Hey everyone, welcome to Simplilearn. Today we will learn the Advanced SQL. In this full course, we will be covering the fundamentals of SQL, how to become a SQL developer, which explains your perfect roadmap to become a SQL developer. Followed by that, we will go through the fundamentals of SQL, which includes the introduction to SQL, SQL installation, ER diagrams, installation of SQL Workbench, and then followed by that, we will dive into the SQL fundamental operations such as create a table, create a database, how to insert records, and data manipulation operations such as delete, insert, etc. And then we will go through the update query, drop query, current date, etc. And followed by that, we will get into some more advanced fundamental operations of SQL such as group by, between operators, like operators, deleting duplicate records, etc. Next, we will dive into the normalization of SQL tables. Then we will learn SQL Joins. Followed by that, we will go through the subqueries in SQL, and next, the most important part of today's session, that is SQL with Python. Followed by that, we will learn SQL injection. To make things more interesting, we have covered the most important SQL interview questions for your upcoming interviews. Now, before we begin, if you are a tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to Simplilearn's YouTube channel, and don't forget to hit that bell icon to never miss an update from Simplilearn. Also, the first topic.
Now let's get started with what is a database. So according to Oracle, a database is an organized collection of structured information or data that is typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. So it is a storage system that has a collection of data. Relational databases store data in the form of tables that can be easily retrieved, managed, and updated. You can organize data into tables, rows, columns, and index it to make it easier to find relevant information. Now talking about some of the popular databases, we have MySQL database, we also have Oracle database, then we have MongoDB, which is a NoSQL database. Next, we have Microsoft SQL Server. Next, we have Apache Cassandra, which is a free and open source NoSQL database. And finally, we have PostgreSQL. Now, let's learn what is SQL. So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use structured query language or SQL for writing and querying data. SQL commands help you to store, process, analyze, and manipulate databases. With this, let's look at what a table is. So this is how a table in a database looks like. So here you can see the name of the table is players. On the top, you can see the column names. So we have the player ID, the player name, the country to which the player belongs to, and we also have the goals scored by each of the players. So these are also known as fields in a database. Here, each row represents a record or a tuple. So you have the player ID, which is 103 here. The name of the player is Daniel. He is from England, and the number of goals he has scored is 7. So you can use SQL commands to query, update, insert records, and do a lot of other tasks. There are mainly 4 types of SQL commands. So first we have data definition language or DDL. So DDL commands change the structure of the table, like creating a table, deleting a table, or altering a table. All the commands of DDL are auto-committed, which means it permanently saves all the changes in the database. We have create, alter, drop, and truncate as DDL commands. Next, we have data manipulation language or DML. So DML commands are used to modify a database. It is responsible for all forms of changes in the database. DML commands are not auto-committed, which means it can't permanently save all the changes in the database. We have select, update, delete, and insert as DML commands. Now select command is also referred to as DQL or data query language. Third, we have data control language or DCL. So DCL commands allow you to control access to data within the database. These DCL commands are normally used to create objects related to user access and also control the distribution of privileges among users. So we have grant and revoke, which are the examples of data control language. Finally, we have something called as transaction control language or TCL. So TCL commands allow the user to manage database transactions. Commit and rollback are example of TCL. Now let's see the basic SQL command structure. So first, we have the select statement. So here you specify the various column names that you want to fetch from the table. We write the table name using the from statement. Next, we have the where clause to filter out our table based on some conditions. So you can see here where condition 1, condition 2 and so on. Then we have the group by clause that takes various column names. So you can write group by column 1, column 2 and so on. Next, we have the having clause to filter out tables based on groups. Finally, we have the order by clause to filter out the result in ascending or descending order. Now talking about the various data types in SQL. So we have exact numeric, which has integer, small int, bit and decimal. Then we have approximate numeric, which are float and real. Then we have some date and time data types such as date, time, timestamp and others. Then we have string data type, which includes char, this varchar and text. Finally, we have binary data types, and binary data types have binary, var binary and image. Now let's see some of the various operators that are present in SQL. So first we have our basic arithmetic operators. So you have addition, the subtraction, multiplication, division and modulus. Then we have some logical operators like all, and, any, or, between, exists and so on. Finally, we have some comparison operators such as equal to, not equal to, this greater than, less than, greater than equal to or less than equal to, not less than or not greater than. Now let me take you to my MySQL workbench where we will learn to write some of the important SQL commands, use different statements, functions, data types and operators that we just learned.
Who is a SQL developer? SQL developer is a person who is accountable in creating and managing huge data assets of a company. In other terms, SQL developer is a person who can develop SQL databases as well as write and test code. Let's understand this with the help of an example. Let's say we want to search a particular product on Amazon website, and Amazon has stored all its data about products in a database. Now we will write the product name in the search bar, and when we click on the search button, it will run a SQL query that fetches all the information about the product and displays us on the website. So this is the basic task done by a SQL developer. Now we will understand the responsibilities of a SQL developer. All databases have a structure and logic behind how data is stored and retrieved. A SQL developer designs the database accordingly for businesses, that is called database modeling. After the database is created and deployed, it's the SQL developer who is responsible for fixing the general issues of the database. SQL developer should be well versed with structured query language to create optimized SQL queries and refines the existing ones to extract information from the database. SQL developers run several diagnostic tests to keep a check on the server and the database. In order to understand how to organize company's data, SQL developers must communicate with technical and non-technical persons from the business, and SQL developer also gathers client requirements and identifies the features that the database owners want. As data is an asset to a company, SQL developers backup and restore data for their clients. They also perform tasks like data management and data migration. That is, if a company has stored all its data on a local storage and now it wants its data to be stored in a cloud storage. So the safe transmission of the data from local storage to cloud storage is known as data migration, and that is done by the SQL developers. After knowing the responsibilities, now we should look for skill set required to be a good SQL developer. One should have a good knowledge of SQL commands, functions, joins and procedures. Let's have a look at few commands such as create, drop, alter and truncate. These commands come under data definition language. We also have insert, update and delete commands. These commands come under data manipulation language. We have grant and revoke commands. These commands come under data control language. We also have commit, rollback and save point commands. These come under transaction control language. These are the basic commands a SQL developer should be familiar with. And a SQL developer may have a little command on any one programming language. You don't have to be expert in programming. All you need is how to interface between application and your database. For example, you are using MySQL and your web application is based on PHP. Then you should know how to connect your application to the database and how to issue queries, how to fetch results and then how to display it to the users. one should have a good understanding of various database management systems such as MySQL, Microsoft Access, Oracle, PostgreSQL, DBase, FoxPro, SQLite, IBM DB2, LibreOffice Base, MariaDB, and Microsoft SQL Server. One should know integration of databases with data visualization software such as Power BI and Tableau, which helps businesses to make better decisions and give you an add-on as a SQL developer. One should develop critical thinking and problem-solving skills to create optimized queries. Now we'll see how a SQL developer is compensated in both United States and India. In the United States, SQL developers draw an average salary of $72,282 per annum. In India, the average salary of a SQL developer is Rs 4,49,532. Now we'll see how a person can become a good SQL developer. For that, one should have a good command on structured query language and know how to interact with database management system and can issue queries to get the desired result. Earning industry-recognized SQL developer certifications such as Microsoft Certified Professional Developer (MCPD) or Oracle PL SQL Developer Certified Associate, which usually require a passing score on an exam. And it's important to accumulate as much practical experience as possible. Start by designing, creating, and querying small databases connected with your hobbies and interests. For example, your favorite music, videos, or your personal finances. This will enable you to gain experience, test your knowledge, and build your project portfolio, which will be highly beneficial when you start applying for your first full-time position. Now we will see some major companies recruiting SQL developers. First we have the multinational financial services corporation American Express, followed by the multinational professional services network Ernst & Young. We also have the messaging company WhatsApp. Then we have the e-commerce giant Amazon, as well as the technology and computer solutions company Dell. Finally, in our list of companies, we have the multinational technology company Google.
So let's understand what an ER diagram is. An entity relationship diagram describes the relationship of entities that needs to be stored in a database. ER diagram is mainly a structural design for the database. It is a framework made using specialized symbols to define the relationship between entities. ER diagrams are created based on the three main components: entities, attributes, and relationships. Let's understand the use of ER diagram with the help of a real-world example. Here, a school needs all its student records to be stored digitally, so they approach an IT company to do so. A person from the company will meet the school authorities, note all their requirements, describe them in the form of ER diagram, and get it cross-checked by the school authorities. As the school authorities approve the ER diagram, the database engineers would carry further implementation. Let's have a view of an ER diagram. The following diagram showcases two entities, student and course, and their relationship. The relationship described between student and course is many-to-many, as a course can be opted by several students and a student can opt for more than one course. Here, student is the entity and it possesses the attributes, that is, student ID, student name, and student age. And the course entity has attributes such as course ID and course name. Now we have an understanding of ER diagram. Let us see why it has been so popular. The logical structure of the database provided by ER diagram communicates the landscape of business to different teams in the company, which is eventually needed to support the business. ER diagram is a GUI representation of the logical structure of a database, which gives a better understanding of the information to be stored in a database. Database designers can use ER diagrams as a blueprint, which reduces complexity and helps them save time to build databases quickly. ER diagrams helps you identify the entities that exist in a system and the relationships between those entities. After knowing its uses, now we should get familiar with the symbols used in ER diagram. The rectangle symbol represents the entities, oval symbol represents attributes, a rectangle embedded in a rectangle represents a weak entity, a dashed oval represents a derived attribute, A diamond symbol represents a relationship among entities. Double oval symbol represents multi-valued attributes. Now we should dive in and learn about the components of ER diagram. There are three main components of ER diagram: entity, attribute, and relationship. Entities have weak entity. Attributes are further classified into key attribute, composite attribute, multi-valued attribute, and derived attribute. Relationships are also classified into one-to-one relationships, one-to-many relationships, many-to-one relationships, and many-to-many relationships. Let's understand these components of ER diagram, starting with entities. An entity can be either a living or a non-living component. An entity is showcased as a rectangle in an ER diagram. Let's understand this with the help of an ER diagram. Here, both student and course are in rectangular shape and are called entities, and they represent their relationship study in a diamond shape. Let's transition to weak entity. An entity that makes reliance over another entity is called a weak entity. The weak entity is showcased as a double rectangle in ER diagram. In the example below, the school is a strong entity because it has a primary key attribute, school number. Unlike the school, the classroom is a weak entity because it does not have any primary key, and the room number attribute here acts only as a discriminator and not a primary key. Now, let us know about attributes. Attribute. An attribute exhibits the properties of an entity. An attribute is illustrated with an oval shape in an ER diagram. In the example below, student is an entity and the properties of student such as address, age, name, and roll number are called its attributes. Let's see our first classification under attribute, that is key attribute. The key attribute uniquely identifies an entity from an entity set. The text of a key attribute is underlined. In the example below, we have a student entity and it has attributes name, address, roll number, and age. But here, roll number can uniquely identify a student from a set of students. That's why it is termed as a key attribute. Now, we will see composite attribute. An attribute that is composed of several other attributes is known as a composite attribute. An oval showcases the composite attribute, and the composite attribute oval is further connected with other ovals. In the example below, we can see an attribute name, which can have further subparts such as first name, middle name, and last name. These attributes with further classification is known as composite attribute. Now, let's have a look at multi-valued attribute. An attribute that can possess more than one value are called multi-valued attributes. These are represented as double oval shape. In the example below, the student entity has attributes phone number, roll number, name, and age. Out of these attributes, phone number can have more than one entry, and the attribute with more than one value is called multi-valued attribute. Let's see derived attribute. An attribute that can be derived from other attributes of the entity is known as a derived attribute. In the ER diagram, the derived attribute is represented by dashed oval, and in the example below, student entity has both date of birth and age as attributes. Here, age is a derived attribute as it can be derived by subtracting current date from the student date of birth. Now, after knowing attributes, let's understand relationship in ER diagram. A relationship is showcased by the diamond shape in the ER diagram. It depicts the relationship between two entities. In the below example, student, study, course. Here, both student and course are entities and study is the relationship between them. Now, let's go through the type of relationship. First is one-to-one relationship. When a single element of an entity is associated with a single element of another entity, this is called one-to-one relationship. In the example below, we have student and identification card as entities. We can see a student has only one identification card and an identification card is given to one student. It represents a one-to-one relationship. Let's see the second one, one-to-many relationship. When a single element of an entity is associated with more than one element of another entity is called one-to-many relationship. In the below example, A customer can place many orders, but a particular order cannot be placed by many customers. Now, we will have a look at many-to-one relationship. When more than one element of an entity is related to a single element of another entity, it is called many-to-one relationship. For example, students have to opt for a single course, but a course can be opted by a number of students. Let's see many-to-many relationship. When more than one element of an entity is associated with more than one element of another entity is called many-to-many relationship. For example, an employee can be assigned to many projects, and many employees can be assigned to a particular project. Now, after having an understanding of ER diagram, let us know the points to keep in mind while creating the ER diagram. First, identify all the entities in the system, embed all the entities in a rectangular shape and label them appropriately. This could be a customer, a manager, an order, an invoice, a schedule, etc. Identify relationships between entities and connect them using a diamond in the middle illustrating the relationship. Do not connect relationships. Connect attributes with entities and label them appropriately, and the attributes should be in oval shape. Assure that each entity only appears a single time, and eradicate any redundant entities or relationships in the ER diagram.
Firstly, we will visit the official Oracle website, that is mysql.com, and now we'll move to the downloads page. Now scroll down and click on MySQL GPL downloads. Now under community downloads, click on MySQL installer for Windows. The current versions are available to download. I will choose this installer and click the download button. Now here just click on no thanks, just start my download. Once the installer has downloaded, open it. You may be prompted for permission. Click yes. This opens the installer. You will be asked to choose the setup type. We will go with custom. Click next. Now you have to select the products you want to install. We will install only the MySQL Server, MySQL Shell, and the MySQL Workbench. Expand MySQL servers by double clicking on it. And choose the version you want to install and click on this arrow. Now you have to do the same thing for applications. Expand applications and choose the MySQL Workbench version you want to install and click on the arrow. And we'll do the same thing for MySQL Shell. We'll choose the latest version, click on the arrow. So these are the products that have to be installed in a system. Now we'll click next. I'll click execute to download and install the server. This may take a while depending on your internet speed. As the download is completed, click next. Now you'll see the product configuration. Click next. Now we'll configure our SQL Server instance. Here we will go with the default settings and click next. And under authentication, select use strong password encryption for authentication, which is recommended, and click on next. Now here set the password for your root user. By the way, root is the default user. This user will have access to everything. I will set my password. Now I will click on next. And here also we'll keep the default settings and click on next. Now to apply configuration, we will execute the process. Once all the configuration steps are complete, click finish. Now you will see the installation is complete. It will launch MySQL Workbench and MySQL Shell after clicking on finish. Now the Shell and Workbench has started. Now we'll connect by clicking on the root user. It will ask for a password. Enter the password and it will connect successfully. The workbench has started. Now we'll just connect the server. So first we'll open command prompt. Now we'll reach the path where MySQL files are present. We'll go into this PC, local disk C, program files, MySQL, MySQL Server 8.0, bin. And now we'll copy this path. Now we'll open the command prompt and write a command cd space and paste the link and press enter. Now we'll write another command that will be MySQL -u space root -p and press enter. Now it will ask for your password. Just enter the password and press enter. Now the server has started and now we'll see some commands in MySQL Workbench. First we will open MySQL Workbench. Now we'll click on the local instance MySQL 80 and enter the password to connect to the local host. Now the MySQL Workbench has started. Now we will see some commands. The first command we will see is show databases. Show databases semicolon, and now we will select the whole command and click on this execute button, and here we will see the result in the result grid. These are the databases that are stored already in the database. Now there are 4 databases, that is Information Schema, MySQL, Performance Schema and SYS. Now we will select one of the database. We will use MySQL. Now we have selected the MySQL database, and now in this database we will see which tables are stored in this MySQL database. To see that, we will run a command show tables. We'll select the command and click on the execute button. These are the tables that are stored in this MySQL database, that is columns underscore prive, component, DB and much more. So now we will see what components are stored in these tables. So we'll select one table, that would be component, and we'll see what are the columns and what values are stored in it. To see that, we will run a command select star from components. Now we have run this command, and what we will see is that the table has 3 columns, that is component ID, component group ID, component URN, but there are no values. There are null values in the table. Now we will write a command to create a table. Now we will create a table in the MySQL database. For creating the table, the syntax is create table, table name, and then we will start with the round brackets, and then we will write the column name and then what column it is, whether it's int or varchar. So now we will write the command create table, and we will name the table as persons, and we will start the round bracket and the first column would be person ID. Okay, and what type it would be? It would be int type, comma, and the next column would be first name, and its type would be varchar. And the next column, it would be the last name, same type varchar, and the last column we would be write as city. Now we'll run this command and see that the table has been created. Create table persons, person ID, first name varchar, city varchar. So yeah, now we'll insert the values. First we'll see what components are there in this table. Select star from persons. Now we'll execute this command. Now what would we see is that the table is created and all the columns are there, but there are no values. So we'll insert the values and then see the table. So to do that, we will run the commands that would be insert into table name, that is persons, then values, then we'll start the round bracket and write the values according to the column names. So I will write 1 as the person ID, then comma, space, and then I will write first name, that would be Gautam, comma, last name, that would be Gambhir, comma, city, I would write Delhi, and we have to put these varchar into commas. Gautam, not an inverted commas, only single commas you can put it. Now we'll run this command. Yeah, it's been inserted into the table persons. So first we will see whether it's inserted or not. Select star from persons, semicolon. Yeah, we can see the result. Our first row has been inserted. Now we'll insert some more rows and then we'll some other commands. So we'll copy this, paste here, and just change the values. Person ID 2. Now we will insert Virat. Kohli, and he's also from Delhi, so it will let it remain the same. We'll execute this command. It's also been inserted into the table, and we will write more commands. Rohit, Sharma, Mumbai, and one more row, that would be for Hardik Pandya. We will execute this command. Now we have inserted 4 rows into the table. I will write a command to see whether 4 rows are inserted or not. Now we'll see another command to get out the result with a condition. Let's do that. Select star from persons, and what condition we should put would be we would obtain the 2 rows with the persons living in the city Delhi. So we will write the command select star from persons where city equal to Delhi. Semicolon, and we would run this command, and what would get is the 2 rows with the persons living in the city Delhi, that is Gautam and Virat. Now we will see a command to obtain only a column from the table. That would be select column name, that we will select first name. First name from table name, that is persons. Semicolon, and now we'll run this command. So what we have got is that is the column first name from the table persons.
So to install SQL Server in Windows, you will need 2 different software packages. The first one being the SQL Server itself, and the second one is a SQL Server management tool. Let's download these. Let's go back to Google. Now type in SQL Server download. Now you can choose the first option, SQL Server downloads from Microsoft. Ensure that you are choosing the software from the service provider, which is Microsoft itself, not the third-party software files. Now, if you scroll down, you can see 2 different versions of the SQL Server. The first one being the developer and the second one being the Express. If you are a learner, then I would recommend you to go with the Express version because it has more features than the developer version, and also it is open source. Now let's go with the Express version. Download now. The software file should be downloaded shortly. So the Express exe file has been downloaded successfully. Click on it and it should be running. Now it is asking for the admin permission. Give the admin rights and then you should be good to go. Once you provide the admin rights, the SQL Server installation will begin. So here you can see the window or the dialog box, which will give you 3 different options: basic, custom, and download media. I would recommend you to go with the basic version. Select that and now read all the terms and agreements. Post that, accept, and check the location where the SQL Server is being installed. If you're comfortable with it, you can click on install, or if you want to change, go to browse and select your folder. I'm comfortable with this particular location, which is program files, so I'll click on install. It should be installing in a while. There you go, the download is successful. The installation phase might take a little while. So the download has been successfully done and the installation has also completed successfully. Now only the first phase of the installation process is done, right? The SQL Server is done, but we need another tool, which is SSMS or SQL Server Management Studio. That you can get right over here. Just click on install SSMB and it will redirect you to a different web page. Just click on the web page you want to go or the web browser you want to choose. And that is the web page that I was talking about. Scroll a little towards down, and you can see the option saying free download for SQL Server Management Studio version 19.0.2. So you might be having the latest versions in the future as well. Let's go with the current version. Click on it, and there you go. The system setup is being downloaded here. It's 629 MB, so it might take a while. There you go. The Microsoft SQL Server Management Studio has already downloaded and is being installed right now. So now you can see there is one bottleneck. You need to restart the system, or you can close and start it anyways. But let's choose the restart option. So after the restart, the SQL Server Management Studio is downloading a few more packages and the installation should be done in a while. There you go. The installation has been complete and you have the Server Management Studio ready to execute. Open that. So here you have the server type, server name and authentication. If you want to change them, you can, but I'm comfortable with these, and just press connect and you should be good to go and get started with your query editor. Then you can start writing your queries on your SQL Server. So now we're on the Ubuntu operating system. Let's quickly start our terminal. The shortcut key for that is Ctrl-Alt-D. So now we have the terminal opened, so we might have to run a couple of commands. So the first one would be sudo apt upgrade or update. It will ask for the host password. Now you have the update. So usually what happens is when you try with the default method or when you try with the default codes or the commands, you might miss a couple of updates or two or files, right? So what happens when you try with the default codes or default commands is you might miss a file or two. So when you update the Ubuntu, you will get the missing files as well. Now, if you find I've got all the updates, but in case if you find some files are missing, you might receive a message from Ubuntu saying can't update or not fetched, right? In that case, you can try upgrade command. Even then, if you miss a couple of files, there is another similar command which says sudo apt full upgrade. You should also try that as well. So basically what happens is you might have one single command which says sudo apt install MySQL, right? So that particular command will run, but unfortunately sometimes it misses to face complete get. It misses to get all the files. So to avoid that, we will try the brute force method, which will get all the files, all the updates on all the executable files you require to run MySQL in Ubuntu, right? Just a couple of minutes, yes. So similar to upgrade, we have full upgrade. It's done. And in case if you wanted to remove some unnecessary files, you have a command for that as well. So let's take a look at that. So the sudo apt auto remove will remove any of those older packages which you no longer need after the complete full upgrade. Let's run that. There you go. So now we are done with the Ubuntu update. Let's clear the screen by pressing Ctrl+C shortcut key. The shortcut key Ctrl-L has been pressed and the screen has been cleared now. Now we are good to go with our SQL installation command, which is sudo apt get install MySQL. Yeah, so again we face some issues regarding the installation. So this means that we might have some files which we might not need related to MySQL. So my suggestion would be to eliminate those particular files using the sudo apt get remove purge MySQL server, MySQL client, MySQL common, yes. That is why. So we're trying to remove any of the existing files. So let's try to get auto remove and auto clean. Again, the update. There you go. We have the update, and now we shall try to install the MySQL server with the following command. But the difference is we are trying to install it with yes. That is -y, providing the permissions. There you go. You can see MySQL is running as PID 6045. Anyways, let's also check the status once the update is done. There you go. Let's quickly check the status by using sudo system control status MySQL. And there you go. It says the server is operational and the main PID is 6240. Let's quickly clear the screen using Control L key combination. And now let's start SQL by using the command sudo MySQL. They should start MySQL for you. There you go. That's how you install MySQL in Ubuntu operating system.
First, let's understand what is MySQL Workbench or MySQL Workbench. So, MySQL Workbench is a graphical tool for working with MySQL servers and databases. You may use the MySQL Workbench for server administration, for creating entity relationship diagrams, and for running SQL queries. MySQL Server is cross-platform, meaning that it can run on a number of different platforms such as Windows, Linux, macOS, and others. Now, we will see the MySQL Workbench functionalities. So first, we have SQL development or SQL development. MySQL Workbench enables you to create and manage connections to database servers. Along with enabling you to configure connection parameters, MySQL Workbench provides the capability to execute SQL queries on the database connections using the built-in SQL editor. Next, we have data modeling. The data modeling functionality of MySQL allows you to create models of your database schema graphically, reverse and forward engineer between a schema and a live database, and edit all aspects of your database using the comprehensive table editor. The table editor provides easy to use functionalities for editing tables, columns, indexes, triggers, partitioning, options, inserts, and privileges, routines, as well as views. The third functionality is server administration. It enables you to administer MySQL server instances by administering users, performing backup and recovery, inspecting audit data, viewing database health, and monitoring the MySQL server performance. Fourth, we have data migration. Now, this functionality of MySQL Workbench allows you to migrate from Microsoft SQL Server, Microsoft Access DB, Sybase, SQLite, SQL Anywhere, PostgreSQL, and other relational database management system tables, objects, and data to MySQL. Migration also supports migrating from earlier versions of MySQL to the latest releases. And finally, we have MySQL Enterprise support. The MySQL Workbench has support for enterprise products such as MySQL Enterprise Backup, MySQL Firewall, and MySQL Audit. Now, let's have a look at the MySQL Workbench editions available to us. First, we have the Community Edition. So this Workbench edition is open sourced and can be downloaded free of cost. It came under the GPL license and is supported by a huge community of developers. Then we have the Standard Edition of MySQL Workbench. The standard edition of MySQL Workbench is the commercial edition that provides the capability to deliver high performance and scalable online transaction processing, that is popularly known as OLTP applications. So the last edition, that is the enterprise edition we have, is the commercial edition that includes a set of advanced features, management tools and technical support to achieve the highest scalability, security, reliability and uptime. Now this edition also reduces the risk, cost, complexity in the development, deployment and managing MySQL applications. Now with this theoretical knowledge, let's go ahead and see how to download and install MySQL Workbench on Windows. Okay, so I've searched for MySQL download on Google, and let me go ahead and click on the first link, which is from www.mysql.com. This will lead us to the downloads page. I've opened in a new tab, and in the downloads section, if I scroll down, you'll find something called as MySQL Community GPL downloads. This GPL stands for General Public License, which is for free. So we will install the community edition of MySQL Workbench. If I click on this, it will take you to another page where you have all the MySQL community downloads, and here you will find something called as MySQL installer for Windows. I'll click on this, and here you can see we have the MySQL installer 8.0 version. Please go ahead and install from this link. You can just click on download. Now we already have a video published on how to install MySQL on Windows, so please click on the above link to know the steps for installation. Let me show you the video. So this is the video I'm talking about, which is already published on our channel, that is Install MySQL Server and Workbench on Windows. Alright, now once the installation is complete, go ahead and launch the MySQL Workbench. So here in the search bar, if I just type MySQL, you can see here I have the MySQL Workbench 8.0 version installed. I'll open this. So this is how the interface looks like. It says welcome to MySQL Workbench. It tells you what MySQL is, and here I have already created a MySQL connection. Now let me show you how to create a new connection. I'll just click on this plus button and it will open setup new connection. Now here you can give a connection name. Let me type my name as MySQL_demo. Now the connection method, you can keep it as standard TCP IP. Now the host name will be the default, port number should be 3306. The username, I have kept it as root because this is what I gave while installing MySQL. Now if you want, you can also set the password. If I click on this, you can enter the password. I'll suggest you to give a strong password. I'll click on OK, and let's try to test the connection. You can see here it says successfully made the MySQL connection. You have the host, the port number, user, and it says a successful MySQL connection was made with the parameters defined with this connection. Just click on OK, and I'll click on OK again. You can see here we have made a new connection which says MySQL demo. I'll click on this and it will open my query editor. So let me open my MySQL Workbench, where we will perform some hands-on demonstrations and look at how to use MySQL functions, write different commands, and we'll see the results. So here on the search bar, I'll type MySQL. So it says MySQL Workbench 8.0 version. Let me open it. Okay, you can see I have a local instance connection. I'll connect to this and I'll enter the password. So this is how my MySQL Workbench interface looks like. Let me just drag this to the top. Okay. Now the white workspace that you see here is called the SQL Visual Editor, and below you will have the result pane and the history output window. I'll show you once I run a query. And on the right hand side you can see we have a help pane or a help window. So if you want to check the documentation or the usage of a certain command, you can just type here and it will give you the documentation. As you can see, I just chose one command, that is select here, and it has returned me the syntax and what select statement really does. Alright, and here on the left side you can see we have something called administration and schemas. These are the different databases that I've already created. So for this demo we will start by creating a new database. So the command I'll write is create database. If I hit tab, it will autocomplete, and the database name I'll give is SQL Workbench. I'll give a semicolon. I'll select this and you see this thunder button. If I click on this, it will execute my query. Okay, you can see here it has returned me one row affected and my query was successful. Alright, now to move inside this database, I'll use the command called use SQL_workbench, which is my database name. Let's run this. You can see we have successfully entered into our database. Now we can create any tables, perform any calculations, operations, data manipulations, retrieve data, fetch data, insert data, and a lot of other operations. Now under the schema, let me just refresh this so that you can see our new database. This is our database. You can see SQL Workbench. Currently we haven't created any tables. If I create a table, it will show here. You can see here views, stored procedures, functions, and other things. So first let's get started by looking at some of the numeric functions that are available in MySQL. So I am giving a comment by typing shift and then my comment, that is numeric functions. First and foremost, we'll see how to use the absolute function in MySQL. So for using the absolute function, I'll write select ABS, and inside this ABS function I'll pass in a value, let's say 22. Now if I run this, it gives me a result that is 22, since the absolute value of 22 is 22, because 22 we have passed in as a positive value. Now let's say I'll pass in minus 22 and let's run it. There you go. You can see here my absolute function has dropped the negative sign and has returned me a positive value, which is 22. You can try for other values. Let's say I'll select minus 50. If I run this, it returns me 50. Alright. Next, we'll see how the mod function works. So the mod function returns the remainder of a division. So if I write select mod and I want to divide 10 by 4. Let's run this and see the result. You can see it has returned me 2, because the remainder for 10 divided by 4 is 2. You can also give an alias name to this. I'll write as remainder. The reason why I'm giving an alias name is because the result we have got, if you see the column, this is not very readable. Now if I run this, you can see the difference. There you go. Now the output is much readable than the previous one. Okay, so let's say I want to find the mod of another division 15,3 as remainder again. I'll run it again. You can see 15 divided by 3, the remainder is 0. Let's try for one more. Let's say 50.6 divided by 2. You can already guess the result. It should be 0.6. There you go. You can see this is my remainder. Now as I said, the below window is called the history output window or the pane, and this is called the query result pane, which is part of the MySQL Workbench. Let me just drag this a bit. Okay. Now moving on to the next numeric function, we will explore the power function. Now suppose I write select power 4 raised to 2. Let's see the result. I'll run it. It gives me 16, which is correct. Let's see. I'll write select power 10 raised to 3. You can already think of the result. It should be 1000. Okay. Now, like how you use the power function, similarly you can use the square root function. In MySQL, the square root function is written as sqrt. So you can get the square root of a number by using the sqrt function. Let's say I want to find the square root of 4. If I run this, it gives me 2, which is the square root of 4. I'll edit here itself. Let's say I want to find the square root of 144. If I run this, it gives me 12, which is the square root of 144. Now moving ahead, let's say you want to find the greatest number within a range of numbers. You can use the greatest function that is available in MySQL. I'll write select greatest. I'll give a range of numbers. Let's say 2, 5, 18, 6, and let's say 12. I'll give a semicolon and let me run it. It returns me 18 because 18 is the largest or the greatest number in my range of numbers. Similarly, you can also find the least number. For that, you can use the least function. This will return me the minimum number present in my range of numbers. In this case, it is 2. Alright. There's another function that is available in MySQL is truncate. So the truncate function truncates a number to the specified number of decimal places. So suppose I write select truncate 22.897, 1. Let's see the output. Okay, you can see here. So the truncate function has returned us 22.8 and it has truncated the rest of the decimal places. I want to truncate up to 2 decimal places. Let's see the result again. You can see here it has given us 22.89. Next, we have another function called round. So the round function in MySQL is used to round a number to a specified number of decimal places. If no specified number of decimal places is provided to roundoff function, the roundoff function rounds the number to the nearest integer. So let's see a few examples. Suppose I want to round the value 22.897. This time I am not passing the specified number of decimal places. We'll see the result. It has returned me 23, which is the next highest integer. Suppose you want to round it to 2 decimal places. You can give a comma and then say 2. I'll run it. It has given us 22.90. So this 89 it has converted to 90. Similarly, if you want to round the number to 1 decimal place, it will give you 22.9. Alright. Now, let's create a students table and store it in our MySQL Workbench. So I'll just give a comment called student table or students table. Alright. So the way to create a table in a database in MySQL Workbench is you write create table followed by the table name that you want. In this case, I'm going to create a students table. Then you start with parenthesis and give the columns that you want in your table. So first I want the student ID. You can think of this as the student roll number. Give a space and then give the data type of the column. Now student ID should ideally be of type integer. I'm assigning this as primary key. So the primary key will uniquely identify each record in a table. and it cannot have any duplicate values. So ideally, if you think, all the students in a school will have a unique roll number. No two students will have the same roll number. Next column I want is the student name. Now the name is of type varchar, and I'll give the length as, let's say, 25. Then I want the age of the student. Age is also of type integer, and I'll write in the same line. Then I need the gender. Gender of the student should be of type character, and the size I'll give as 1. Then we have DOA, which stands for date of admission, and it is of type date. Then we have the city to which the student belongs to. Then city is also of type varchar. Alright, you close the bracket and give a semicolon. Let's run this. There you go. Here you can see in the history window it says the table was created successfully. Now let's just refresh this again so that you can see the table. Here under MySQL Workbench database, under tables, you can see we have a students table. Let me expand this further so that you can see the columns that we have. There you go. We have the student ID, the student name, age, gender, date of admission, and the city. Okay. Now it's time to insert a few records to this table. For that, you need to write the insert statement. Now I'm going to open a notepad where I have already written the insert statement. So let me just copy paste it here. Okay, so here on my notepad I have my insert statement already written. I'll just copy this and I'll paste it on my workspace. Okay, if I go to the top, you can see this is how my insert into command look like. You have insert into followed by the table name, which is students. Then you have the values keyword, and we have the set of records. So the first value represents the student ID or the roll number. Then you have the student's name, you have the age, you have the gender, then we have the date of admission, and then we have the city to which the student belongs to. Alright. Now let me go ahead and run my insert query. I'll just select everything and I'll hit on execute. You can see here we have successfully inserted 20 rows of information to our table. Now if you want to check all the records in a table, the SQL command is select star from table name, that is students. If I run this, this is my output. You can see we have the student ID, the student name, age, gender, date of admission, and city. If I scroll down, there are total 20 rows of information in my table. Now the star represents you want to select all the columns in the students table. Suppose you want to return specific columns from the table, you can mention that in the select statement itself. Suppose I want to select the student name, the age of the student, and the city to which the student belongs to. So I will write select stu underscore name, which is my column name, comma, the age, comma, the city from my table name, that is students. Let's run it. You can see the output. We have only 3 columns displayed in the result. Okay, now let's see how to use the where clause in SQL or MySQL. So the where clause helps you filter specific records based on certain condition or conditions. Suppose I want to see the students who are from Pune. So I want to display only the records of students who are from Pune city. So the way to do is I'll write select star from students where city equal to Pune. Now this Pune is a character type, so you need to mention it within single quotes. Let's run it. There you go. In the output you can see there are total 4 students who are from Pune. You have Joseph, Anubhav, Akshay and Anand. Alright. Now let's say you want to filter only those students who are from Miami and their gender is male. Again, you are going to use the where clause, and along with the where clause we will use the AND operator. So I'll write select star from students where city equal to, I'll say Miami. This Miami should be within quotes. I'll use my AND operator and then write the gender should be equal to M or male. Again, M should be within single quotes. I'll give a semicolon and let's run it. You can see here we have Vipul, Ishan, Tanishq and Amrit who are from Miami city and their gender is male. Cool. Now moving ahead, suppose you want to know the students who are either from city Boston or Chicago. In that case, you are going to use an OR operator. I'll just copy this SQL command and I'll paste it here and I'll edit in the same query. So this time we want the students who are from city Boston or Chicago. So here instead of Miami I'll write Boston. I'll use an OR clause or an OR operator, and instead of gender equal to male I'll again write or city equal to Chicago. Let us run the SQL query and see what we have. So there are total 6 students who are either from city Chicago or from Boston. We also have a female student, Eliana. Alright. Now moving further, let's say you want to display the records of the students who belong to any city rather than Chicago. In that case, you are going to use the NOT operator. So I'll write select star from students where not city equal to Chicago. Let's run it and see the result. Alright, you can see total we have returned 17 rows of information, which means there are total 17 students who belong to other cities apart from Chicago. If you see the result, you won't find any student who is from Chicago city. Okay. Now there's another important feature of MySQL where you can group certain rows of information based on a particular column or columns. So let's see how to use group by in MySQL. I'll give a comment called group by. Now in this group by clause, we are going to find the total number of students present in each city. So the way to do is I'll write select. I want to select this city and then I'm going to use the count function. This is an inbuilt MySQL function. I'm going to count the student IDs. I'll give an alias as total students from my table, that is students. Then I'm going to group my result based on each city. Let's run this and see the output. There you go. You can see here. So our table has total 6 cities. You have Pune, New York, Miami, Chicago, Detroit and Boston. And here on the right hand side you have the total students that we just created using an alias name. and this total students column has the total number of students from each city. So if you see here, New York has 4 students, Pune has 4 students, in Miami, Chicago we have 4 and 3 students, and in Detroit we have 2 students respectively. Alright, the next clause we are going to see is having. Now having and where are kind of similar, but there are certain differences. Now for our example, we are going to find the cities where the total number of students are more than 3. If you see the results pane, so we have Pune, we have New York and Miami as the cities where there are more than 3 students. So let me show you how to return these 3 records. So I'll write select city, comma, I'll count the students using the count function, and I'll pass my column as student ID, and I'll give an alias as total students from my table, that is students. I'll use the group by clause, group by city, and then I'm going to use having the count of student ID greater than 3. Let me run it and show you the result. There you go. As expected, we have Pune, New York and Miami where the total number of students are more than 3. Let's see how the order by clause works. So the order by clause is used to filter the records based on a particular order in ascending or descending order. So suppose, see, I write select star from students, and then I'll write order by, let's say, city. Let me show you the result first. Okay, you can see the city column has been ordered in alphabetical order. So first the cities start with B, then we have C, D, M, and then we have N and P. What if I want to order the result in descending order? So again, it will alphabetically sort my result in descending order of city. So on the top we have Pune, because alphabetically in descending order Pune starts with P, so it appears on the top. Then we have New York, followed by Miami, Detroit, Chicago and Boston. Now it's time to explore some string functions in MySQL. So I have given a comment, string functions. First, let's say you want to convert a certain string into uppercase. So I can write select. The function I'll use is upper, and within this function you can pass in the string. Let's say I'll write India. If you want, you can give an alias name as, let's say, uppercase. I'll give a semicolon and let's run it. There you go. So my input was in sentence case, and using the upper function we have converted everything into uppercase. Similarly, let me just copy this and I'll show you. If you want to convert a string into a lowercase, you can use the lower function. I'll run this. You can see the result. Everything is in lowercase now. Of course, I need to change the alias name to lowercase. Now instead of using lower as the function, there is another function that MySQL provides, which is called the L case. So I'll just edit this and write L case, and let's say I'll write India in uppercase. Let's run it. It returns me the same result. Cool. Now moving on, let's say you want to find the length of a string. You can use the character length function. I'll write select, use the function character length, and I'm again going to pass in my string as India, as, let's say, total length. Let's run it. This time I'm going to hit Control Enter to run my SQL command. There you go. It has given us the right result, which is 5, because India has 5 characters in it. Now these functions you can also apply on a table. Now let me show you how to do it. Let's say we already have the students table and you want to find the length of each of the student names. So here you can pass stu_name and you can give the same alias name, let's say total length, and then you can write from table name, that is students. If I run this, you can see the output. It has given me total 20 rows of information. It is not readable actually. Let me also display the student names so that we can compare their length. Alright, I'll run this again and now you can see the result. So Joseph has 6 characters, Nilesh has 6, Vipul has 5, Anubhav has 7. Similarly, if you see, Akshay has 6, Tanishq has 7, Raghav has 6, Cummins has 7, Rabada has 6, so on and so forth. Now instead of using this character length, you can also use the function char length. It will work the same way. Let's see the result. There you go. It has given us the same result. You can either use character length or char length. Now there's another very interesting function called concat. So the concat function adds 2 or more expressions together. Let's say I'll write select. I'll use the function concatenate. The function is actually concat, and I'm going to pass in my string values. Let's say India is in Asia. Let's run this and see our result. You can see here it has concatenated everything. Let us make it more readable. I'll give a space in between so that you can read it clearly. Now this is much more readable. India is in Asia, and if you want you can give an alias name as well, as let's say merged. There you go. Now the same concat operation you can also perform on a table. I'm going to use the same students table. Let's say I want to return the student ID followed by the student name, and then I am going to merge the student name followed by a space followed by the age of the student, and I can give an alias as, let's say, name_age from my table, that is students. Let's see how this works. Okay, you see here the result is very clear. We have the student ID, the student name, and the concatenated column that we created, which was name_age, where we have the student name with a space followed by the age of the student. If I scroll down, you can see the rest of the results. Cool. Now moving ahead, let's see how the reverse function works in MySQL. So the MySQL reverse function returns a string with the characters printed in reverse order. So suppose I write select reverse. I'll use the same string again. Let's say I have India. Let's run it. You will see all the characters printed in reverse order. Again, you can perform the same operation on a table as well. Let's say I'll write select reverse and I'll pass in the column as student name from my table, that is students. Let's run it. It gives you 20 students and all the names have been printed in reverse order. Okay. Now let's see what the replace function does. So the replace function replaces all occurrences of a substring within a string within a new substring. So let me show you what I mean. I'll write select replace. I'll pass in my input string, which is, let's say, orange is a vegetable, which is ideally incorrect. I'm purposely writing this so that I can replace the word vegetable with fruit. Okay, so what this replace function does is it is going to find where my word vegetable is within the string, my input string, and it is going to replace my word vegetable with fruit. Let's run it and see the output. There you go. Now this is correct, which is orange is a fruit. Alright. Now MySQL also provides some trim functions. You can use the left trim, right trim, and just the trim function. So let me show you how this left trim works. Left trim or L trim removes the leading space characters from a string passed as an argument. So say I write select, I'll use the left trim function, which is L trim, and then I'm going to purposely give a few spaces in the beginning of the string. I'll give a word, let's say India, and then I'll give some space after the word India, and see how the L trim works. If I run this, it gives me India, which is fair enough. But before that, let's first find the length of my string. So I'll use my length function here, and within this function I am going to find the length of my string, which has India along with some leading and trailing spaces. I'll paste this here, give a semicolon, and I'll run it. Okay, so the entire string is 17 characters long, or the length of the string is 17. Now say I use ltrim on my same string, what it returns me is India, and if I run length over it, you can see the difference, as in you can see how many spaces were deleted from the left of the string. You can see here, now it says 17, and I'm going to use ltrim. Let's see the difference. It gives me 12. The reason being it has deleted 5 spaces from the left. You can count it, 1, 2, 3, 4, and 5. So 17 minus 5 is 12, which is correct. Similarly, you can use the rtrim function, which removes the trailing spaces from a string. Trailing spaces are these spaces. When you use left trim, it deletes the leading spaces, which is this. Now let me just replace ltrim with rtrim, which stands for right trim, and see the result. So the length is 10 now. The reason being it has deleted 7 spaces from the right of the string. If you can count it, 1, 2, 3, 4, 5, 6, and 7. Cool. You can also use the trim function, which will delete both the leading and the trailing spaces. So here, if I just write trim and I'll run it, it gives me 5, because India is total 5 characters long, and it has deleted all the leading and the trailing spaces. Alright. There's also a function called position in MySQL. The position function returns the position of the first occurrence of a substring in a string. So if the substring is not found with the original string, the function will return 0. So let's say I'll write select position. I want to find where fruit is in my string, that is orange is a fruit. I'll give an alias as name. There's some error here. This should be within double quotes. Now let's run it and see the result. Okay, it says at the 13th place or at the 13th position we have the word fruit in our string, which is orange is a fruit. Now the final function we are going to see is called ASCII. So the ASCII function returns the ASCII value for a specific character. Let's say I write select ASCII of the letter small a. If I run this, it will give me the ASCII value, which is 97. Let's say you want to find the ASCII value of 4. Let's see the result. It gives me 52. Alright. So that brings us to the end of the demo session on MySQL Workbench. Let me go to the top and show you the things that we covered. So first of all, we created a new database called MySQL Workbench, which you could see it here under schemas. There was a database created called MySQL Workbench. Then we entered into the database using the command use MySQL Workbench or SQL Workbench. We explored a few numeric functions where we saw how to use absolute, mod, power, square root, least, greatest, truncate, round, and then we created a table called students. We inserted some 20 rows of information of different students and their age, date of admission, city. We saw how to use where clause, how to use the and or operator. We used group by to group our records based on certain conditions. We also used having. We used order by, and then we look at a few string functions such as lower, upper, concat, character length, reverse, replace, ASCII, and position.
If you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who elects to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's Data Engineering Postgraduate Program from Purdue University in collaboration with IBM. The link in the description box and the pinned comment should take you to the program being offered. Now, let's quickly look at the syntax we need to create a table in SQL. So we will be using the keyword create to let the SQL know that we're trying to create an element which can be a table or database. Followed by that, we will be using the table keyword to explain the SQL that we are trying to create a table here. Followed by that, a customized table name. Then inside that, we will be starting with the parameters, which can be the elements or columns which are present in your table. Column 1 or parameter 1, its data type and constraint. So what is a constraint? We will be understanding about the data type and constraint when we're in the practical mode. Let's quickly try to understand the syntax over here. So these are the things: create keyword, table name, which is a customized or user-defined name for the table. Then the parameters involved in the table, that is the columns, column 1, 2, 3, data type and constraint. Followed by that, close the bracket and use the semicolon to explain SQL that it is the end of the code. Now let's get back to the SQL Workbench. So we logged into the SQL Workbench. So now we have logged into the SQL Workbench. Now previously we had created a database, that is Simplilearn database. Now we will try to create the table in the same database. Now we will be using the create keyword, table. Now table name, which can be anything. Let's try to create a student database or employee database. You can see that I'm using capitals for keywords and smalls for the user-defined ones, just to make it clear for the reader to understand what is what. If it is in capital, it is a keyword. If it is in small, it is a user-defined name. Now, emp id, which is an integer type, and then the constraint, not null. So remember the data type and constraints that we discussed earlier. So this is it. So you're trying to tell the SQL that the ID, what you're creating, is of integer data type, and since this can be a primary keyword, it should not be null, right? Now the next one, employee name. which can be character data type. So let's keep it as char or character, and let's give the size as 150. Now the next one. Okay, I forgot to give the constraint. Default. Okay, let's not keep it as default null. It cannot be null as well. Then comes the address, which can again be character, and let's give it as 500 as the size, and followed by that it can be default. Here we are trying to tell SQL that it is okay to keep the employee address column as null. It can be blank. Again, it's your wish. If you don't want the address column to be empty, you can keep it as not null. And if it's all right for you to keep it as null, then you can provide it as default null. Right, so these are the parameters, their data types, and the constraints. Right, now we will understand them a little more detail in the theoretical section, now followed by the columns. The last one is to dedicate or create a primary key. Let SQL know which is a primary key. So primary key is very important for every database or table, and I'll explain you that in the theoretical section again. Now, which is the primary key? The ID, what we created for employees, that is EMP ID, is the primary key. This particular primary key will be really important when we are trying to work with two different tables with one single column in common between both the tables, right? So with that, we have created the code for creating a new table in a database. Now let's quickly try to execute it. So there is a small error. Let's try to resolve it. Yes, so the small error that we created is we did not try to select a database, right? Before creating a table, you need to select the database or explain SQL which database is supposed to be used. Now for that, we have to use the use keyword and a database name, that is Simplilearn DB, semicolon. Now, when you run this particular code, SQL will understand we need to use the Simplilearn DB, and then it will get access to that particular DB. Then it will read this particular code and try to create a new table. Let's quickly run it. And there you go. Let's try to eliminate this code for a while. Run this. Now we are using the Simplilearn DB. Eliminate this code. Now run this particular code once again, and okay, so instead of character we can use varchar and run it. Since character limit was 255 and we gave 500, instead of character, if we provide varchar, we can provide the maximum limit. So now the table is successfully created here. So that's how you can create a new table in SQL. Now the syntax is as follows. Now here you have the insert and into keywords. Table name is the user-defined name for the table. Then you have the columns, that is column number 1, 2, and etc. Then after declaring the column names, you have the keyword values, which will help SQL understand this is a tuple and these are the values involved inside the tuple. That is row 1 value 1, row 1 value 2, so on, and row 1 value n. So this type of syntax will help you to add one tuple at one time, and this will take a lot of time to process. You can see to insert the next tuple, we are writing a completely new syntax once again, using the same insert into table name, column 1, 2, 3, n, values, and row number 2, that is the second tuple. Right, so this type of code will take longer duration to run, as well as it will take longer lines, or number of lines will be extra. So is there a way where you can add multiple tuples in one single go? Yes, there is. So the syntax will be completely same. right? So you will be using one insert into keyword, one table name, and once you will be declaring all the column numbers, and once you will be using the values keyword. The only difference is you will be adding multiple tuples under the values bracket, right? You will be declaring the number of values you want to include in one single go, and this whole query becomes as a whole. And once you run this query, all the values will be added at once. Now that you are clear with the syntax, let's quickly get back to the SQL Workbench and try to run this command. Now we are on the MySQL Workbench. Let's quickly log in. There you go, we have logged in. Let's use the Simplilearn database once again so that we get access to the data which we have. So we already have an employees table. So let's see what's presently included in employees table. Select star from employee table semicolon. So this is the data that we already have in our table. Now let's try to add some more data. So now we will include one single element or one single tuple, data related to one single employee, right, using the first type of syntax. Let's quickly execute this. The command got executed. Again, let's quickly see what's present in the table. Select star from employee table. Again, you can see I'm using lowercase for the user-defined keywords and uppercase for the predefined keywords, just to make sure that the code is understandable and which is the user-defined keyword and which is the predefined keyword. So these are the ones in small case are user-defined and the ones in uppercase are predefined. Right, so we have successfully included one single element or one single tuple, the details which are related to Brian. And now let's try to modify the same code and try to include few more tuples inside the same insert command and try to insert multiple rows into the table. Now here you can see we are using the same insert into employee table command, and instead of Brian, we replaced or we added 6 more entries under the values section, right? And the only difference is we are trying to separate the tuples using a comma. You can see we are enclosing one tuple inside the parenthesis and we are separating two tuples with the help of a comma. Right, ensure that you include comma between every tuple and you can ignore the comma for the last tuple. You can see we are not using any sort of comma or any sort of specifier at the end, right? So, and we are closing the command using the semicolon. This explains SQL that it is the end. Now we are going to run this command and see the output. So there you go, the command got successfully executed. Now let's again execute the select command and see if the data is involved or included or inserted into the given employee table. Now there you go, the command got successfully executed and you can see the table over here, and you can see that all the data or all the tuples we included into the table using the insert command in one go are successfully included. So that's how you insert multiple rows into a table using SQL. So first, let's have a quick look on the syntax we use to create a database. So first we have a create keyword which will explain the SQL server that we are trying to create a new element, which can be a database or a table. Next we have the keyword database, which clarifies the SQL that we are trying to create a new database. The next one is not mandatory if not exists, just we are trying to make sure that the database that we are going to create is not already existing. So if you use this if not exist, then SQL will tell you in case if there is an existing database on the same database name, then it will not allow you to create a duplicated database. And followed by that we have the database name, which can be anything. So I've just created as database name here. Now that we are clear with the syntax, let's get back to the IDE, that is MySQL, to execute a command to create a new database. So now we are on the SQL Workbench. Now let's quickly try to log in. There you go. Now you can see some existing databases on the left hand side of the Workbench. SYS or system is the default one. So I already created test and trial. Let's try to create a new one right away. So the create keyword and database keyword, and then if not exists. So here you can see I'm trying to capitalize the keywords so that it's easier to understand what is the code and what is the user defined names, right? So create a database if not exists and Simplilearn DB. That's our code. Let's try to execute this, and there you go. So here you can see in the action output, create database if not exists, Simplilearn DB has been executed successfully. Now we can run a new code which says show databases This should show us the newly created database, which is Simplilearn DB, which is right over here. Let's quickly take a look at the syntax that we will be using today. So we will be using the alter keyword and the table keyword. Followed by that, we will be specifying the table name in which we want to add a new column. Then we have the add keyword and name the column which you want to add to your existing table. Then the data type of that particular column with constraints if you have any. Now that we're clear with the syntax, let's get back to the SQL Workbench where we can execute this particular command. Now we are on the SQL Workbench and let us execute this particular command and see what we have in our existing table. Okay, I think we might have to use this particular command first. You need to get the access to your database, then you can get access to your tables in your database, right? So we have this particular data. Let's try to add a new column which explains about the phone number of a employee working in your organization. Okay, now we can use this particular command which is alter table. There you go. So we have added the column phone number, data type, and the constraint, not null. And if anything is not added in that particular column, the default value should be NA, right? Let's quickly execute this particular command. There you go. Now let's check if the new column is added or not by running the select command. There you go. The new phone number has been successfully added, and by default, since we did not add any number, we have NA in that particular column. So that's how you add a new column to your existing table in SQL. How do you delete a row in SQL? Let's quickly take a look at the syntax. So we will be using the delete keyword and the from keyword, adding the table name and giving a where clause with a user-defined condition. So this will be a basic syntax for the process of deleting a single row in the SQL table. Now, to understand in a much better way, let's get back to the SQL Workbench. So now we are on the SQL Workbench, and previously we tried to create a table, add some data using the insert command, and update a value using the update command. Now let's say we have to delete the last row, which is 1006 Jeremy Hyderabad. Let's say Jeremy found a new job in a new organization, and now you need to eliminate his credentials from your database. So we will be using the following code, that is delete from table name is employee table, and the where clause, now the condition, which is EMP ID is equals to 1006. Now let's try to run the code. There you go. The employee is being eliminated from that particular database. Now let's try to recheck the table. So select star from EMP LOYEE table, run the code, and there you go. The last ID, which was 1006, has been eliminated from your database. Now you might be having multiple questions. Is adding a date, is that tough in SQL tables? No. You can add a date in SQL in the format of varchar or character, everything. But if you want to perform analytics, then using the date format or date data type would be more beneficial, right? So for the SQL table, you do have some formats to follow. So that's exactly what we are going to discuss in this particular tutorial. Now let us imagine that we're going to create a table using the following syntax, that is create table keywords, table name, which is a user-defined table name, and the parameters, their respective data types, and at the end, let's say we have a date element as date of joining. And for date of joining, we will have the data type as date, right? Then let's see the code. And you need to make sure that when you're trying to enter the date element into your table, you need to be a little more cautious to follow a pattern. SQL has predefined approach to store dates, which is in the format of YY, year, MM for month, DD for dates. You need to follow this particular way of writing your date, and if you make some minor error, let's say you add a date first, then the month, and then the year, then obviously SQL will throw an error. So we don't want that to be happening. So in that case, let's try to follow the approach that SQL has. Now let's quickly go back to SQL Workbench and see how exactly it works. So here we are back on the SQL Workbench. Let's run this use database command to get access to our database. There we go. Now let's see, we have a freshly created database and it doesn't have anything, right? Now we will add these particular details into the data table, and here you see we are following the year, month and date approach, right? Now let's quickly run this command, and there you go, the date has been updated into the table. Let's now run the command again. Now we have the dates here. Now let's say we try to break the rules. Now we will try the DD, MM and the YY format here, right? Now let's try to run this particular code once again. Okay, let's eliminate all the previous elements and let's consider this as a new entry. Right, now let's try to execute this. There you go. So it will automatically throw an error saying the date value is incorrect. You need to change this back to the original form, that is YY, month and the date. Only then it will accept this particular value. There you go. So that's how you add date to your SQL tables. The second highest salary in SQL. So this particular type of questions will be most frequently asked in data analytics interview questions. So let's try to understand the syntax of how to find the not just second but any number of salaries given in a SQL table. Let's say your interviewer asked you to find the top third salary or top fourth salary. You can find that using the same syntax. So the syntax is something similar to this as shown now. But before we begin, if you are an aspiring data analyst, then I have the perfect course for you. We have the Professional Certificate Program in Data Analytics. Boost your career with this data analytics program in partnership with Purdue University and in collaboration with IBM, which features masterclasses and follows an applied learning model with real-time projects and business case studies. Now that we have a clear understanding of the PGP Data Analytics certification with Simplilearn in collaboration with IBM from Purdue University, we will get started with our tutorial for today's session. So here you can see select star. You can also use the specific columns you want, that is name and salary, but I'm selecting star, that is every single column in my table. That is select star from employee table, group by salary. So you'll be grouping by salary here, and order by salary descending. Since we wanted to find the highest, we will be choosing the descending order, that is increased number, that is the highest number to the lowest number. In case if your employer or if your interviewer asks you to find the lowest salary, then you will be using the ascending descending order, right? So since we are given the condition that we have to find the highest, we will use the descending order. Then limit n minus 1. Let's say you're supposed to find the 5th highest salary. Then the formula will be 5 minus 1 and the limit 1. That is, you just want one single row to be displayed on your output, right? So that's the reason we'll be giving limit as 1, right? So this is the simple syntax you will be following. Now let's quickly execute this on MySQL Workbench and try to get our results. Back to the Microsoft SQL Workbench. So now we are on the MySQL Workbench. Let's quickly use the database and get access to our all tables. Now we have access to the tables and the employee table which we were working on. So let's quickly have the show tables here, and we have employee and employee table 2. We will be accessing the employee table which has the salary details. So there you go. We have Rakesh, Jack, Regina, etc. right? So here you can see Karan has the highest salary and the next second highest salary is Rakesh. So we need to fetch this particular column here, right? Since our expectation is to find the second highest salary, let's try to write the following code. That is, select star from employee, group by salary, order by salary, descending order since we want highest salary, and the limit n minus 1, that is 2 minus 1, or you can also write as 1 comma 1, and done. Let's quickly execute this code, and there you go. Now let's say we want to find the third highest salary. So here n minus 1, 3 minus 1 is 2, and execute this, and there you go, you have Regina. So that's how you can extract second highest salary or any number of highest salary or the lowest salary based on the query changes you're doing. Let's say if you want to highest salary, then you should be using descending order. Let's say you want the lowest salary, you should be using the ascending order. So that's how you can extract the second highest salary from SQL tables. Now, how do we create a view in Excel? So it's as simple as creating a new table. The syntax is as follows. You just need to add create a view and your customized view name as the statements. Now what are the statements? Statements usually have the statements of what you query, the query statements. For example, select star some data what you want to fetch from your table. Yes, I totally understand select might be a really short one, but sometimes you might have to add some where conditions, you might have to add some subqueries, and the entire query length might go up to 10 to 15 lines. Right, now you might not be able to execute that query for every single time. So if you create a view for that, and if you just select that particular view, and you get all the data. Now let's understand this more easily by going through a practical demonstration on MySQL. Now we are on the MySQL Workbench. We are having a small database which is flights, and in that we have a table by the name flight data, and this is the data which we have added into a flight data, right? Let's run this and get the table. So here you have the information on your table about a few flights. You have the airline, date of journey, departure, destination, total stops, additional information, etc, etc. Right, now let's say if someone asked you to fetch a flight from Indigo which is completely non-stop, control enter. Now you have this. Right, now you face this query for once, and what if someone asks you to get this data for 10 times a day? Maybe you have 10 clients who are asking for the same information. Would you write the same query 10 times? No, right? Similarly, here you have, let's say someone wanted to go to Delhi and they ask you to get the information for the flights which are going to Delhi, and someone asked for the flights which are going from Bangalore to Delhi. Right, similarly you have many of such things. So what would be helpful here? So let's say you add one more query which reads as create view. Now the customized view name could be anything. Let's say view Indigo nonstop, as your query. Right, let's quickly execute this query and it should create a new view for you. The new view is currently done. Similarly, let's try to create a new view again. Create a view. Let's name it View Flights Delhi. Kolkata. And the Bangalore Delhi flights. Right, now you have the queries ready or the views ready. Now all you have to do is just get the select statement star from the view name. This is simpler, right? Just control enter and you have the data over there. Now let's say somebody asks you to fetch the data for flights from Bangalore to Delhi. All you have to do is select star and you should be having the data. There you go, right? As simple as that. So that's how you can create a view in SQL. And in case if you wanted to drop it, let's say you don't need it anymore. So it's simple, just drop the view and the view name. Let's say you want to drop this particular view, paste it there and control enter. There you go. The view got successfully dropped. Now when you try to run this query, you will not get it. If you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who elects to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's Data Engineering Postgraduate Program from Purdue University in collaboration with IBM. The link in the description box and the pinned comment should take you to the program being offered. So, what exactly are temp tables in SQL? So, temp table is a temporary table. So the term temporary is self-explanatory. You know that every database in SQL has tables, right? Now let's say you created 10 tables in your database and you close your MySQL Workbench or you close your database and you restart it after a while and then you will have all your 10 tables intact in your database. But temporary table is not like that. It is something different which has its existence until the session of the database is running. Let's say you open the database now, you have this session of the database running, you created the 11th table as a temporary table, and that particular 11th temporary table will be existing in the database only until the current database is running and active. Once you close it, once you turn it off, or once you restart it, the temporary 11th table that you created will die or it will be eliminated. So that is the meaning of temp table. Now let's see how we can create a temporary table. So the syntax is completely similar to the temporary or to the table what we usually create, right? It is similar to the table what we regularly create, but the only catch is we will be using the keyword temporary. Create temporary table name which is user defined name, and inside that the parameters may be the employee ID, student ID, employee name, student ID name, etc. Right? So this is how we create the temporary table. Now let's quickly get back to the SQL Workbench and try to create a temporary table, add some data into it and try to display the temporary table.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now we are back on the SQL Workbench, and meanwhile we are logging in. You might have a question, right? When you say that the temp table will be existing or running only until the database is active, then why create those temporary tables in the Workbench, right? The sole purpose of using temporary tables is, in a few cases, the intermediate results of the data analytics process are important, and you can have a quick reference on the intermediate results, and you don't want them to be existing in your database in a permanent basis, right? For such scenarios, you can use a temporary database. Now here on my workbench, we have a simple code for creating a temporary table. So I'll be creating the temporary table on the name of student, and we have student ID, integer data type, student name, worker, and department, and student ID will be the primary key. Now let's use the database, that is use Simplilearn database to get access, and we have the access now. Let's quickly see what and all tables we have using the show command. Show tables, enter, and we have two tables, employee and employee table 2, but not student. Right, now let's quickly execute this, control enter, and now let's use the insert command, same like we inserted in the previous tables. Insert into table name student, parameters ID, name, department, and values, comma separated values, student ID, name, and department or group, whatever he took in college. Right, now let's execute this code, control enter. There you go, the data has been successfully included. Now let's select star from student, that is view the contents in this particular table. We have the values in this particular table, and let's also see if we have that particular data included in the database or not. That is show tables. There you go, it's not included in the database, but it is active. When you try to print the values in that particular table which is in the database, it will show you, but when you try to fetch that particular existence or the permanent existence of that particular table, it will not be present, and this particular table will be active only until the database is active. Now let's restart this particular workbench. I'm closing it, restarting it. Now if I run this, I will not get it. You can see the error, the database, right? Okay, then let's have the database selected, and let's try to run the command. There you go, table Simplilearn db dot student does not exist, right? Previously when you try to execute, the table was giving us values. Now we have the error saying the table does not exist, right? That is how a temporary database runs. How to update table in SQL. Let's quickly take a look on the syntax for today's function. So here we have the update keyword, table keyword, and the table name which you want to update. And followed by that, we have the set keyword, which will help the SQL to set a particular column name to a new parameter to which you want to update it. Now you're giving a where condition over here. So where is the keyword, and the condition is a user-defined condition, and the combination of where and condition will help SQL to identify a particular tuple and update the parameter under that particular condition. Now that we have understood the syntax, let's quickly get back to the SQL IDE, which is MySQL Workbench, and try to execute a sample command. So we are on the IDE, and previously we tried to create an employee table. So let's select the same table. For that, let's use the database we created, that is Simplilearn DB, semicolon, enter. So we are on the Simplilearn database now. To update a table, we need to have some data in it. So as we remember, we just tried to create a normal table in the previous session. Now let's try to add some data into the same table using the insert command. So let's try to make use of the insert command. And insert into is the keyword, employee table is the table name, and these are the columns we have in the employee table. And followed by that, we have the values keyword, and followed by that we have the data which we need to enter into the table. And these items are in the form of a tuple, and every tuple is covered using parentheses. And inside the tuples, you have the first one, which is an integer type data, which is as it is. And when you come into the text type data, they are covered using the single quotes. So let SQL identify that it is a character type data. Now After entering all the tuples separated by comma, we have a semicolon which indicates the end of the statement. Now let's try to run this particular statement and add the data into the employee table. So let's select the database once again, and now let's try to add the data. There you go. Now we have the data added onto our employee table. Let's quickly check the employee table. Select star from employee table. There you go. We have all the data added onto the table: employee ID, employee name, and employee address. Let's say the last employee, Jeremy, who's been working in Delhi since a past couple of years, and you decide, being the manager, you decide that he should be relocating to Hyderabad. And you need to update the employee table now by changing the location of Jeremy from Delhi to Hyderabad. Now let's try to run our update query. So first we have the update keyword, then employee table, then set emp address equals to Hyderabad, where condition emp id equals to 1006 and semicolon. So there you go, the code is complete. We have the update keyword followed by the table name, then set keyword to set that particular column, that is the employee address, to the key Hyderabad. From Delhi, we are changing it to the Hyderabad, which is value or key, whichever you consider. And since it is a text type value, we are encoding it using the single quotes. Then the where clause and the condition, which is employee ID, must be equals to 1006. Now let's try to quickly run this command. There you go. Now let's recheck if the table has been updated or not. So select star from employee table. Let's run it. And there you go. The last location, Jeremy, which was Delhi, is now updated to Hyderabad. So that's how you update values in a table. Now, let's quickly take a look at the syntax that we will be following to execute this particular command. The syntax is as follows. We will be using the alter table keyword, then the table name where we want to eliminate the column, followed by that the drop column keyword and the column name. Now, let's get back to the SQL Workbench to execute this particular command. Now, we are on the SQL Workbench, and you can see we have 5 different columns over here, and we have the phone number column, which does not have anything. Now, we will try to eliminate this particular phone number column since we do not need that for our purposes. Now, the command is really simple. As discussed before, we will be using the alter table keyword and the table name, and the drop column keyword and the phone number, which is the column name. Now let's quickly execute this particular command and see the output. There you go. Now the column phone number has been successfully eliminated. Now let's run the select command once again and see the new table. There you go. The phone number column has been successfully eliminated. Now with that, we have come to an end of this session on how to eliminate a selected column in an existing table in SQL. That is how to print or how to obtain current date in SQL. Now the syntax is really simple. We have 2 different commands to do that. We can just type in select get date, or we can just type in select current date or CUR date. So these particular commands or functions will fetch us the current date in SQL. Now to execute these commands, let's get back to the practical mode, which can be a SQL Workbench. So now we are on the SQL Workbench. Let's log in. There you go. So we have both the commands. Let's try to execute them. Control enter, and there you go. So we have the current date. So that's how you can fetch current date using the get date function or the current date function in SQL. How to change the data type of a column in SQL. Now let's take a quick look on the syntax we will be using to change the data type of the column in SQL. So this is the syntax we'll be using. So we will be using the alter keyword, table keyword, and table name. So alter is the keyword which will help SQL to understand that we are trying to modify something, and we are selecting the table by offering the table name. And then we have the modify keyword, which will help SQL to understand that we are trying to modify something, and we are modifying the column name from the table selected, and we are modifying that particular column to a different data type, which will be specified over here in place of data type keyword, right? So now that we are clear with the syntax, let's proceed and execute the command and change some column data types. Now we are on the SQL Workbench. Previously, we created an employee database in Simplilearn DB, and we will be using the same table here. So we will be typing use Simplilearn DB so that we get access to the Simplilearn DB and the tables we have there. So let's select all employee table. Column. Let's execute this. So there you go, we have the table on our screen, and let's quickly describe the table using the desc command. And this will give us the data types of each and every column in our table. Now you can see we have pin code in the format of varchar. So let's try to alter or modify this particular pin code column from varchar to integer, since it only saves the numbers, right? So our command for that was alter table name, which is employee table. Modify was the keyword. Modify the column pin code to integer, semicolon. Now let's quickly run this command, and there you go, the command got executed successfully. Let's try to describe the table once again, and there you go. Now the pin code was earlier mentioned as varchar, and now it got changed to integer. Now that's how you alter or modify or change the data type of a column in a table in SQL. So let's quickly take a look at the syntax that we will be following to change the column name in SQL. So the syntax is as follows. We will be using the alter and table keywords, and we will be specifying the table name, and then we will give the rename column keyword, then the old existing column name, and to the new column name which we need to change it to. So having a clear understanding of the syntax, let's try to execute this command in the practical mode. So let's get back to the MySQL Workbench. So now we are on the MySQL Workbench. Let's quickly get access to the Simplilearn database. There you go. And now let's quickly take a look at the column names in our existing table. Now you can see the first column is the employee number. Let's try to change that by using the alter table command, and now the rename keyword. The column name is emp number to emp id, semicolon. Let's quickly execute this command, and there you go. Now let's try to execute the select command once again and see the output. There you go. Now the employee number has been changed to employee ID. Now, before we execute the actual code, let's take a quick peek on the syntax that we will be using today. Now the syntax is completely similar to the regular syntax that we usually use. It will have the select keyword, parameters that you want to print in your table, the from keyword, and the table name which you're trying to access. The only difference is you will have a new keyword, that is the group by keyword, and based on a certain parameter. Right, now we would get back to the practical mode, that is the MySQL Workbench, to understand the practicality of group by clause in a much better way.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill Up by Simplilearn. Click on the link in the description to know more.
Now we are on our SQL Workbench. Now let's get access to our Simplilearn database. There you go. Now let's quickly take the look at the tables we have. We have two different tables. Now let's get access to our employee table. Now we have all the employee numbers, employee names, department, designation, salary, etc. Right? Let's say you wanted to know the average salary of all the employees, right? So that would be select, that is the AVG, average function of salary, close the bracket, from EMPLOYEE, right? Let's execute this. There you go. Now you have the average salary of the entire office. But what happens when your manager asks you to find the average of each and every department, average salary of the employees in each and every department? How would you do that? Right. Every organization has multiple departments, HR, development, testing, etc., etc. Right. Now your manager wants the individual department's average salary. Then you can use this particular clause which says group by department. So the entire table will be categorized based on the departments, and it will be grouped on the basis of the department. And I'm also using the order by here, which we will discuss in the next session. But to give you a brief understanding of why we are using order by, let's say your manager asks you to find the department which has the highest average salary, right? Then you will be ordering the tables or ordering the rows based on the descending order of the salary. Now let's quickly execute this query and see the output. There you go. The query got successfully executed and we have the average salary of each and every department. Now, before we begin, let's try to take a quick look on the syntax that we will be using today, right? It is simply the select star from table name using the where clause and the column which you're choosing for that, and the between operator, and we are giving some constraints, and those different constraints are encapsulated between an AND command here. Let us say that your manager tells you to select all the rows where selecting one single column, that is salary, where the employees have the salary from 10,000 to 20,000, right? Then you will write the command select star from table name where salary between the value 10,000 and the value 20,000. So this is how the between command works. Now let's execute the same practically. Let's get back to the MySQL Workbench.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now we are back on the MySQL Workbench. Let's make some edits to the same command. Select star from employee where salary between operator. So we are using float or integer type, so we will not need the single quotes or double quotes. Number 10,000 and operator number 20,000. Right? Now let's execute this command. There you go. Now we have all the employee list which have or who have their salary ranging from 10,000 to 20,000. That is how to use like operator in SQL. So at first, let's take a quick look on the syntax that we will be using for getting the like operator operation. Right. So it's really simple. So all you need to do is select star from table name. So instead of star, you can also give your selected columns here, but by default, I'm using to select the entire table, right? And it can go with where clause. So after the table name, you will be giving the where clause and the column name that you want to extract, and you will be using the like operator with the constraints. And I'm using the single quotes here, right? Because this particular like operation can be used upon string or varchar or character type data types, right? So we will represent that particular data type using single quote. Now that we are clear with the syntax, let's go to the practical mode, that is the SQL Workbench or MySQL Workbench, and execute the like operator command.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now we are on the MySQL Workbench and we have some data or tables, and let's consider the employee name. So we have some text or varchar type of data type in the employee name as well as the employee department, right? Let's use that particular data. And here we have the command select star from employee table 2, where we can edit the same command employee name like, and remember the single quotes, right? And we will be using the percentage operation here, right? We can give the full name, so we have Jennifer here, right? Jennifer, or let's remove Jennifer, and if somebody asks you, give me all the names which start with a J, right? In that particular situation, we will be using the modulus symbol or percentage symbol, right? Now, what we will get is all the names that start with the alphabet J. And now, let's say we want all the names that include a certain alphabet. Let's say R, right? Then we can use the modulus symbol again. It can start with anything and it can end with anything, but it should have alphabet R. So this is how it works. So we have all the names which start or include the alphabet R in them, right? And that's how we can use the like operator in SQL. You can also use like operator in this way, where you can give the entire name. Let's say somebody asks you to get one single row which has the employee name as Peter, right? You can also do this in this way. There you go, you have Peter. That is how to eliminate duplicate records in SQL table. Now, we can eliminate the duplicate records in SQL by a few methods. So we will use the most simplest ones. The first one is using the inner join along with a where clause, and the second one is a simple and the humble distinct command. Now we have a brief idea on the methods. Let's understand them in a much more detailed way through a practical demonstration. Now let's get back to the MySQL Workbench to understand the codes in a much better way. So now we are on the MySQL Workbench and we will get access to our Simplilearn database, and we are in the Simplilearn database. So previously we used to work on our employee table. So let's not work on the same employee table since we have actual data there. Let's try to duplicate that table so that we will have some duplicate entries in between. So we will be changing the employee ID numbers, and we will also be using the same employee ID numbers. So the employee ID has some details to it. So we'll be understanding that in a much more detail while we are executing the commands. And we will also try to remove the primary key from the table. So I'll also explain why we are going to include the primary table, and also will explain the usage of eliminating it. So when you have the primary key in the table, SQL Workbench or any SQL will automatically stop you from adding duplicated values. But let's say if you add a duplicate entry with a new primary key, right, then it will not stop you. So we'll also have a demonstration about what to do in such scenarios. So now let's try to quickly create a duplicate employee table, which will be employee table 2, and then we will try to add some duplicate entries into it. Remember, we will not use the primary key here. So the code will be create table employee table 2, and everything will be same, which is from the previous table, which will be the employee ID, integer type, employee name, character type, this character type, pin code will be integer. And normally we include the primary key in this way. Primary key, brackets open, em. So this is the way how we add the primary key, but we are not going to add it since we want to know what happens if we enter data which also has the duplication of the primary key, right? So we will not give any primary key over here. Let's quickly run this. There you go. The new duplicated table of employee table has been created. Let's try to insert the same values with some duplication. There you go. I have pasted the command for inserting the values, and if you observe clearly at the end, I have repeated the values of Tony, Katie, Summer, June, and Gloria. So these 5 will be the duplicate values, and also we are trying to enter the duplicated primary key. Since we did not declare the ID as the primary key, it will accept all these values. Let's quickly run this, and there you go. The values have been successfully entered into the table. Let's quickly see if we have the duplication. Select star from employee table Control Enter. There you go. So you can see the duplicate values are also added onto the table. Now, how do you remove these duplications? Remember, we discussed the distinct method, which is the second one. So that happens to be the most simplest one. Let's see how it works. So here we will write a simple select command. Select distinct star from the employee table 2. Now this will give us the distinct values, right? But again, when you run this particular command, which is select star, you will have all the details back again, right? Our job is to eliminate them. So what we will do is we'll create a duplicate table. So let's name it as DUP table. So create table and duplicate table will be the name. Now quickly execute this command. And there you go. Now we have the data which we obtained from the distinct command is stored into the table named as duplicate table. Now let's quickly drop the employee table 2. Okay, the table has been successfully dropped. So when we run the same command once again, it says Simplilearn DB did not find any table by the name employee table 2. That means it's been eliminated. Now the next thing we need to do is rename it. So what we're trying to do is we are trying to use the alter table and we are trying to rename duplicate copy to employee table 2 so that we have the actual table here after eliminating the duplicated values. It's not dupe copy, it's actually dupe table. Right. There you go. Now let's execute this. Successfully done. Now if we execute this particular select command, you can see we have the cleaned data without any duplicate entries. This was one of the simplest ways of eliminating duplicates in a SQL table. Now let's try to get a step ahead and try to use some join commands and where commands and where conditions, and using those we will try to eliminate the duplications in a table. Now we are talking about a table which does have the primary key and the data will be duplicated. Let me explain you how. Now let us declare the primary key as employee ID. The key is EMP ID. Right now we do have a primary key. Now there is no way. Okay, let's try to create this. Before that, let's try to truncate employee table 2. So we can use the not drop table, we can use the truncate. So let's replace drop with truncate so that the data which we have an employee table will be removed. There you go. Now we will, or let's quickly drop the table because we are trying to create the new table, right? So let's create the new table. So once we have executed the drop table command, the table has been successfully removed. Now let's try to create this particular table. Control Enter. There you go. The table got successfully created. Now let's try to duplicate the same entries. Remember, I'm not changing the primary key here. Now when I run this command, I will get an error which says primary key cannot be duplicated. So here you can see duplicate entry for 9 and you cannot have the duplicate entries, right? This is one way to avoid duplications. But what if someone comes up with a brilliant idea to replace the primary key? Now if I change the primary key as 17, 18, let's say we also have this data copied. Let's duplicate this. Right, this will be our 19 and this will be our 20. Now we have unique primary keys for all our data, and we also know there are some duplications. Let's try to execute this command and see the output. So somewhere something is not correct yet. Okay, this one. So Tony has been repeated, so we can have a different ID for Tony. Let's say we have Tony as 21. Try to execute the command once again. It should be clear now. Okay, it still has some duplication somewhere. Yes, it's right here. Let's keep this as 22. Okay, I think we made a lot of duplications somehow. Let's quickly take a look if all the major keywords are duplicated or not. So we copied from Gloria. So after Gloria, we will remove these. So Gloria, so we just make sure, we're trying to make sure that the primary keys are unique here. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20, 22. There you go. So now we believe that all the primary keys are unique. Let's try to run this command and see if we get the same error or not. No. So now all the data has been inserted into the duplicate table, which is employee table 2. And we also have some duplicate entries. Now, how would you recognize that we don't have any duplicates, or how would you recognize which data has been exactly duplicated, and how do you even remove it? Now the old distinct command is not going to work. Anyhow, let's see if it works by any chance. So when I try to run the distinct command, it will give me all 22 rows with all the duplicate entries, right? In this case, we can use the first method, which was the join and where condition method, right? Let's try to do that. So we are going to use the delete command, delete T1 from employee table to T1 inner join employee table 2 as T2. So we are declaring two different tables. So we are considering T1 as one table and T2 as the next or second table. So T1 and T2 are the copies of the same existing employee table 2, right? Now we are joining these two tables and we are having a where condition over here. So from table T1, we are going to eliminate table 1 from table 2, where we have an intersection and where we have the employee IDs greater than employee ID in employee. Okay, let's not confuse. So let's execute the command first. Okay, let's execute this to understand what I mean here. So here, when we go a little down, you can see 14 for Tony, right? actual employee ID of Tony is 9, but we have 14 for Tony. And Gloria, we have 18, 19, 20. And again, for Katie, we have 22. The actual number of Katie is 10, right? So now it will try to recognize the highest number of employee ID. So it will recognize the highest employee ID number and it will retain it, and rest all the numbers will be eliminated. So this is the first where condition, and we're also giving a string comparison function where SQL will try to identify if there is a similarity between the employee name of the first table and the employee name of the second table. And we know that when you give the string comparison operation, if it results in 0, it means the strings are equal. If it results in 1, it means the strings are not matching. Now that we understood the logic of this particular statement, let's try to execute it. So there you go. So we have executed the command. Now let's try to see what's left in the table. There you go. Now we should be having the usual 13 number of employees in our table. And you can see that the records are retained where the employee ID number is the highest. Remember, we had the number 10 as employee ID for Katie, and we have that over here. In case if you want the actual numbers to be placed however they were, you can make a small change to your command. All you need to do is keep this particular, or change this particular greater than symbol to lower than symbol, and you will retain the actual numbers of the employee records. So that's how you can eliminate the duplicate entries in the table. And if you ask me, hey, only 2 conditions are enough, don't you think the pin code and we also have pin code and the address of the employees, don't you think that is also important? Yes, you can also do that. You can make some minor modifications to your code and try to include all those remaining things, and again you can do the same, right? Now let's try to eliminate the data in our table. Let's truncate it, and we should be having no data left in our table. And let's try to insert the duplicate entries once again. And okay, before that, let's try to do this particular execution. Remember, we tried to keep the employee ID. Let's try to execute that and try to print it, and we should be having the actual numbers over here, right, as expected. Now let's again truncate the data and try to compare the conditions, or we will be using the where condition and we'll have all the parameters included in our condition. Let's truncate the table, and now let's try to add the duplicate entries once again. There you go, we have all the duplicate entries entered. Now what we will be doing is we will be using the same command, but the only change will be the string comparison or the where condition, right? So you can keep this string comparison if you want, or if you can change that. Let me change that actually. So instead of this, we will use this particular command where we are trying to compare the employee ID. So let's keep the employee ID as lesser than, so that we have the actual employee ID numbers, and we are using an AND condition over here, so that this particular condition should be valid and the employee name should be equal to the employee name in T1 and T2. Yep. And the next one is, here we have the employee address. So the employee address in T1 and T2 should also be same, and pin code from both the tables should also be same. So what we are trying to compare here is we are trying to keep the employee ID with the least number or the least value, and the names of the employee should be same, the address of the employee should be same, and the pin code of the employee should be same. In that particular condition, you can try to delete the record. Let's try to execute this, and there you go, the command got executed. And now let's try to execute the select command, which should give us the final result. So here you go, Control Enter, and you have the data here. So now we have successfully eliminated all the duplicates by comparing the values in each and every single column, and we also have retained the original ID of each and every employee.
So what is normalization in DBMS? So the normalization theory was first explained by IBM researcher EF code in the 1970s. So in a database, a large amount of data is stored in different tables. There can be the possibility of redundancy being present in the data. So normalization aims to eliminate this redundancy from the data and ensures data integrity. Using normalization techniques, you can split a large table into smaller tables and define relationships between them to enhance the clarity in organizing data. It also removes anomalies like insert, update, and delete anomalies. In insert anomaly, the values such as null are not allowed to be inserted in a column. So a record about an entity cannot be inserted into the table without first inserting information about another entity. So for example, you cannot enter a customer without a sales order. Now in update anomaly, the data cannot be updated correctly because the same values occur multiple times in a column. And in delete anomaly, the deletion of a record generates inconsistency as it gets deleted from more than one row. Now to understand how normalization works, it is important to learn about keys in databases. A key is an attribute or a column that uniquely distinguishes or identifies a record in a table. A key could be an individual column or a combination of multiple columns. It is a very important part of relational database model. In reality, multiple tables are needed for storing the data, and those tables are related to each other as well. Now, to retrieve any specific record from a table, you need to apply some conditions. But what if there is duplicate data present, and every time you try to fetch some data by applying certain conditions, you get the incorrect result or the data? So to avoid these issues, we need keys in a table. Now keys also help to establish relationships among the tables. So here you can see we have a student table, and it has columns like the student ID, we have the student roll number, we have the student name, the city to which the student belongs to, as well as the department to which the student belongs to. So in this table, ID column is the primary key. You can also have the roll number as the primary key because this is the column from which you can identify individual record for any of the students. And here you can see department ID is called the foreign key. Just wait for a while, we'll learn about foreign keys in a while. Now let's look at the different types of keys in a database. So we have primary key, foreign key, super key, and candidate key that we are going to discuss in this video. There are other keys as well, like the composite key, alternate keys. Cool. Now let's understand what is a primary key. So primary key is a set of one or more fields or columns of a table that uniquely identifies a record in a database table. It cannot accept null or duplicate values. Okay, so here you can see we have two tables. The first is the student table and the second one we have is the department table. So in the student table, we have columns such as the student ID, we have the roll number column, student name, city, and the department ID to which the student belongs to. So in this case, the primary key will be student ID because you can see all the values are unique and there are no repetitions, as in there are no duplicate values for the ID column. You can also consider the roll number as the primary key because in a college or in a school, the roll number for each student in a class would be unique. So here also you can see the roll numbers are all unique, but you cannot have student name, city, and department ID as the primary key because there can be two students with the same name. Similarly, there can be different students belonging to the same city, and there could be a lot of students from the same department. So these three columns cannot be the primary key columns. Only ID and roll number can be the primary key columns. Similarly, for the department table, the department ID is the primary key. Now moving on. Next we have foreign key. So foreign key is a table in a database that is the primary key in another table. So here we have the same tables as we saw in the previous slide. So here we have the student table and the department table. In the student table, the department ID is the foreign key, whereas in the department table, the department ID is the primary key. So this means that the department ID column in the student table is referring to the primary key department ID column in the department table. Alright, so moving ahead, we have super key. So super key is a set of one or more than one key that can be used to identify a record uniquely in a table. So super key can have extra attributes that are redundant for distinct identification. So here we have the student table, and on the right side you can see we have the list of super keys. So using these columns you can identify each record in a table. So your ID and student name can be a super key. Similarly, roll number and student name can be super key. Then we have ID, student name and city combinedly forming the super key. Then you also have the roll number, city and department ID as the super key. There can be other combinations as well. Now moving to learning what is a candidate key. So a candidate key is the minimal super key that can identify a record uniquely in a table. Each candidate key can work as a primary key. So we have the same table again here, and these are the list of candidate keys. Just to make sure, these candidate keys should be also part of the super key. So hence a candidate key is also known as a minimal super key. Now with this basic knowledge about the different keys in a database, let's look at the next topic. We have types of normal forms. So we have the first normal form, the second normal form, third normal form, and BCNF or Boyce Codd normal form that we are going to discuss in this session. Coming to learning what is first normal form. So a relation is in first normal form if it does not contain any composite or multi-valued attribute. So each table cell should contain a single value and each record needs to be unique. That is, an attribute of a table cannot hold multiple values. Let's see an example. So here you can see we have a student table, and this table is not in first normal form because we have multi-valued attribute student phone number for student ID A102 with the student name Sam. So here we can see there are two phone numbers, so this becomes a multi-valued attribute. Now the table can be transformed to the first normal form like this. You can see on the right side. So this contains only atomic values or single value in each cell. So we have split A102 Sam having two different phone numbers into two different rows. Now this table follows the first normal form because each of the cells have atomic values. Alright, now let's understand what is the second normal form in a database. So for a table to be in second normal form, the following two conditions should be met. The first is that the table should be in first normal form and it should not have any partial dependency. So records should not depend on anything other than a table's primary key. Hence you need to remove subsets of data that apply to multiple rows of a table and place them in separate tables. Let's understand what is a partial dependency. So if the proper subset of any candidate key determines the non-prime attributes, it is called partial dependency. Let's understand this with an example. So here we have a course table and the table has three columns. We have the professor ID, then we have the course name, and then we have the course fee. Now the course fee attribute cannot alone decide the value of professor ID or the course name. Similarly, the course fee together with professor ID column cannot decide the value of the course name. Course fee column together with the course name column cannot decide the value of professor ID. Hence, course fee column here becomes the non-prime attribute as it does not belong to any of the candidate keys, that is the professor ID and the course name. But here the course fee column is dependent on the course name. So if you want to know the course fee of a particular course, you need to know the course name. Course name column here is a proper subset of the candidate key. So the non-prime attribute, which is the course fee, is dependent on a proper subset of the candidate key. Now this creates a partial dependency. So this relation is not in 2NF. Here you can see we have the professor ID and course name combinedly forming the candidate key, and course fee is the non-prime attribute. Now to convert this table into second normal form, we need to split the table into two tables. Here you can see we have our original course table and we have split into two tables, that is the professor course table and the course fee table. So the professor course table has two columns, the professor ID and the course name. Similarly, for course fee have the course name. So these are all unique courses and the course fees for the different courses. Now one thing to notice here is a lot of the courses are being taught by the same professors. For example, Professor ID P01 teaches both physics and chemistry. Similarly, Professor P03 teaches law and politics, and Professor P02 teaches economics and statistics. And there are multiple professors for each of the courses. For example, for economics we have P02 and P05. For physics we have P01 and P04 as well. And the course fees for a few of the courses are the same. For example, for physics and chemistry the course fee is $5,000. Similarly, for economics and statistics the course fee are the same, so $6,500. Now the second normal form tries to decrease the unnecessary data getting stored in memory. For example, if there are 10 professors teaching the chemistry course, we don't need to store its fee as 5,000 for all the 10 records. Instead, just once we can store it in another table as the course fee for chemistry is $5,000. Now let's move on to the next normal form. We have the third normal form. So a relation is said to be in 3NF for third normal form if it is in second normal form and does not contain any transitive partial dependency. In 3NF is also used to diminish data duplication and it is also used to achieve data integrity. Let's understand what is transitive functional dependency with an example. So a transitive functional dependency exists if the column entry is dependent on any other column apart from the key column in the table. So here we have an employee table, and in this table we have the employee ID as the primary key. Also the candidate key in this table is the employee ID, and there are a few functional dependencies. For example, the employee name is dependent on the employee ID. Similarly, the department name of the employee is dependent on the employee ID column. We have the employee city depending on the employee ID column again, but the city zip code or the city pin code is dependent on the employee's city name. For example, if you want to know the zip code of a particular place, you need to know the name of the place or the city. So hence your employee city zip column depends on the city column, and this leads to a transitive functional dependency. So we need to break the table into two tables for transforming it into the third normal form. Now let me show you how you can break it in the next slide. So here you can see we have the original employee table with all the columns, and now we have broken our original table into two tables with the name employee details and city details. So here your employee ID becomes the primary key, and we have the employee name, department name, and the employee city. So each of the other non-prime attributes are depending only on the primary key or the candidate key here, which is the employee ID. Similarly, in this table we have only one primary key, which is the zip code, and then we have the city for each of the zip codes. Alright. So this tells us that all the non-key columns are fully functional dependent only on the primary key column. Now moving ahead to the next normal form, which is the Boyce-Codd normal form. So Boyce-Codd normal form or BCNF is a special case of third normal form. A relation is in BCNF if and only if every determinant is a candidate key. So if for every functional dependency X determines Y, here X should always be a super key. Only then the relationship is in BCNF. Now let's see an example. So here we have an employee table with the columns employee ID, the country to which the employee belongs to, we have the different departments, we have the department type and the department number as well. So here one thing to note, you can see there are two employees from Japan, that is from the same country, but these are two different employees. Now you can see the functional dependencies that exist. So to know the country of the employee, you need to know the employee ID. So your country is dependent on employee ID. Similarly, your department type column is dependent on the department column. Department number is also dependent on the department column, and to know the department you need to know the employee ID. So here your employee ID and department columns together form the candidate key. Now to transform the above table to Boyce Codd normal form or BCNF, we have to break it down into three tables. You can see here T1, T2 and T3. So in the first table we have employee ID as the candidate key or the super key, and then we have the country. So your country is dependent on the employee ID. Similarly, in table T2, your department type column and department number columns are dependent only on the department column, and in the third table, that is T3, your department is dependent on the employee's ID. So here the candidate keys for tables T1, T2 and T3 are employee ID, department and employee ID and department together. So one thing to note is the LHS or the left hand side of each functional dependency should be a candidate or super key for the table to be in BCNF. And that brings us to the end of this video tutorial on normalization in DBMS. Let me just run through whatever we learnt. So first we looked at the basics of normalization in database management system and why do we need it. Then we learned what is a key in a database table. Then we looked at the different types of keys. So we understood what is a primary key, what is a foreign key. Then we looked at what is a super key and we listed down a few super keys for our student table. Then we understood how candidate key is related to super key, and then we moved ahead with our types of normal forms. So we explored the first normal form. So we learned here that all the values in the table should be atomic. So we broke our rows into two different rows for the table to be in first normal form. Then we understood about the partial dependency in a second normal form and how you can avoid partial dependency in a table. Then we looked at the third normal form and understood about the transitive functional dependency using this employee table. And finally we learnt about the Boyce Codd normal form with an example. Now there are other normal forms as well, such as the fourth normal form and the fifth normal form, but in most of the cases in reality all the data integrity issues and the anomalies such as the insertion, deletion or update anomalies are resolved in the third normal form or the BCNF form.
If you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who elects to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's Data Engineering Postgraduate Program from Purdue University in collaboration with IBM. The link in the description box and the pinned comment should take you to the program being offered.
First, what is group by in SQL? So the group by statement or clause groups records into summary rows and returns one record for each group. It groups the rows with the same group by item expressions and computes aggregate functions for the resulting group. A group by clause is a part of select expression. In each group, no two rows have the same value for the grouping column or columns. Now below, you can see the syntax of group by. So first we have the select statement and then followed by the column names that we want to select. From, we have the table name followed by the where condition, and next we have the group by clause, and here we include the column names. Finally, we have the order by and the column names. Now here is an example of the group by clause. So we want to find the average salary of employees for each department. So here you can see we have the employees table. It has the employee ID, the employee name, the age of the employee, we have the gender, the date on which the employee had joined the company. Then we have the department to which each of these employees belong to. We have the city to which the employees belong to, and then we have the salary in dollars. So actually we'll be using this employees table on MySQL Workbench as well. So if you were to find the average salary of employees in each department, so this is how your SQL query with group by clause would look like. So we have selected department, and then we are using an aggregate function, that is AVG, which is average, and we have chosen the salary column, and here we have given an alias name which is average underscore salary, which appears in the output, you can see here, from employees, and we have grouped it by department. So here in the output you can see we have the department names and the average salary of the employees in each department. Now let me take you to my MySQL Workbench, where we will implement group by and solve specific problems.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Okay, so I am on my MySQL Workbench. So let me make my connection first. I'll enter the password. So this will open my SQL editor. So first of all, let me check the databases that I have. So I'll use my query, that is show databases. Let's run it. Okay, you can see we have a list of databases here. I'm going to use my SQL underscore intro database. So I'll write use SQL underscore intro. So this will take us inside this database. I'll run it. Alright, now you can check the tables that are present in SQL underscore intro database. If I write show tables, you can see the list of tables that are already present in this database. To do our demo and understand group by as well as having, let me first create an employee table. So I'll write create table employees. Next, I'll give my column name as employee underscore ID, which is the ID for each employee. I'll give my data type as integer, and I'll assign employee ID as my primary key. Next, I'll give employee underscore name, and my data type would be varchar. I'll give the size as 25. My third column would be the age column. Age would obviously be an integer. Then I have my gender column. I'll use character data type and assign a value of 1 or size of 1. Next, we have the date of join, and the data type will be date. We have the department column as well. This is going to be of varchar, and 20 will be the size. Next, we have the city column, which is actually the city to which the employee belongs to. And finally, we have the salary column, which will have the salary for all the employees. Okay, now let me select and run this. You can see here we have successfully created our table. Now to check if our table was created or not, you can use the describe command. I'll write describe employees. You can see the structure of the table so far. Alright, now it's time for us to insert a few records into this employees table. So I'll write insert into employees, and I'll copy paste the records which I have already written on a notepad. So let me show you. So this is my EMP notepad, and you can see I have already put the information for all the employees. So let me just copy this and we'll paste it here. Alright, let me go to the top and verify if all the records are fine. Alright, so let's run our insert query. Okay, so you can see here we have inserted 20 rows of information, and now let's check the table information or the records that are present in our employees table. I'll write select star from employees. If I run it, you can see here I have my employee ID, the employee name, age, gender, we have the city, salary, and in total we have inserted 20 records. Now let me run a few SQL commands to check how the structure of our table is. Let's say I want to see the distinct cities that are present in our table. So I'll write select distinct city from employees. If I run this, you see here there are total 8 different cities present in our employees table. So we have Chicago, there's Seattle, Boston, we have New York, Miami, and Detroit as well. Now let's say you want to know the total number of departments that are present. So you can use distinct department. If I run this, alright, you can see we have 7 rows returned, and here are the department names. So we have sales, marketing, product, tech, IT, finance, and HR. Alright, now let me show you another SQL command. Now this is to use an aggregate function. So I want to find the average age of all the employees from the table. So I can write select AVG, which is the aggregate function for average. Inside that I have passed my age column from employees. If I run this, so the average age of all the employees in our table is 33.35. Now say you want to find the average age of employees in each department. So for this you need to use the group by clause. I'll give a comment here. I want to find the average age in each department. So I'll write select department, comma, I'll write average of age from employees group by department. Now if I run this, you can see here we have our 7 departments on the left, and on the right you can see the average age of employees in each of these departments. Now you can see here in the output it says AVG of age, which is not readable, so I can give an alias name as average age. Alright, I can bring this down, and if you want you can round the values also. So you can round the decimal places, so I'll use a round function before the average function, and the round function takes 2 parameters. One is the variable and the decimal place you want to round it to. So if I run this, there you go. You can see here we have the average age of all the employees in each of these departments. Alright, now suppose you want to find the total salary of all the employees for each department. So you can write select department, comma, now I want the total salary, so I'll use the sum function and I'll pass my column as salary from employees group by department. Let's run this query. You can see here in the output we have the different departments, and on the right you can see the total salary of all the employees in each of these departments. Now here also you can give an alias name as total underscore salary. Let's run it again, and you can see the output here. Alright, now moving ahead, you can also use the order by clause along with the group by clause. Let's say you want to find the total number of employees in each city and group it in the order of employee ID. So to do this, I can use my select query. I'll write select count of, let's say, employee ID, and I want to know the city as well, from employees group by city, and next you can use the order by clause. I'll write order by count of employee ID, and I'll write DESC, which stands for descending. If I run this query, you can see here on the left you have the count of employees, and on the right you can see the city names. So in Chicago we had the highest number of employees working, that was 4. Then we had Seattle, Houston, Boston, Austin, and the remaining also had 2 employees. So in this case we have ordered our result based on the count of employee ID in descending order. So we have the highest number appearing at the top and then followed by the lowest. Okay, now let's explore another example. Suppose we want to find the number of employees that joined the company each year. We can use the year function on the date of joining column. Then we can count the employee IDs and group the result by each year. So let me show you how to do it. So I'll write select. I'm going to extract year from the date of join column. I'll give an alias as year. Next, I'll count the employee ID from my table name, that is employees, and I'm going to group it by year, date of join. I give a semicolon. Alright, so let's run this. Great. You see here in the result we have the year that we have extracted from the date of join column, and on the right you can see the total number of employees that joined the company each year. So we have in 2005 there was 1 employee. Similarly, we have in 2009 there were 2 employees. If I scroll down, you have information of other years as well. Now if you want, you can order this as well based on year or count. Okay. Now you can also use the group by to join 2 or more tables together. So to show you this operation, let me first create a sales table. So I'll write create table sales, and the sales table will have columns such as the product ID, which is going to be of integer type. Then we have the selling price of the product. Now this will be a float value. Then we have the quantity sold for each of the products. So I'll write quantity. Quantity will be of integer type. Next we have the state in which the item was sold, and state I'll put it as varchar and give the size as 20. Let's run this so that we'll create our sales table. Alright, so we have successfully created our sales table. Next, we need to insert a few values to our sales table. So I've already written the records in a notepad. Let me show you. Okay, so here you can see I have my sales text file. Let me just copy these information. I'll just paste it on the query editor. Okay, now let me go ahead and run this insert command. Alright, so you can see here we have successfully inserted 9 rows of information. So let me just run it through what we have inserted. So the first column is the product ID column. Then we have the selling price at which this product was sold. Then we have the quantity that was sold and in which state it was sold. So we have California, Texas, Alaska. Then we have another product ID which is 123, and these are the states in which the products were sold. So let me just confirm with the select statement. I'll write select star from sales. If I run this, you can see we have successfully created our table. Okay. Now suppose you want to find the revenue for both the product IDs 121 and let's say 123, since we have just two product IDs here. So for that you can use the select query. So I'll write select product ID. Next, I want to calculate the revenue. So revenue is nothing but selling price multiplied by the quantity. So I'll use the sum function to find the total revenue, and inside the sum function I'll use my selling price column multiplied by my quantity column. I'll give this an alias name as revenue from my table name, that is sales. Finally, I'll group it by product ID. Let's run it. There you go. So here you can see we have the two product IDs 121 and 123, and here you can see the revenue that was generated from these two products. Alright. Now let's say we have to find the total profit that was made from both the products 121 and 123. So for that I'll create another table. Now this table will have the cost price of both the products. So let me create the table first. I'll write create table. Let's say the table name is C product, which stands for the cost price of the products. I'll give my first column as product ID. This will be an integer, and I'll have my second column as cost price. Cost price will have floating type values. Let's run this. So we have successfully created our product cost table. Now let me insert a few values into the C product table. So I'll write insert into C underscore product. I'll give my values for 121. Let's say the cost price was $270 for each, and next we have my product as 123, and let's say the cost price for product 123 was $250. Let's insert these two values. Okay. Next, we'll join our sales table and the product cost table. So this will give us the profit that was generated for each of the products. So I'll write select C dot product underscore ID, comma, I'll write sum S dot sell underscore price. Now here C and S are alias names. So if I subtract my cost price from the selling price, that will return the profit that was generated. I'll multiply this with S dot quantity, close the bracket. I'll give an alias name as profit from sales as S. So here S stands for the sales table. I'm going to use inner join C underscore product table, as the alias name should be C, where S dot product underscore ID is equal to C dot product underscore ID. We are using product underscore ID because this column is the common column to both the tables. And finally, I am going to group it by C dot product underscore ID. Alright. So let me tell you what I have done here. So I am selecting the product ID. Next, I am calculating the profit by subtracting the cost price from the selling price, and I have multiplied the quantity column. I am using an inner join to connect my sales and the product cost table, and I am joining on the column that is product ID, and I have grouped it by C dot product ID. Let's run this. There you go. So here you can see for product ID 121 we made a profit of $1,100, and for product ID 123 we made a profit of $840. So now that we have learnt group by in detail, let's learn about the having clause in SQL. The having clause in SQL operates on grouped records and returns rows where aggregate function results matched with given conditions only. So now having and where clause are kind of similar, but where clause can't be used with an aggregate function. So here you can see the syntax of having clause. You have the select statement followed by the column names from the table name, then we have the where conditions, next we have the group by, finally we have having, and at last we have order by column names. So you can see here we have a question at hand. We want to find the cities where there are more than 2 employees. So you can see the employee table that we had used in our group by clause as well. So if you were to find the cities where there are more than 2 employees, so this is how your SQL query should look like. So we have selected the employee ID and we are finding out the count using the count function. Next we have selected the city column. From employees we have grouped it by city, and then we have used our having clause. So we have given our condition having count of employee ID should be greater than 2. So if you see the output, we have the different city names, and these were the cities where the count of employees was greater than 2. Alright, so let's go to our MySQL Workbench and implement how having works. So suppose you want to find those departments where the average salary is greater than $75,000. You can use the having clause for this. So let me first run my table, which is employees. If I run this, you can see we had inserted 20 rows of information, and the last column we had was salary. So the question we have is, we want to find those departments where the average salary is greater than $75,000. So let me show you how to do it. So I'll write select department, comma, I'll use the aggregate function that is average salary. I'll give an alias name as avg underscore salary from employees. Next we'll use the group by clause, and I want to group it by each department, and then I'm going to write my having clause. So in having clause I'll use my condition that is having average of salary greater than $75,000. Let's run it and see the output. There you go. So here you can see there were total 3 departments in the company, that is sales, finance and HR, where the average salary is greater than $75,000. Okay. Next, let's say you want to find the cities where the total salary is greater than $200,000. So this will again be a simple SQL query. So I'll write select city, comma, I want to find the total salary, so I'll use the sum function, and I'll pass my column as salary, as I'll give a alias name as total from employees group by city, and then I am going to use my having clause. I'll pass in my condition as having sum of salary greater than $200,000. Alright, so let's run this query. There you go. So the different cities are Chicago, Seattle and Houston, where the total salary was greater than $200,000. Now suppose you want to find the departments that have more than 2 employees. So let's see how to do it. I'll write select department, comma. This time, since I want to find the number of employees, I'm going to use the count function. I'll write count star as employee underscore count or emp underscore count, which is my alias name, from employees. Next, I'll group it by department, having, I'll give my condition count star greater than 2. Let's run this. Okay, so you have departments such as sales, product, tech and IT, where there are more than 2 employees. Okay, now you can also use a where clause along with the having clause in an SQL statement. So suppose I want to find the cities that have more than 2 employees apart from Houston. So I can write my query as select city, comma, count star as emp count from employees, where I'll give my condition city not equal to Houston. I'll put it in double quotes since I don't want to see the information regarding Houston. I'll group it by city, having count of employees greater than 2. So if I run this query, you see we have information for Chicago and Seattle only, and we have excluded the information for Houston. Now you may also use aggregate functions in the having clause that does not appear in the select clause. So if I want to find the total number of employees for each department that have an average salary greater than $75,000, I can write it something like this. So select department, comma, count star as emp count from employees group by department, and in the having clause I'm going to provide the column name that is not present in the select expression. So I'll write having average salary greater than 75,000. This is another way to use the having clause. Let's run this. Alright, you can see we have department sales, finance and HR, and you can see the employee count where the average salary was greater than 75,000. Okay, so let me run you from the beginning what we did in our demo. So first we created a table called employee, then we inserted 20 records to this table. Next we explored a few SQL commands like distinct, then we used average, and finally we started with our group by clause, followed by looking at how group by can be used along with another table, and we joined two tables, that was sales and product cost table, to find out the profit. Then you learned how to use the having clause. So we explored several different questions and learned how to use having in SQL. SQL Joins statement or command is often used to fetch data present in multiple tables. SQL Joins are used to combine rows of data from two or more tables based on a common field or column between them. Now consider this example where we have two tables, an orders table and a customers table. Now the order table has information about the order ID, which is unique here. We have the order date, that is when the order was placed. Then we have the shipped date. This has information about the date on which the order was shipped. Then we have the product name, which basically is the names of different products. We have the status of delivery, whether the product was delivered or not, or whether it was cancelled. Then we have the quantity, which means the number of products that were ordered. And finally we have the price of each product. Similarly, we have another table called customers, and this customer table has information about the order ID, which is the foreign key here. Then we have the customer ID, which is the primary key for this table. We also have the phone number, customer name and address of the customers. Now suppose you want to find the phone numbers of customers who have ordered a laptop. Now to solve this problem, we need to join both the tables. The reason being, the phone numbers are present in the customers table, as you can see here, and laptop, which is the product name, is present in the orders table, which you can see it here. So using a join statement, you can find the phone numbers of customers who have ordered a laptop. Now let's see another problem where you need to find the customer names who have ordered a product in the last 30 days. In this case, we want the customer name present in the customers table and the last 30 days order information, which you can get from the order date column that is present in the orders table. Okay, now let's discuss the different types of joins one by one. So first we have an inner join. So the SQL inner join statement returns all the rows from multiple tables as long as the conditions are met. From the diagram above, you can see that there are two tables, A and B. A is the left table and B is the right table. The orange portion represents the output of an inner join, which means an inner join returns the common records from both the tables. Now you can see the syntax here. So we have the select command and then we give the list of columns from table A, which you can see here is the left table, followed by the inner join keyword and then the name of the table, that is B, on a common key column from both the tables A and B. Now let me take you to the MySQL Workbench and show you how inner join works in reality. So here I'll type MySQL. You can see I have got MySQL Workbench 8.0 version installed. I'll click on it. So it'll take some time to open. Okay, I'll click on this local instance and here I'll give my password. Okay, so this is how an SQL editor on MySQL Workbench looks like. So first of all, let me go ahead and create a new database. So I'll write create database. This is going to be my command, followed by the name of the database, that is going to be SQL_joins. If I give a semicolon and hit Ctrl Enter, this will create a new database. You can see here one row affected. Now you can check whether the database was created or not using show databases command. If I run it, here you can see I have SQL Joins database created. Now I'll use this database, so I'll write use SQL_joins. Okay, now to understand inner join, consider that there is a college, and in every college you have different teams for different sports such as cricket, football, basketball and others. So let's create two tables, cricket and football. So I'll write create table and my table name is going to be cricket. Next, I'm going to create two columns in this table. The first column is going to be cricket ID. Then I'm going to give the data type as int and use the auto increment operator. I'm using auto increment because my cricket ID is going to be my primary key. Then I'm going to give the name of the students who are part of the cricket team, and for this I'll use varchar DataType and give the length as 30. I'll give another comma and I'll assign my cricket ID as primary key. Within brackets I'll give cricket underscore ID. Cricket ID is nothing but a unique identifier for each of the players, like you have roll numbers in college. Okay, let me just run it. Alright, so we have successfully created our cricket table. Similarly, let me just copy this and I'll paste it here. I'll create another table called football. This will have the information of all the students who are part of the football team, and instead of cricket I am going to give this as football ID. Alright, and the name column will have the names of the students. I'll change my primary key to football ID. Alright, let me run this. Okay, so now we have also created our football table. The next step is to insert a few player names into both the tables. So I'll write my insert into command. First, let's load some data to our cricket table. So I'll write cricket and I'll give my name column followed by values, and here I'll give some names such as, let's say, Stuart. I'll give another comma. The next player I'll choose is, let's say, Michael. Similarly, I'll add a few more. Let's say we have Johnson. The fourth player I'll take is, let's say, Hayden. And finally we have, let's say, Fleming. Okay. Now I'll give a semicolon and run this. Okay, so let me just check if all the values were inserted properly. For this I'll use select star from table, that is cricket. If I run it, you can see I have created a table and have successfully inserted 5 rows of information. Now similarly, let's insert a few student names for our football table. So I'll change this to football, and obviously there would be students who will be part of both cricket and football team. So I'll keep a few repeated names. Let's say Stuart, Johnson, and let's say Hayden are part of both cricket and football team. Then we have, let's say, Langer, and let's say we have another player in the football team, that is Astle. I'll just run it. Okay, you can see there are no errors. So we have successfully inserted values to our football team as well. Let me just recheck it. I'll write select star from football. Alright, so we have 5 players in the football team as well. Okay, now the question is, suppose you want to find the students that are part of both the cricket and football team. In this case you can use an inner join. So let me show you how to do it. So I'll write select star from cricket, as I'm using an alias name as C, which stands for cricket. Then I'm going to write inner join. My next table is going to be football as F, which is an alias name for the football table. Then I'm going to use the on command or operator, and then I'll give the common key, that is name here. So c dot name is equal to f dot name. So based on this name column from both the table, my inner join operation will be performed. So let's just run it. There you go. So Stuart, Johnson and Hayden are the only 3 students who are part of both the teams. Alright. Now you can also individually select each of the columns from both the tables. So let's say I write select c dot cricket underscore id, comma c dot name, comma f dot football underscore id, comma f dot name. From, I'll write cricket as C, inner join football as F on C dot name is equal to F dot name. Now if I run this, you see we get the same output here as well. Alright. Now let's explore another example to learn more about inner joins. So we have a database called classic models. Let me first use classic models. I'll run this. Okay. Now let me just show the different tables that are part of classic tables. Alright. So here you can see there are tables like customers, there's employees, office, there's office details, orders, payments, products and product lines as well. Alright. So let me use my select statement to show what are the columns present in the products table. Okay. So this product table has information about different product names. You have the product code. Now this product code is unique here. We also have the product vendor, a little description about the product. Then we have the quantity in stock, buying price and MSRP. Let's see what we have in product lines. If I run it, you see here we have the product line, which is the primary key for this table. Then we have the textual description for each of the products. This is basically some sort of an advertisement. Alright. Now suppose you want to find the product code, the product name and the text description for each of the products. You can join the products and product lines table. So let me show you how to do it. I'll write my select statement and choose my columns as product code. Then we have product name, and let's say I want the text description. So I'll write this column name. Okay. Then I'll use from my first table, that is products, inner join product lines. I can use using the common key column, that is product line. Close the bracket, I'll give a semicolon, and if I run it, there you go. So you can see the different product codes. Then we have the different product names and the textual description for each of the products. So this we did by joining the products table and the product lines table. Alright. Now suppose you want to find the revenue generated from each product order and the status of the product. To do this task, we need to join three tables, that is orders, order details and products. So first let me show you what are the columns we have in these three tables. We have obviously seen for the products table. Now let me show you for orders and order details table. So I'll write select star from orders. If I run it, you can see it has information about the order number, the date on which the order was placed. We also have the shipment date. We also have the status column, which has information regarding whether the order was shipped or cancelled. Then we have some comments column. We also have the customer number who ordered this particular product. Similarly, let's check what we have under order details. So I'll write select star from order details. If I run it, You can see it has the order number, the product code, quantity of each product, we have the price of each product, then we have the order line number. Okay, so using the product orders and order details, let's perform an inner join. So I'll write select O dot order number, comma, O dot status, comma, I need the product name which I'll take from the products table, so I'll write P dot product name. Now here O, P are all alias name for the tables, orders, products, and I'll use OD for order details, comma, since we want to find the revenue, we actually need to find the product of quantity ordered into price of each product. So I'll use a sum function, and inside the sum function I'll give quantity ordered multiplied by the price of each item. I'll use an alias as revenue, then I'll use my from clause, from orders as O, inner join order details as I'll use an alias name as OD, on I'll write O dot order number is equal to OD dot order number, I'll use another inner join, and this time we'll join the products table. So I'll write inner join products as P on P dot product code is equal to OD dot product code. And finally I'll use the group by clause and group it by order number. Alright, let me run this. Okay, there's some mistake here, we need to debug this. It says you have an error in your SQL syntax, check the manual. Alright, okay, I think the name of the tables is actually orders and not order. Alright, now let's run it. Okay, there's still some error. It says classic models dot product doesn't exist. So again, the product name is, the table name is products and not product. So let's run it again. Alright, there you go. So we have the order number, the status, the product name, and the revenue. This we got it using inner join from 3 different tables.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now talking about left joins, the SQL left join statement returns all the rows from the left table and the matching rows from the right table. So if you see this diagram, you can see we have all the rows from the left table, that is A, and only the matching rows from the right table, that is B. So you can see this overlapped region, and the syntax for SQL left join is something like this. So you have the select statement and then you give the list of columns from table A, which is your left table, then you use the left join keyword followed by the next table, that is table B, on the common key column. So you write A dot key is equal to B dot key. Okay, now in our classic models database we have 2 tables, customers and orders. So if you want to find the customer name and their order ID, you can use these 2 tables. So first let me show you the columns that are present in customers and orders. I think orders we have already seen. Let me first show you what's there in the customers table. Okay, so you can see we have the customer number, the name of the customer, then we have the contact last name, the contact first name, we have the phone number, then there's an address column. There are 2 address columns actually. We have the city name, the state, and we have other information as well. And similarly we have our orders table. So I'll write select start from orders. So I'll write select star from orders. If I run this, you can see these are the information available in the orders table. Okay, so let's perform a left join where we want to find the customer name and their order IDs. So I'll write select c dot customer name, or let's say first we'll choose the customer number, comma, then I want the customer name, so I'll write c dot customer name. Then we have the order number column which is present in the orders table, and let's say I also want to see the status. Then I'll give my left table, that is customers as C, left join, orders as O on C dot customer number equal to O dot customer number. Let's run it. Okay, again there is some problem. Alright, so the table name is customers. Let's run it. So there's another mistake here. This is customer number, so B is missing. Cool. Let me run it. Alright, so here you can see we have the information regarding the customer number, then the respective customer names, we have the order number and the status of the shipment. So if I scroll down, you'll notice one thing, there are a few rows you can see which have null values. This means for customer number 125 and for this particular customer name there were no orders. And similarly if I scroll down, you will find a few more null values. You can see here there are two null values here. For customer number 168 and 169 there were no orders available. Alright, now to check those customers who haven't placed any orders, you can use the null operator. So what I'll do is here I'll just continue with this. I'll use a where clause and write where order number is null. Now let me run this. Okay, so here you can see there are 24 customers from the table that don't have any orders in their names. Okay, now talking about right joins. So SQL right join statement returns all the rows from the right table and only matching rows from the left table. So here you can see we have our left table as A and the right table as B. So the right join will return all the rows from the right table and only the matching rows from the left table. Now talking about the syntax. So here you can see we have the select statement. Followed by the select statement, you will have the list of columns that you want to choose. From table A, right join table B on the common key column from both the tables. Alright. Now to show how right join works, I'll be using two tables, that is customers and employees. So let's see the rows of data that are present in the customer table first. So I'll write select star from customers. Let's run it. So here you have the customer number, the customer name, then we have the phone number, the address of the customers. You also have the country to which the customer belongs to, the postal code, and the credit limit as well. Similarly, let's see for the employees table. Here I'll change customers to employees. Let's run it. Okay, so we have the employee number, the last name, the first name, we have the extension, the email ID, the job title, and also reports to here means the manager. Okay, so based on these two tables, we'll find the customer name, the phone number of the customer, and the email address of the employee, and join both the tables, that is customers and employees. So let me show you the command. So I'll write select c dot customer name, comma, then we have c dot phone. I'll give a space here. Next, I want the employee number from the employee table. So I'll write e dot employee number, comma, e dot email from customers as C, right join employees as E on e dot, my common key column is employee number here, so I'll write e dot employee number is equal to C dot, we have sales representatives employee number, and I'm also going to order it by the employee number column. Okay, so you can see I have my customer name selected from the customers table, the phone number of the customer, then we have the employee number and the email address. So let me run it. Okay, there's some problem. Alright, so the table name is customers actually. Let's run it once again. There you go. So you can see here we have all the values selected from our right table, which is the employees table. You can see right join employees, which means your employees table is to the right, and then we have the customer name and phone numbers of the customers from the customer table, which is actually your left table. So you have a few employee numbers such as 1002, there's 1056, which don't have any customer name or phone numbers. Okay, so there's another popular join which is very widely used in SQL, known as self joins. So self joins are used to join a table to itself. So in our database we have a table called employees. Let me show you the table first. Alright, so here you can see we have the employee number, the last name, the first name of the employee, we have the email ID, and here if you see we have a column called reports to. Now this you can think of as the manager column. So the way to read is, for example, for employee number 1056, the manager is 1002. So if you check for 1002, we have Dane Murphy. Then if I scroll down, let's say for employee number 1102, for employee number 1102, the manager is 1056. So here you can see who is at 1056. You have Mary Patterson. Similarly, if I scroll down, let's say for employee number 1188, we have the manager as 1143. Now if I check the table at 1143, we have Anthony Bow. So the employee Julie Firelli reports to Anthony Bow. Alright, now suppose you want to know who is the reporting manager for each employee. So for that you can use a self join. So let me show you how to join this employees table. I'll write select, and then I'm going to use a function called concat. Within brackets I'll start with my alias name, that is m dot, then I'll write last name. I'm going to concat last name followed by a comma, then I'll have my first name. I'll close this bracket, and then I'm going to give my alias name, let's say manager, comma. Next I'm going to concat the same last name and first name, and this time I'm going to use a separate alias, let's say E, which stands for employee. So I'll write E dot last name, comma, and within single quotes I'll give my comma, and then I'll write E dot first name. I'll close this bracket. I'll give an alias as, let's say, employee. From, I'll write employees as E, inner join employees as M on M dot, I'll use my common key column as employee number, so I'll write M dot employee number is equal to E dot, here I'm going to use the reports to column, and then I'll order it by, let's say, manager. Okay, now let's run this. There you go. So you have your two columns as manager and employee. So for employee Louis Bonder, the manager is Gerard Bonder. Similarly, if I scroll down, you have there are multiple employees reporting to this particular manager. Similarly, we have our manager as Anthony Bow, and we have different employees who are reporting to this particular manager, and so on. Alright, now moving ahead. Now let's see what a full join is. So SQL full outer join statement returns all the rows when there is a match in either left or right table. Now you must remember that MySQL Workbench does not support full outer join by default, but there's a way to do it. So by default, this is how the syntax of full outer join looks like. Now this statement will work on other SQL databases like Microsoft SQL Server, but it won't work on MySQL Workbench. I'll show you the right way of using full outer join on MySQL Workbench. So to show full outer join, I'm going to first use a left join, and then we'll also use a right join, and finally we'll use a union operator. So the union operator is used to combine the result set of two or more select statements. So first of all, let me write C dot customer name. So for this example, I'm using the customer table and the order table, comma O dot order number. So I just want to know the customer name and the order number related to the customer. From, I have customers as C, left join, I'll write orders as O on C dot customer number is equal to O dot customer number. Let me just copy this, and after this I am going to use my union operator. So union operator is used to merge results from two or more tables. So basically this performs a vertical join. And next I am going to use my right join operation. So here instead of left join, I'll write right. Rest all looks fine. Let me just run it. There you go. So we have successfully run our full outer join operation. You can see we have the different customer names and the order that each customer had placed. Alright. So that brings us to the end of our demo session. So let me just run through whatever we did in this session. So first we created a database called SQL Joins. Then we created two tables like cricket and football. Then we had inserted a few rows to each of these tables. Then we used this table to learn about inner join. Next, we used a database called classic models. It had multiple tables, so we explored all of these tables like products, there was product lines, orders, customers and employees, and learned how to use inner join, left join, self join, right join, as well as full outer join.
If you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who elects to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's Data Engineering Postgraduate Program from Purdue University in collaboration with IBM. The link in the description box and the pinned comment should take you to the program being offered.
So, what is SQL Join? In relational databases, the information you want to retrieve is often stored in various different tables. In such scenarios, you'll need to join these tables to view data in a much better way. This is where SQL Join comes into picture. SQL Joins is widely used clause in SQL essentially to combine and retrieve data from two or more tables based on related columns, or you can say common fields between them. Now consider two tables here. Table 1 has 3 columns A, B, C and 3 records. Let's say for reference we'll take them as 1, 2, 3. Similarly, table 2 also has 3 columns B, C, D and 3 records 3, 4, 5. Here I've taken a different color combination to represent values that are present in various columns. Now instead of querying each table every time to retrieve data, I'll simply join these two tables and this will be the following resultant table. Also make sure when you're joining two tables, it should compulsorily have a common column. Here C is the common field which forms the basis to join these two tables here. Why we use SQL Join? Flexibility. SQL Join allows the user to access and manage records from more than one table easily. Let us understand with an example. Consider Mercedes-Benz, which is one of the leading car manufacturers in the world, and let's say they want to access the records of their customers from the database. Now in the database, let us take they have various different kinds of tables such as customer table, order table, vehicle table. Now if they want to get the vehicle details of so and so customer XYZ, for that they have to first query the customer table to get the customer ID. Now once they get the customer ID, they have to query the order table to get the order ID. And finally, with the help of order ID, they can get the vehicle details. Now as you can see, this is a time-taking process and hectic at the same time. Now instead of that, I'll just simply join these tables, which will allow the users to combine rows from two or more tables based on different types of conditions. In this way, you can access and manage your records easily. Data redundancy. SQL Join allows the user to maintain data redundancy as much as low as possible so that we can maintain the amount of data anomalies, that is the duplicate values that are repeated in various tables in the database. Finally, efficiency. SQL Join executes the query faster and shows the result much more quickly, because instead of using various subqueries for each and every table individually, we can just simply join two tables using a simple single query. Types of SQL joins. SQL joins are broadly classified into 4 types. They are inner join, outer join, left join, right join, and additionally we also have cross join, which is not that significant in its usage because most of the times we use the first 4 joins. Now that we have gone through different types of SQL joins, let us discuss each of them in detail. Firstly, let us discuss about SQL inner join. SQL inner join joins two tables based on a common column and selects records that have matching values in these columns. Now when the condition is applied for these columns, the query checks all the rows of table 1 and table 2. Only the rows that satisfy the join predicate are included in the resultant table. Let us now understand the syntax of the SQL inner join. The syntax is followed as select table 1 dot column 1, table 1 dot column 2, table 2 dot column 1, and so on. From table 1 inner join table 2 on table 1 dot column equals to table 2 dot column. Now inner join syntax basically compares rows of table 1 with table 2 to check if anything matches based on the condition provided in the on clause. And when the condition is met, it returns matched rows in both tables with the selected columns in the select clause. Let us now discuss about the SQL outer join. SQL outer join, or else it is called as SQL full join or full outer join, is used to get all the rows which are present in both the tables. That means it will return all the records which are present in either left table, that is the table 1, or the right table, that is table 2, even if there are no matching records present in both the tables. Let us now understand the syntax. The syntax remains same, that is select table 1 dot column 1, table 1 dot column 2, and so on up to table 2 dot column 2. From table 1, full outer join is the keyword that we use here. Table 2 on table 1 dot column equals to table 2 dot column. Now here you have to mention the same or the similar column name in the after the on predicate statement. Next, we have SQL left join. Left join or left outer join, also known as left join, results in a table containing all the rows from the table on the left side of the join, that is the first table, and only the rows that satisfy the join condition from the table on the right side of the join, that is the second table. Any missing values for the rows from the right table in the result of the join tables are represented by null values. Let us look at the syntax. The syntax is followed as select column list, that is the column that you want to display in your table. Now make sure you maintain the syntax of the column list, that is the table name dot column name, otherwise it will throw an error. So let me just repeat the syntax. The syntax is select column list from table 1. The keyword that we use here is left join table 2 on table 1 dot column equals to table 2 dot column. So in this way you can use the left join to display the records. Next, finally we have the SQL right join. Now right join or right outer join is opposite to that of the left outer join. Now it follows the same rules as the left join, and the only difference is that all the rows from the right table and only the conditions satisfying the rows from the left table are present in the resultant table. That means it will return all the rows from the right table and all the matching records that are present in the left table. The syntax remains the same, that is select column list that you want to display in your table from table 1. Right join is the keyword we use. Table 2 on table 1 dot column equals to table 2 dot column. Now to sum up all these different SQL joins and how they work, I've taken a graphical representation of two different tables here which will help us visualize the real-time working of SQL joins. Now consider table 1 here, which is columns A and B and records two different records, let's say record 0, record 1, and similarly we have table 2 which have columns A and C and two records, that is record 0 and record 2. Now if you apply left join, and by the definition of left join, it will only return those values which are present in the left table and the matching records that are present in the right table. Now here the matching value that are present in both the tables is 0 and the values that are present in the left table is 1. And if you consider the right join, it will match the records from both the tables and it will display only the values from the right table. That is the reason it is being displayed the record 0 and the record 2. And if you look at the inner join, it will match the values from both the tables. Now the common value that is present in both the tables is record 0. And if you finally look at the outer join, it will return all the values from both the tables irrespective if they are matching or not. That is the reason all the records, that is record 0, record 1 and record 2 are being displayed.
So let's start with what is a subquery. So a subquery is a select query that is enclosed inside another query. So if I show you, this is how the basic structure of a subquery looks like. So here, whatever is present inside the brackets is called as the inner query, and whatever is present outside is called the outer query. So first, the inner query gets executed and the result is returned to the outer query, and then the outer query operation is performed. Alright, now let's see an example. So we have a question at hand, which is to write a SQL query to display department with maximum salary from employees table. So this is how our employees table looks like. It has the employee ID, the employee name, age, gender, we have the date of join, department, city and salary. Now to solve this query, my subquery would look like this. So I'll first select the department from my table, that is employees, where I'll use the condition salary equal to, and then I'll pass in my inner query, which is select max of salary from employees. So what this does is it will first return the maximum salary of the employees in the table. Then our outer query will get executed based on the salary returned from the inner query. So here the output is department sales has the maximum salary. So one of the employees from the sales department earns the highest or the maximum salary. If you see in our table, the employee is Joseph, who earns $115,000 Alright, and Joseph is from the sales department. Now let's see how this query works. So here we have another question, which is to find the name of the employee with maximum salary in the employees table. So this is our previous employees table that we saw, and to find the employee who has the maximum salary, my subquery would look something like this. So I'm selecting the employee name from my table, that is employees, where I'm using the condition salary equal to, and then I'm passing in my subquery or the inner query. So first I'm selecting the maximum salary. This will return a particular value, that is the highest salary from the table. And if you see our table, the highest salary is $115,000. So our query becomes select employee name from employees where salary equal to $115,000. So the employee name is Joseph here, and that's the output. Now if you want to break it down, here you can see first the inner query gets executed. So our SQL query will first execute the inner query that is present inside brackets, select maximum salary from employees. The result is $115,000, and then based on the returned result, our outer query gets executed. So the query becomes select employee name from employees where salary equal to $115,000, and that employee is Joseph. Alright, now we'll learn the different types of subqueries. So you can write subqueries using select statement, update statement, delete, and insert statement. We'll explore each of this with the help of example on my MySQL Workbench. So let's learn subqueries with the select statement. So subqueries are majorly used with the select statement, and this is how the syntax looks like. You select the column name from the table name, then you have the where condition followed by the columns that you want to pass, the operator, and inside that you have the subquery. So here is an example that we will perform on our MySQL Workbench. So in this example, we want to select all the employees who have a salary less than average salary for all the employees. This is the output. So let's do this on my MySQL Workbench. Alright, so let me log into my local instance. I'll give my password. Okay, so you can see I'm on my MySQL Workbench. So let's start by writing our subquery using the select statement. Okay, so for this demo session, we'll be using a database that is subqueries. You can see it here. I have a database called subqueries. So I'll use this subqueries database, and we'll create a few tables as well. Okay. If I run it, now we are inside the subqueries database. So let me just show you the tables that are present inside this database. I'll write show tables. If I run it, okay, there are two tables, employees and employees underscore B. We'll use this table throughout our demo session. Alright, now for our select subquery, we want to fetch the employee name, the department, and the salary whose salary is less than the average salary. So we will be using the employees table. So let me first show you the records and the columns we have in the employees table. So I'll write select star from employees and run it. Okay, you can see here we have 20 rows of information. We have the employee name, the employee ID, age, gender, date of join, department, city, and salary. So this is the same table that we saw in our slides. Okay, now for our subquery, I'll write select. I want to choose the employee name, the department, and the salary. There should be a comma here instead of a period. Next, I'll give my table name, that is employees, where my salary is less than, and after this I'll start my inner query or the subquery. I'll write select average salary. So I'm using the AVG function to find the average salary of all the employees from my table, that is employees. If I give a semicolon and run this, you'll see the output. So we have total 12 employees in the table whose salary is less than the average salary. Now if you want, you can check the average salary. So the average salary is $75,350. Now the employees who have a salary less than the average salary, so these are the people. Alright, now moving back to our slides. Okay, now let's see how you can use subqueries with the insert statement. Now the insert statement uses the data written from the subquery to insert into another table. So this is how the syntax looks like. So you write insert into table name followed by select individual columns or star from the table, use the where clause, and then you give the operator followed by the inner query or the subquery. So here we will explore a table called products table. We are going to fetch few records from the products table based on a condition, that is the selling price of the product should be greater than $100. So only those records will fetch and put it in our orders table. Alright, so we are going to write this query on my MySQL Workbench. So let's do it. I'll give my comment as update subquery. Alright, so first of all, let's create a table that is products. So I'll write create table products. Then we'll give our column names. The first column would be the product ID of type integer. Then we have the column as item or the product, which is of type varchar 30. Next we have the selling price of that product. The selling price will be of type float. And finally we have another column which is called the product type. And again, product type is of the data type varchar. I'll give the size as 30, close the bracket and give a semicolon. Now let's just run it. Okay, so we have successfully created our products table. Now let's insert a few records to our products table. So I'll write insert into products followed by values. I'll give 4 records. The first product ID is 101. The product is, let's say, jewelry. Then the selling price is, let's say, $800, and the product type is, it's a luxury product. Next, let's insert one more product detail. The product ID is 102. The product is, let's say, t-shirt. The price is, let's say, $100, and the product type is non-luxury. Next, I'll just copy this to reduce our task. We'll edit this. The third product's ID is 103. The product is laptop, and let's say the price is $1,300, and it's a luxury product. I'll paste again, and finally I'll enter my fourth product, which is, let's say, table, and the price is $400, and it's a non-luxury product. I'll give a semicolon and we'll insert these 4 records to our products table. You can see we have inserted 4 records. Let's just print it now. So I'll write select star from products. If I run it, you can see we have our 4 products ready. Now we need to create another table where we are going to put some records from our products table. So that new table is going to be the orders table. So I'll write create table orders. Now it will have 3 columns. The order ID will be of type integer. Then we have product underscore sold. This will be of type varying character of size 30, and finally we have the selling price column. This will be of type float. Let's create our orders table. The table name should be orders, and there is some mistake here. Okay, you should close the brackets. Okay, let me run it. So we have our orders table ready. Now let's write our insert subquery. So I am going to insert into my table, that is orders, and I'll select the product ID, comma, the item and the selling price or the sell price from my table, that is products, where I'll write product ID in. I'll write my inner query, select prod ID or the product ID from products. Next, I'll give a where clause where the selling price is greater than $1,000. So let me tell you what I am going to do here. I am going to insert into my orders table the product ID, the item name and the selling price from my products table, where the product ID has this condition. So let me first run this condition for you, which is select prod ID from products where the selling price is greater than 1000. If I run this, okay, there is some issue here. The column name is actually prod ID. Now let's run it again so that we can see the product IDs of the products which have a selling price greater than 1000. So it is 101 and 103. Now let's run the entire query. There is another mistake here. Let's debug the mistake. Now this should be product ID instead of product underscore in. Let's insert again. Alright, so we have successfully inserted 2 records to our table, that is orders. Now let's see the orders table. I'll write select star from orders. If I run it, there you go. So there were 2 products from our product table, that were jewelry and laptop, which have a selling price greater than $1,000. So the selling price for jewelry was $1,800 and for laptop it was $1,300. So this is how you can use a subquery using the insert statement. Alright, now going back to our slides again. Alright, now let's see how you can use subqueries with the update statement. Now the subqueries can be used in conjunction with the update statement. So either single or multiple columns in a table can be updated when using a subquery with the update statement. So this is how the basic syntax of an update subquery looks like. So you write update table followed by the table name, you set the column name, you give the where operator, and then you write your inner subquery. So we are going to see an example where we will use this employees table, and using this employees table we will update the records of the salaries of the employees by multiplying it with a factor of 0.35 only for those employees which have age greater than 27. So we are going to use a new table called employees underscore b for this as well. So let's see how to do it. So I'll give my comment as update subquery. Before we see the subquery, let's see what we have in the table employees underscore b. This is basically a replica of the employees table. There you go. It has the same records that our employees table has. We are going to use both the employees table and the employees underscore b table to update our records. So I'll write update employees set salary equal to, let me bring this to the next line. I'll write set salary equal to salary multiplied by 0.35, where age in, then I'll write select age from my other table, that is employees underscore b, where age is greater than or equal to, let's say, 27. Alright. So let me run through this query and tell you what we are going to do. So I'm going to update the records of the employees table specifically for the salary column. So I'm checking if the age is greater than 27, then we'll multiply the salaries of the employees with a factor of 0.35 in the employees table. Let me just run this, then we'll see our output. Okay, so it says 18 rows affected, which means there are total 18 employees in the table out of the 20 employees whose age is greater than 27. Now if you see, I'll write select star from employees. You can see the difference in the salaries. If I scroll to the right, you can see these are the updated salaries. Okay. Now if you check for employees who have an age less than or equal to 27, for example Marcus, whose age is 25, his salary is the same. We haven't updated his salary. Then if you see, if we have, okay, there is one more employee, Maya. We haven't updated the salary of Maya because the age is less than 27. Alright. Now let's go back to our slides again. As you can see, we got the same output on our MySQL Workbench. Now let's explore how you can write subqueries with the delete statement. Now subqueries can again be used in conjunction with the delete statement. So this is how the basic syntax of a delete query using subquery would look like. You write delete from the table name, where clause, the operator value, followed by the inner query in within brackets. So here we are going to use the employees table, and what we are going to do is we'll delete the employees whose age is greater than or equal to 27. So let's see how you can do it. Alright, so I'll give my comment as delete subquery. So we'll follow the syntax that we saw. I'll write delete from my table name, that is employees. I'll write where age in, and then I'll start my inner query or the subquery. I'll write select age from employees underscore B, where age is, let's say, greater than or equal to 32, or let's say the age is less than or equal to 32. Close the bracket and I'll give my semicolon. Let me first run the inner query for you so that you get an idea of the employees who are less than 32 years of age. So there are 9 employees in the table who have an age less than or equal to 32. So we are going to delete the records. If I run this, okay, it says 9 records deleted. Now let's print or display what we have in the employees table. If I run this, there you go. So if you see the age table, we have total 11 employees now, and all their ages are greater than 32 because we have deleted all those employees who had an age less than or equal to 32. Okay, so let me show you from the beginning what we did. So first we used our subqueries database, then we used our employees table. So we started by looking at how you can use the subquery with a select statement. This should be insert instead of update. So we learned how to write an insert subquery. We use 2 tables, products and our orders table. Moving ahead, we saw how to write subqueries using the update command. So we updated the salaries of the employee by a factor of 0.35 for those who had an age greater than or equal to 27. And finally, we saw how to use the subquery using the delete statement. So we deleted all those records for the employees whose age was less than or equal to 32. So I am on MySQL Workbench. So first let me go ahead and create my connection. I'll give my password. Alright, now this will take you to my SQL editor. Okay, so first and foremost, let me create a new database called triggers. So I'll write my SQL command as create database triggers. Let me run this. Okay, so you can see here one row affected. I have created my database, that is triggers. Next, I'm going to move inside this database, so I'll write the command use triggers. Let's run this. Okay, now inside this triggers database we'll be creating our different tables. So let's check if we have any tables. I'll use the command show tables. Now you see there are no tables in this database. Alright, first let's see how before insert trigger works. So for before insert trigger, we'll create a table called customers and verify the age of each customer. So I'll give a comment before insert trigger. So let me go ahead and create my customers table. I'll write create table customers and I'll give my column names as cust_id, which is customer ID. This is going to be an integer. Then we have the age of the customer. This is again an integer, and we'll have the name of the customer. The name of the customer will be of varchar type. I'll give the size as 30. Alright, let's create this table. Okay, so we have successfully created our customers table. Now moving ahead, I'm going to write my before insert trigger command. So we'll start with a delimiter. So a delimiter is a marker for the end of each command. Next, I'll write my create trigger followed by the trigger name. I'll give a valid trigger name such as age_verify. I'll write before trigger. It should be before insert on. My table name would be customers. Then I'll write for each row if new dot age is less than 0, then set new dot age equal to 0, which means while inserting your values to the age column, in case the age value is negative, we'll convert the age to 0. I'll give a semicolon and then I'll write end if. I'll give another semicolon and I'll close the delimiter. Now let me run this. Okay, so we have created our trigger. Now let's insert a few values onto customers. So I'll write insert into customers values 101, which is the customer ID. I'll give the age as 27 and let's say the name of the customer is James. Let's insert another record, give the value as 102, and this time I'm purposely giving the age as -40, which is less than 0, so that you can see the output clearly. I've given the customer name as Amy. Let's insert two more records. The customer ID with 103 has an age of 32, and let's say the name is Ben. I'll give another comma, and finally we'll insert our fourth customer record. The customer ID is 104. The age I'm giving as -39, which is less than 0 again, and let's say the customer name is Angela. Alright, now let me run this. Okay, so we have successfully inserted 4 rows of information to our customers table. Now let's see the difference. Since we had created a age verify trigger which would change the values of the age column in case the age value is less than 0. So now that we have inserted 4 records to a customer, so let's see what we have in the customers table. Now let me run it. There you go. So if you see this, for those customers where the age was less than 0, such as 102 and 103, you can see here our trigger has automatically converted those values to 0. If you can see the trigger we had created, we had set our new age to 0 if the age was less than 0. And this is the output we get. So here we looked at how a before insert trigger works. Alright, now moving ahead, let's understand how an after insert trigger works. So I'll give a comment here as after insert trigger. Now in this example, we'll create 2 tables, customers and message. Now the trigger will be fired if the birthday column has a null value in the customers table. You will get a message to update your date of birth. Okay, so first let me create my customers table. Now since we already have one customers table, I'll name it as customers 1 and let me give the column names. So the first column would be the ID column. This is going to be an integer and I'll use the auto increment parameter, and this will be my primary key as well. Next we'll have the name of the customer. This is going to be of type varchar and I'll use not null constraint. Next we'll have the email ID of the customer. This is again going to be of varchar type, and the column we are interested in is the birthday column. So I'll write birth date. This is going to be of type date. Okay, so let's create our table. Alright, now we'll create our second table, which is going to be message. Let's create the columns. This will have ID, int, and I'll use the auto increment operator. Next we'll have the message ID. This is going to be of integer type. We'll have a column called message. This will be of varchar type, let's say 300 characters and not null, and I'm going to set my primary keys as ID and message ID. Let's create our second table then. So we have some error here. Let's debug the error. Okay, so I forgot to close the bracket here. Alright, now let me run this table. Alright, so we have created our message table as well. Next I'll write my after insert trigger command. So I'll write delimiter. Next I'll use create trigger command. So I'll write create trigger. My trigger name would be check underscore null underscore date of birth. After insert on customers 1 for each row begin if new dot birth date is null, then we are going to insert into our message table. I'll give the columns as message ID and message values, new.id, comma, I'm going to use the concat function where I'll give my message, let's say hi, followed by the name, followed by, let's say, please update your date of birth. Okay, now I'll write end if. I'll close the delimiter. Okay, so let me go to the top and recheck if we have created our trigger correctly. So I have my trigger name after insert on customers 1 for each row begin. If our new birthday has a null value, then we'll pass in a message saying hi, the name of the customer, then the message would be please update your date of birth. Alright, so let's run the trigger. Okay, now the next step is to insert a few records to customer table. So my name of the table is customers 1. Okay, I'll give the column names as name, email and birth. Okay, we'll pass in a few values. So our first customer's name, let's say, is Nancy, comma, I'll give my email ID, let's say nancy@abc.com. Now let's say I'm purposely passing the date of birth as null. I'll give a comma. My next customer, let's say the name of the customer is Ronald, and then I'll give the email ID such as ronald@xyz.com, and this time I'm going to pass in the date of birth, let's say 1998 November, and let's say 16th. Okay, now we'll add another customer, let's say Krish. We'll give the email ID of Krish, so krish@xyz.com, and let's say we'll give the date of birth as 1997 08/20, and finally we'll add one more record for another customer, let's say Alice. I'll give the email ID as alice@abc.com, and this time I'll purposely pass the date of birth as null. Alright, so let's run the insert query. Okay, now let me display the message table for you so that you can see the output and how our after insert trigger works. There you go. So if you see this, we had inserted 4 rows of information, out of which the first customer ID and the fourth ID had null date of birth. So for those two values you have the message as hi Nancy, please update your date of birth, and then you have hi Alice, please update your date of birth. Now you can give a space between hi and the name of the customer. Alright. Now moving ahead, let's understand how before update trigger works. So I'll give a comment here as before update. Okay. Now to show you how before update works, first we'll create a table called employees. Alright. So let me create my table, that is create table employees. I'll give my column as employee ID. This is going to be an integer type and it will be my primary key. Next we'll have the employee name. This will be of varchar type, and let's say the size would be 25, comma, then we'll have the age of the employee. Age will be of integer type, and finally we'll have the salary of the employee. Salary will be of type float. Let's create this table. Alright, now the next step is to insert a few records to our employees table. Okay, so here on the notepad I have already written my insert query. So I have inserted nearly 7 records. So let me paste it here. Alright, I'll just go ahead and run this insert query so that we'll insert 7 employees to our table. Okay. Next, we'll write our before update trigger command. So first and foremost, I'll write my delimiter followed by the create trigger command. I'll give my trigger name as update underscore trigger. Let's bring this to the top. Okay. I'll use before update on my table, that is employees. For each row I'll write begin. My condition would be if new dot salary is equal to, let's say, $10,000. I'll write then set new dot salary equal to $85,000. I'll give a semicolon. Then I'll use else if new dot salary is less than $10,000, then I'll set new dot salary to, let's say, $72,000. I'll give a semicolon. I'll end the if statement. I'll close the delimiter by giving a semicolon. Okay. So if you see the employees table, we have the salary values here. Now in case while updating the table, if the salary is equal to $10,000, we'll set the new salary to $85,000. Else, if the salary is less than $10,000, we'll set the salary column values to $72,000. So let's go ahead and run this trigger query. Alright. Now let me use my update command. So I'll write update employees. I'll write set salary is equal to, let's say, $8,000. Now if you see our trigger query, we are setting the salary to $8,000, which is clearly less than $10,000. So our new salary would be $72,000. So let me run this. Okay. So you can see here 6 rows affected. So I'll write now select star from employees. Let's run this. Okay. If you see this, we have converted our salary column to $72,000 since we updated the salary to $8,000, and according to our trigger query, if it's less than $10,000, the salary should be $72,000, which you can see here. Alright, now moving to our final demo. This time we are going to explore how before delete trigger command works. So in this example, we'll create a table called salary. We'll store the deleted record in a new table using the before delete trigger. So first, I'll give my comment as before trigger. Comments are always useful since they make your query more readable. So let me now create my salary table. So I'll write create table salary. I'll give my column names as EID, which is employee ID, and I'll set it as primary key, comma, I'll give another column, let's say valid from, which means the date from which this salary was effective. This is going to be of type date and not null. And then I'll have the amount. Amount will be of type float, and again not null constraint. Let me run the create table command. Okay, so we have created our salary table now. The next thing is to insert a few values. So I'll write insert into salary. I'll give my column names as EID, comma, valid from, comma, amount. I'll write values. My first employee ID would be 101, followed by a date, let's say 2005, May, and 01, which is 1st of May 2005. Let's say the amount is $55,000. I'll give another row of information. This time the employee ID is 102, and I'll give a valid from date. Let's say the amount is 68,000. I'll give another employee ID, let's say 103, 2006, 0901, and let's say the amount is $75,000. Okay, let's run this. Alright, you can verify also, so I'll write select star from salary. You can see here we have inserted 3 rows of information. Alright, the next step is to create another table that will store the deleted rows. So I'll write create table. Let's say the name of the table is create, or let's say salary delete. I'll write salary del. Now this will have the ID, the type would be integer, and primary key. I'll also use the auto increment operator. Next we have the EID, which is of type integer. I'll write valid from date and not null. Then I have the amount column, which is of type float and not null. My final column would be deleted at. The data type will be timestamp. I'll use the default constraint as now. So this will return the time and the date at which the record was deleted. Alright. Let me create this table. Okay. Finally, let me write my before delete trigger command. So I'll first declare my delimiter. Let's say this time I'm using the dollar symbol. I'll write create trigger. My trigger name would be salary underscore delete before delete on my table, that is salary. For each row I'll write begin. Next, let's insert into salary delete. I'll give my columns as employee ID, valid from, and amount. Now we'll insert a few values. I'll write values old dot eid, comma old dot valid from, comma old dot amount. I'm going to close with the delimiters. Alright, so let's run our before delete trigger. Alright, now let me go ahead and delete one of the records from the salary table. So I'll write delete from salary where employee ID is, let's say, 103. Let me run this query. Okay, so you have successfully deleted one of the records in the table. Now if you see our other table, that is salary delete, you will find this information present in the salary delete column. So we had deleted one row of information, that is for employee ID 103, which you can find it here. Now the final column, that is delete at, shows the time at which the information was deleted or the row was deleted. Alright, so let me go to the top and just give you a recap of what we did in this demo. So first we created a database called triggers. Then we started with before insert trigger, where we inserted customer table, and then we verified the age of the customers. So we saw if the age was less than 0, then we set the age to 0. We inserted a few records to the customers table, and purposely we inserted some negative age records, and then we converted this age records to 0. Then we learned how an after insert trigger works. So we created two tables, customers 1 and message. So wherever the customer's date of birth was missing, we passed in a message saying, hi, the name of the customer, please update your date of birth. Alright, now moving ahead, we saw how before update trigger works, and finally we learned about before delete trigger.
If you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who elects to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's Data Engineering Postgraduate Program from Purdue University in collaboration with IBM. The link in the description box and the pinned comment should take you to the program being offered.
Python, as you must be aware, is a high-level general-purpose programming language that can be used for data science and analytics. In this tutorial, we will learn how to work with databases and tables using SQL with Python. To do this demo, we will be using our Jupyter Notebook and the MySQL Workbench. You can see it here. So we will write our SQL queries in the Jupyter Notebook with Python-like syntax. If you don't have MySQL or Jupyter Notebook installed, so please go ahead and install them first. While installing the MySQL Workbench, you will be asked to give the username and password. Let me show you. So I am on my MySQL Workbench. So once you connect, it will ask for the username and the password. So I have given my username as root and password you can give while installing it. We will be using the same user ID or the username and the password to make our connection. So let's get started with our hands-on demonstration part. First and foremost, let me go ahead and import the necessary libraries. I'll give a comment as import libraries. Alright, so first I'll import MySQL.connector. Next, from MySQL.connector, I'm going to import my error method or the error module. Next, I want to import pandas as PD. So let's run this. Okay, there is some error here. This should be capital E and not small e. Alright, you can see I have imported my important libraries. Now I'm going to create a function that will help us create a server connection. So I'll write my user-defined function by using the def keyword. I'll write create underscore server underscore connection. This is going to be my function name, and it will take in 3 parameters. First is the host name, next is the username, and then we have the user password. Alright, I'll give a colon, and then in the next line I'm going to define a variable which is going to be connection, and I'll assign it to a value called none. Now we'll be using exception handling techniques to connect to our MySQL server. The try block lets you test a block of code for errors, and the except block will handle the errors. So I'll write try and give a colon, and then I'm going to reassign the connection variable to a method which is mysql.connector.connect. Now this mysql.connector.connect method sets up a connection, so it establishes a session with the MySQL server. If no arguments are passed, it uses the already configured or default values. So here we are going to pass in 3 parameters. The first is the host name. I'll write host equal to host name, which is host underscore name. I'll give a comma, then I'll write user equal to user underscore name. Next will be my password, and I'll assign the value user underscore password. Alright, now I'm going to use a print statement and write MySQL database connection successful. After this, I'll give my except block. So I'll use the keyword except. Here I'll write error as err, give a colon, and then I'm going to use the print statement. Here I'm going to use some print formatting techniques using the F letter. I'll write error colon, and I'll use curly braces, give err, and then I'll close the double quotes. After this, I'm going to return my connection. Alright, let me give a comment here. We are going to assign our password, so we need to put our MySQL terminal password. So this password you assign it while installing MySQL Workbench. I'll write pw and I'll give my password, which is simply @12345, and then I'm going to give my database name. So I'll give database name. Here I'm going to write db equal to, this is the database I want to create, which is going to be MySQL_Python. Let me just scroll this down. Okay, now I'll say connection equal to, I'll pass in my user defined function name, which is create server connection, and the parameters, which are going to be localhost, that is my host name, my username, which is root, and then I'll give pw, which is my password, that is exactly simply @12345. Let's just run it now. Okay, there is an error here. We need to remove this double quotation. Alright, made another mistake here. This should be root. Okay, you can see here MySQL database connection successful. Alright, next we are now going to create a database, that is MySQL_Python. So I'll give a comment, create MySQL_Python database. Again, to create this database, I'm going to create another user defined function using the def keyword. I'll write the function name as create database, pass in the parameters as connection, query, give a semicolon, and in the next line I'll write cursor equal to, I'm going to make the connection, so I'll write connection dot cursor, and I'll give the parenthesis. So this MySQL's cursor of MySQL connector Python is used to execute statements to communicate with the MySQL database. The MySQL cursor class initiates objects that can execute operations such as the MySQL statements. Okay, next I'm going to again use my try and except block. So I'll write try, give a colon, and here I'm going to use cursor dot execute. Within that I'm going to pass in my query. Next I'll use a print statement, and the message I'm going to display is database created successfully. After this I'm going to write my except block. I'll write except error as err, give a colon, and then I'll use a print statement. I'll write print, I'll use the formatting again, error colon, and I'll write within single quotes, I'll give curly braces err, and then I'll close the double quotes. Next let's use the variable create underscore database underscore query, and here I'm going to write my SQL query to create the database. So I'll write create database, and followed by that I'll give my database name, which is going to be MySQL Python. Okay. After this, I'll call my function, which is create database, and I'll pass in the parameters. The first one is connection, and next the query is create underscore database underscore query. Let me just copy it and I'm going to paste it here. Alright, so what I'm doing here is I am creating a new function, that is to create a new database with the name MySQL Python, which you can see it here. Now this function takes in two parameters, connection and query. I'm using the connection.cursor function, which is often used to execute SQL statements using Python language. And then I have created my try and exit blocks. So this try block statements will try to create my new database, which is MySQL Python. In case it fails to create the new database, the exit block will work. So here I am writing my SQL query to create a new database, which is create database followed by the database name, and I am assigning it to a variable which is create database query, and then I'm calling my function create database and passing in the two parameters, connection and the query. Alright, so let's just run it. Alright, you can see here it has created my database successfully. Now you can verify this by checking the MySQL Workbench or the MySQL shell. You can see on the MySQL Workbench here on the left panel under schemas, there is a database called MySQL Python. Let me just expand it. Now we haven't created any table, so it's not showing it now. The next step, we are going to connect to this database. So let's go ahead and connect to our database that we have just created. I'll write the comment as connect to database. Now to connect to our database, I'm again going to create a user defined function using the def keyword. I'll write create underscore db, which is for database underscore connection, and the parameters it will take is the host name followed by the username, then we have the user password, and finally we have the database name. I'll give a colon. In the next line I'm going to create my variable which is connection, and then I'll assign it to a value none. After this I'm going to use my exception handling techniques. So I'll write my try block first. I'm going to reassign my connection variable using the MySQL connector method. So I'll write MySQL dot connector dot connect. So this method will take in the parameters. So first it will take the host name. I'll write host equal to host underscore name. I'll give a comma. Next it will take the username, so user equal to user underscore name, give another comma. Next it will take the user password. I'll use passwd equal to user underscore password. I'll give another comma, and this time it is going to be the database name. So I'll write database equal to db underscore name. Now let's use the print statement, and the message we are going to print is MySQL database connection successful. Alright, finally we'll write my except block. I'll write except error as err, give a colon, and then I'll use the print statement. F, within double quotes I'll write error, colon, within single quotes, curly braces I'll write ERR, and will close the double quotes. Finally, this function will return the connection value. Alright, let's run it, and there you go. It has run successfully, so we have connected to our database. Now it's time for us to execute SQL queries. I'll give another comment saying execute SQL queries. Alright. Now to execute our SQL queries, I'll use another user-defined function, which is execute underscore query, and I'll pass in the parameters as connection and query. I'll give a colon. I'm going to write cursor equal to connection dot cursor. Now this is used to establish a connection and run SQL statements. Next, we'll use the try and except block, so I'll write try cursor dot execute. This will take in one parameter, which is going to be my query, and then I'll write connection dot commit, which is another method. Now let's use the print statement. So I'll write print. Let's say the message would be query was successful. And then we'll write our except block, which is except. If the try block doesn't work, throw an error using the print statement. Within double quotes, inside the curly braces, I'll write ERR and close the double quotes. Alright, so let's run it. Okay, so we have successfully created our various functions that were needed to create a database, establish a connection, and to execute our queries. Alright, now it's time for us to create our first table inside the MySQL Python database. So to do that, I'm going to write my create command in SQL. So first we are going to assign our SQL command to a Python variable using triple quotes to create a multi-line string. So let me show you how to do that. I'll write my variable name, which is going to be create orders table. It is always recommended to use relevant variable names to make it more readable. And now I'm going to use triple quotes. So the triple quote will ensure I can create my multi-line string. Inside the triple quote, I am going to write my create command, which is create table. Here I am going to create an orders table first, and inside the orders table I am going to create my column names. The first column would be the order ID. It is going to be of type integer, and I'll assign this order ID as my primary key column. I'll give a comma. Next, the second column would be customer underscore name. The customer name column would be of type varying character, so I'll write varchar and I'll give a size of 30, and this is also going to be not null. Moving ahead, my fourth column would be the product name column, so I'll write product underscore name. Product name will be of type varying character. The size is, let's say, 20, and it is also not null. Next, I'm going to create my fourth column, which is the date on which the item was ordered or the product was ordered. So I'll write date ordered. The data type will be date. Next, I'll create a quantity column to keep track of the number of quantities that were ordered. This is of type integer. My next column would be unit price, which will basically have information about the price of each unit of product. Unit price can be of type float. And finally, I'll have the phone number of the customer. I'll write phone number. Phone number can be kept as of type varying character. I've assigned a size of 20. Now let's give a semicolon and we'll close the triple quotes. Alright, so this is how the syntax would look like. Next, to run this, we are first going to call our createDB function. So let me give a comment as connect to the database. I'll write connection equal to create underscore db underscore connection. My parameters would be my host name, which is localhost, my username, which is root, comma, my password, and then my database name, which is MySQL underscore Python. So I'll write just db. Alright. Finally, let's execute this query using the execute underscore query function that we had created earlier. This takes in two parameters. The first one is connection, followed by the variable name, which is create orders underscore table. Let us run it. Okay, there is some error here. Let's see what's the error. Okay, so here we have put 4 double quotes. This should be triple quotes. Now let's run it. Okay, there is another here. Let's debug it. It says name cursor not defined. Let me just roll it to the above cell. If you see here in our execute underscore query function, instead of cursor, I have written cursor. So R is missing. Let's rerun this. And now let's run this again. There you go. You can see here MySQL database connection successful. Even our query was also successful. Now if you want to recheck if the table, that is orders, was created or not, you can check it on the MySQL Workbench. So let me show you how to do it. So I am on my MySQL Workbench, and under MySQL underscore Python database you have something called as tables. Let me just right click and I'll select refresh all. There you go. You can see this arrow. Just click on this arrow and here you can see we have a table called orders. So we have created a table called orders. Now you can check the columns as well. You have the order ID, the customer name, product name, ordered date, quantity, unit price, and phone number. Now it's time for us to insert a few records to this table, which is orders. Now to insert records, I'll give a comment as insert data. I'll start with the variable name. Let's say the variable name is data underscore orders. I'll give triple quotes. Next, I'll write my insert into command. So I'll write insert into my table name, that is orders, followed by values, and now I'll start entering my records for each of the rows. So first I'll give 101, which is the order ID. Then I'll give the customer's name, let's say Steve, and the product he had ordered is, let's say, laptop. Then I'll give my date in which the item was ordered. let's say it is 2018. I'll choose 06 as the month and the date is, let's say, 12. I'll give another comma. This time we'll pass in the quantity, which is 2. Let's say the price of each laptop was $800, and we'll give a phone number. This is random. Let's say 6293730, let's say 802. Alright. Similarly, I am going to insert 5 more records of different customers and their items that they have purchased to this table orders. So here on my notepad I have my rest of the 5 records. Let me just copy it and we'll paste it in the cell here. This will save us some time. Okay, let me recheck if everything is fine. I'll give a comma here. Alright, so we have 6 customers in our table which have their customer IDs from 101 to 106. We have Steve, Jaws, Stacy, Nancy, Maria and Danny. You have the different items they have purchased: laptop, books, trousers, t-shirts, headphones and smart TV. This is the date on which they had ordered this item, the number of quantities they had ordered, and then we have the unit price and some random phone numbers. So let's create the connection now. I'll write connection equal to, I'll write create underscore db underscore connection. Then I'll going to give my same parameters. Let me just copy it from the top, which is localhost, the host name, root is my username, then we have password and the database name, and then I'll use the same query as above, which is execute query. I'll copy this, paste it here, and instead of create orders table variable, I'll put as data underscore orders. So this will store my insert into command. You can see the variable I've used here is data underscore orders. Now it's time, let's just run it. Alright, there was some mistake here. Let's debug it. Again, this should be triple quotes and not 4. Now let me rerun it again. There you go. You can see here MySQL database connection successful and my query was also successful. Now we'll create another user-defined function which will help us read query and display the results. So I'll write my function name as def read underscore query. This will take in 2 parameters, connection and query. Then I'll write cursor equal to connection.cursor. I'll put my result as none, and then I'll use my try and accept block. I'll write try cursor dot execute. This will take in 1 parameter, which is query, and then I'll give another variable which is result equal to cursor dot fetch all. Now this fetch all method will return all the results in the table. I'll write return result. Next we'll use the accept block. So I'll write accept error as err, give a colon, and I'll use my print statement. Scroll this down. I'll use my formatting f error, give a colon followed by a space, within single quotes inside curly braces I'll give err and close my double quotes. Let's run it. Alright, so now we are all set. Now we are going to use our select clause, having, whereby, then we'll see how to use order by clause, some inbuilt functions, we'll update some records, delete some records, and do a lot of other stuff. So let's start with our first query. So our first query is going to be using the select statement. Alright, so suppose I want to display all the records that we have inserted into our orders table. So the way to do is, I'll assign my query to a variable, let's say Q1. I'll give triple quotes. Within triple quotes, I'll write select star from orders. I'll give a semicolon followed by the triple quotes. Now we'll establish the connection. So let me just go to the top and I'll copy this line, which is to connect to our database. I'll paste it here. Now we'll create a variable called results that will store the result of this query, and we are going to assign this variable to our function, that is read query, and this read query will have two parameters, the connection and the variable name, which is Q1 for the query. Next, to display, I'm going to use a for loop. I'll write for results for result in results print, I'll say result. Now we are done. Let's just run this query. There you go. You can see here we have successfully printed all the rows in our table, which is orders. You can see we have 6 records in total. Now we are going to explore a few more queries. So let me just copy this and we are going to edit in the same query. I'll paste it here. Next, let's say you want to display individual columns from the table and not all the columns. So let me create the variable Q2. Now instead of star, I'm going to display only the customer name and let's say the phone numbers of the customer. So I'll write phone underscore number. Alright, the rest all remains the same. Let me just recheck it, and here instead of Q1 we'll put Q2, and let's run this cell. Alright, you can see here now we have displayed only 2 columns. The first column is the customer name and then we have their respective phone numbers. Okay, now let me just paste that query again. Now we are going to see how you can use an inbuilt function, that is, in our table we have the order date, and from the order date we are only going to display the different years that are present in the order date. So to do that, I am going to use the year function. I'll edit this query. Instead of Q1, I'll make it Q3, and here I am going to write select year, which is my function name, from my column which is date ordered, from orders, and here I'll change this to Q3. Q1, Q2, Q3 are basically query 1, query 2 and query 3. Let's run it. There you go. So we have successfully extracted the different years present in the order date column. Now if you want to display the distinct or the unique dates present in the column, you can use the distinct keyword in the select statement. So the way to do it is, I'll write select distinct, give a space, the rest of the query remains the same, and here instead of Q3 I'll write Q4. I'll make this as Q4. Let's run it. You can see 2018 and 2019 are the unique year values that are present in the order date column. Okay, now moving ahead, let's write our 5th query, and this time we are going to explore how you can use the where clause. So I'll change this to Q5 before I write my query. So let's say you want to display all the orders that were ordered before 31st of December 2018. So to filter this, we are going to use the where clause. So I'll write select star from orders. Next I'll write where my date underscore ordered is less than, within quotes I'll give my date value, which is 2018 December 31st. So all the items or the products that were ordered before 31st of December 2018 will be displayed. So let's run it. Alright, you can see here there are 3 orders in our table which have been ordered before 31st of December. Now moving ahead, we want to display all the orders that were made after 31st of December. So here what you can do is, I'll just copy the above query again. I'll copy this line. So instead of less than 31st of December 2018, I'll make it as greater than. So every order that was placed after 31st of December will be displayed. If you run it, so you can see here there are 3 orders in our table which were ordered after 31st of December 2018. Now moving ahead, let's write a 7th query. Now let's see how the order by clause works in SQL. So you can filter your results based on a particular column or sort it based on a particular column. So this is going to be my query 7. I'll write it from scratch again. Let's say you want to display all the columns from the table. So I'll write select star from orders. Then I'm going to use order by unit price. I'll give a semicolon. Let's run this query and see the output. Now if you see the result here and you mark the unit price column, the result has been ordered in ascending order of unit price. You see here it starts with the lowest price and then goes on with the highest price towards the end. Now if you want to order it in descending order, you can use the keyword DESC. So this will ensure your top or the most expensive products appear at the top and the least expensive products appear at the bottom. Alright. Next. Now let's see how you can create a data frame from the given table. So as you know, using Jupyter Notebook and Pandas, you can create data frames and work on it very easily. So with this table also we can create our own data frame. So for that, let me create an empty list first. I'll write from db equal to, I'll assign this as an empty list. So we are going to return a list of lists and then create a Pandas data frame. Next, I'll write my for loop. I'll write for result in results. I'll assign result to list of results. So I'm converting the result into a list and then I'm going to append it to the empty variable or the empty list, which is from underscore db dot append. I'll append the result to my empty list. Next, we need to pass in the columns now that will be part of our data frame. So I'll write columns equal to this column. I'll pass it within a list. So I'll give my first column as order ID. Then we have the customer name. Next, I have my product name. Then I have the date on which it was ordered. Give a comma. Then we'll have the quantity column. Let me write it in the next line. Next, we have the unit price column. And finally, we have the phone number column. So I'll write within double quotes phone number, and this we are going to assign it to a data frame. So I'll be using pd dot data frame, which is my function to convert a list into a data frame. My variable I'm going to pass is from underscore db, and I'll write my next argument is columns equal to my variable name, that is columns. Finally, let's display the data frame, which is df. Alright, so here I am creating a empty list first, and then I am creating a for loop, and I am appending the results to my empty list. Here you can see I have created my column list, and using pd.dataframe I am converting the list into a data frame. If I run this is append and not appends. Alright, you can see we have our data frame ready. This is the index column, it starts from 0 onwards, and then we have the different column names. Okay, now let's see how to use the update command. Now suppose you want to change the unit price of one of the orders, you can use the update command. So the way to do it, I'll first create my variable, let's say update, and I'll give 3 quotes or triple quotes. Then I'll use my update command, which is update followed by the table name, that is orders. Next I'll write set, let's say unit underscore price. If you see this, let's say I want to set the unit price of trousers from $50 to, let's say, $45. I want to update this particular record. So I'm going to write set unit price column equal to $45, where the order ID equal to 103. So this query will update the third row in our table, which is order ID 103. So it will update from $50 to $45. I'll close the triple quotes, and now I'll use the connection queries again. Let me just paste it here. Alright, I'll delete these 3 lines of code, and instead of that I'll put execute underscore query, and this will take into parameters as always, which is going to be connection followed by the variable name, that is update. Let's run it. You see here it says MySQL database connection successful, query was successful. Now you can recheck that. To do it, let me just go to the top and we'll just copy our first query, which is Q1. I'll copy this and I'll paste it here. Let me just rename this now. This will be Q8, and I'll change this as well. I'll write select star from orders, where my order ID equal to 103. Let's see the unit price of 103 now. You can see here instead of 50, now we have updated it to $45. Alright, now the last command we are going to say is how you can delete a record from the table. I'll write delete command as my comment. Now to delete a query, I'll first give my variable name, which is delete underscore order, and I'll pass in within triple quotes. Next I'll write my delete query, which is delete from my table name, that is orders. Then I'll give my where clause, where let's say I want to delete my order ID 105. Let me just go to the top and explain you again. So if you say this, we want to delete the order ID 105, which was for customer name Maria, and she had ordered headphones. We want to completely remove this particular record. So I have my delete query ready. Now let me just create my connection and display the results. So I'll go to the top and I'll copy this connection command, which also has the execute query command, and I'll paste it here. And I'm going to make a change here. Instead of update, we'll write delete underscore order. Everything looks good. Let's just run it. You can see our query was successful. And now if you want to print it, let me just show you. I'll just copy this. We'll paste it here. I'll make this as Q9. I want to verify if my order ID 105 was deleted or not. Instead of this statement, I'll write select star from orders, and here I'll change this to Q9. If I run this, you can see it here. You can mark order ID 105 was deleted and it no more appears in this table. Alright, so this brings us to the end of the demo session on SQL with Python. Let me just scroll you through what we did. So first we imported the important libraries, MySQL connector, then we imported the error function, then we imported pandas using PD. We learned how to create a server connection to MySQL database. We created a new database, that is MySQL_Python, and now we connected to that database. We created a function to execute our queries. We saw how you can write a create table command. Then we inserted a few records to our orders table. We created a read_query command to read the queries and display the results. Then we started exploring our different SQL commands one by one. We saw how to use select query. Then we selected a few individual columns from our table, followed by using a inbuilt function which was year. Then we saw how to use the distinct keyword. After that, we used our where clause to filter our table based on specific conditions. We saw how to order your results based on a particular column. Then we saw how you could convert the table into a data frame using pd.dataframe function. Finally, we learned how to use the update command and the delete command.
Now, what is SQL Server? In any application development today, in any computer application which we develop, database SQL Server plays a very important and pivotal role. SQL servers are used for persistence of information in your database, which can be retrieved, mined, data mined, or you can query it at a later point of time. The benefit of having any SQL server is that data is persisted in a structured, efficient manner so that it can be retrieved later quickly and meaningfully. So SQL Server is a relational database management system in which you can create tables, two-dimensional tables, and connect them using referential integrity like primary key, foreign key, and other kind of integrity constraints you can maintain in this relational database. SQL Server is developed and marketed by Microsoft. So this is a Microsoft product, but it is compatible with all the technologies which you might be using or you might want to use, like Node.js, Java, etc., where you want to connect your middleware application server with Microsoft SQL Server. Now, what is the usage of SQL Server? Apart from the definition which I just shared with you for maintaining and building databases, persistent databases, there are other usages also which I'll explain you. Now, the first one is SQL Server Analysis Service, which is used to analyze data. Now, the SQL Server Analysis Service, or SSAS, is a multi-dimensional analysis tool that features online analytical processing, provide powerful data mining capabilities, and deeper dimensions to business information within a relational database. Multi-dimensional analysis is an online analytical processing technique, OLAP technique, that produces the ability to analyze large quantities of data by storing data in axes and cells instead of traditional relational two-dimensional view in rows and columns. SSAS places predictive analytic capabilities in the hands of information workers by creating an instant connection to backend data using familiar applications such as Microsoft Excel, SharePoint, etc. for analysis, visual representation, and collaboration. The next is SQL Server Reporting Services, which is used to generate reports. Now, SSRS is a framework of reporting mechanisms such as the report builder, report designer, report manager, and report server that work together through a web interface to enable the development of concise, interactive reporting solutions in print or web format. Report Builder and Report Designer are two SSRS components for generating reports. Report Builder is a simple solution for the information worker or business user to create quick reports without the need to understand the core structure of the data. The Report Designer is a tool for developers because it adds complexity to custom reports development and you create data models in it. Using this tool requires an understanding of the Business Intelligence Development Studio shell in Visual Studio and the underlying structure of the data. So you have to be aware of it thoroughly. According to Microsoft, the report server is the core process engine in SSRS that manages the processing and delivery of reports using processors. The report manager is an administrative tool that controls reporting services through a web interface. Now let's talk about another important component, which is SQL Server Integration Services, SSIS, which is being used to perform ETL operations, extract, transform, load. Now SSIS is the data warehousing arm of the SQL Server, equipped with superior extract, transform and load capabilities, ETL. It provides the vehicle for moving data from different data sources to another and changing the data if necessary. The three components in the SSIS platform for starting the data integration process are the Import and Export Wizard, SSIS Designer, and SSIS API Programming. The Import and Export Wizard simply transfers data from source to destination but does not include data transformation capabilities. It's the SSIS Designer is an integrated component of the Business Intelligence Development Studio used for the development and maintenance of integration service packages. SSIS API Programming module allows you to code SSIS packages using any number of programming languages. So there are a lot of features which are available to you in order to manage your data, create your data pipeline, structure it, build visualization reports, perform ETL operations, etc. So it's an entire solution, enterprise solution. Now let's see what are the different kind of SQL Server editions. Microsoft provides 5 editions with various tools and services and pricing options as per the needs. So the 2 editions of SQL Server which are free of charge are SQL Server Developer and SQL Server Express. Now the Developer SQL Server edition works and functions exactly like an enterprise SQL edition. The only difference is the license is used for testing and development purpose only. This edition is generally used by developers to build and test applications on top of the SQL Server, but they can't take it to production. SQL Server Express edition now is the free entry-level database version and is ideal for learning and building desktop and small server data-driven applications, but not meant for any serious computation, while also having incredibly limited features. Now the other editions are used for commercial purposes. SQL Server Web Edition. It is a low total cost of ownership option for web hosts and web value add providers to provide scalability, affordability and manageability capabilities for small to large scale web properties. The SQL Server Enterprise Edition delivers comprehensive high-end data center capabilities with blazing fast performance, unlimited virtualization, and end-to-end business intelligence enabling high service levels for mission-critical workloads and end-user access to data insights. This version has all the features required for big data. Now, SQL Server Standard Edition, this delivers basic data management and business intelligence database for departments and small organizations to run their applications and support common development tools for on-premise and cloud enabling effective data management with minimal IT resources. Now let's look at some advantages of SQL Server instances. Its installation is of different versions on one machine. You can maintain different installations. The maintenance of production, development and test environments can be done separately. You can maintain a standby server. So installation is streamlined. It can be installed via setup wizard and the prerequisites updates are detected and downloaded by the installer automatically. The complexity of the installing the software is minimized significantly because of automatic installation of updates. Other components such as analytical and database services can be installed separately afterward. Automatic updation also reduces maintenance costs quite significantly. SQL Server 2008 uses policy management to detect security policies that are not compliant. So this feature allows only authorized personnel access to the database. Security audits and events can be written automatically to log files. MS SQL Server has built-in transparent data compression feature also along with encryption. Users don't need to modify programs in order to encrypt the data. The MS SQL Server has access controlled coupled with efficient permission management tools. Further, it offers an enhanced performance when it comes to data collection. Okay, and coming to the cost reduction, so it has lower cost of ownership. SQL Server includes effective data management and data mining tools along with disk partitioning. Your server's optimum maintenance can be ensured by following effective data management practices. These practices also help you ensure the availability and recoverability of data.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let's move on to creating a database in SQL Server. So I have installed the default SQL Express on my machine, and now I'm gonna create a database called SQL Tutorial. So let's create a database called SQL underscore tutorial. Okay. Now I will write certain queries on top of it. First, I'll create a table customers. Let's create a table customers which has columns customer ID, which is its primary key, the name, which has varchar, customer ID is int, age, which is an integer, gender, male, female, will notify it with one character, address, which is generally a large string value, so we'll keeping it varchar 20, item, which is varchar 15, and price. Okay, so let's create this table. Okay, so now if you see, this table has been created, dbo.customers. Now all the relevant columns which I created here has been present. Now I have prepared a script to insert some sample values so that we can query this. So I have inserted around about 20 values. So let's just check whether my data is present. I'll do a select star from my customer tables, and you can see now the 20 rows with the customer ID, customer name, age, gender, address, the item which the customer has purchased, and the price at which he has purchased. Now let me show some variations of the queries which we can perform. Now select star means you have selected all the columns. I only want to select some selective columns like customer name and gender. So I can also do that. You just need to give the name of the customer and the gender column. Next query. I want to check what is the distinct values of the gender in my customer tables. So I will only get two values, which is male and female. So there is no other value apart from M and F in my customer table. Next, I have a query where I want to find which all are the customers who have purchased an item. Who all are the customers who have purchased an item which is having price greater than 250 rupees. Okay, great. So out of 20, only 12 are the customers who have purchased a price item which is greater than 250. And you can see all the items which are listed over here are greater than 250. Next, okay, I want the customers who are living in New York. Okay, fine. I just have to change the where clause where instead of the price, I am now looking at the address which is in New York. Now it is also possible that you can apply another filter. Okay, people living in New York but age is greater than 28. Perfect. I only have two customers who are living in New York but having age greater than 28, or I want the female customers who are purchasing items greater than 380 rupees. Okay, only 1 out of 20. Okay, Elena. Now we saw examples of AND condition. There is also possibility that, okay, you want female customers or customers who are greater than age 30. So you will get both the records, age greater than 30 or female customers. Both the records will come. Or customers who are in Chicago or purchasing items greater than 420. So these are the examples of OR conditions. Now let's take another example of NOT. Now I want that the customers who are not purchasing price less than 650, the reverse, right? Greater than 650. So I'll get this answer. Or I want the customers who are not living in New York, apart from New York, any other address. So all these customers are there. Okay. So now these are the examples which I showed you are the examples where you can play around, you can filter data applying the where clause. Now let's take another example of aggregated functions in SQL. Now amongst the list of customers, the data set of customers which I have, I want to know what is the minimum age of my customer. Minimum age is 18 years. So the minimum age amongst all the customers is 18 and the maximum is, I can just change it to max, is 61. So the age range of my customers who are purchasing are from 18 to 61. Okay, now another example, hypothetical example. I want the average age of my customers where customer ID is greater than 105. Okay, so if you see, select star where customer ID is greater than 105. I have 15 customers and amongst these, my average age of my customers is 35. Similarly, instead of average, I can take the sum total of the age above 105, which is 539, sum total. Okay. Now, I'll show you an example of like. I want the customers list where addresses which consist of letter E in their address, anywhere in the string, beginning, in the middle, because I have like is a keyword, like percentage, E percentage means E can come in any part of the string. Okay. And if I just change this example, I remove the percentage from here, it means that I want the customers whose addresses end with E. So only Pune will come into the picture. Okay. So this is the difference. Now coming, select star from customers where age which between 20 and 30. So I want all the customers which have belonged to age between age 20 and 30 inclusive. So 20 and 30 both are inclusive. So it means the customers with age 20 and all 30 will also come in this result set. Next example, I want the count of total customers in my data set, which is 20. I inserted 20. So I know now I have 20. I want the count of male customers. Oh, out of 20, 19 are male. Okay, great. And if I group by, now let's see an example of group by. So I want the count of customers grouped by address. So how many are living in Boston, how many in Chicago, Detroit, Miami, New York and Pune. So I have a customer wise total count total basis the address group by. Okay. So it's a very important concept. You can group by any column and then you can do a measure count, a sum, an average. You can do any aggregated calculation basis the other columns which are not in the group by. So like another example, I want an average age per address. So in Boston, the average age of my customer is 34 who are purchasing items, Chicago 35, Pune 43. So like that, you can do some analysis. This is all data analytics. Now let's see another example. I want to filter data now after doing a group by. It's not, so please note this is different from where clause. In where clause means filtering data before grouping. Having clause is used once you want to filter data after grouping. So you are doing a group by address, count of customers, and then only those cities should come where count is greater than 2. Okay. So the customers, only those addresses are listed where customers count is greater than 2. Okay. Now this is an example of inner queries. You want group by customer name and age, only those customers having age greater than the average age of overall. Okay. So my average age, if I say my average age from customers is 36. So overall, all the customers which are more than 36 should come over here, listed over here. And that's what has happened. Okay. Now let's talk about order by. It's like sorting. You want to order by address. So it has ordered by default B, C, D, M, N, P, which is ascending. And if you apply keyword descending, so it will do the reverse way. Similarly, I can order by age, which is descending, highest age first, lowest below. Or you can do order by multiple columns where order by address descending and then same address, within the same address the customers should be ascending. So addresses are descending, but within the address the customer names are sorted in ascending fashion. A first, B, C, D, like that. Now there's an inbuilt function in SQL Server reverse. If you see, this has reversed the name of the customers. It's in reverse fashion. Okay, the characters are reversed. Another example is where you are, now this is not on the table, this is just a sample query where you are replacing vegetable with fruit. So orange is a fruit, so you have replaced vegetable with a fruit. It is just you don't need a table. You can just also write such queries where you don't need a table. Okay. Then there is a function called ltrim, which will remove all the blanks from the left hand side. rtrim, which will remove the blanks from the right hand side. Okay, let me read an rtrim. It will remove the blanks from the right hand side. And then there is trim function, which will remove from both the sides, left and right. Now let's take an example of update command. I want to update the name of my customer whose customer ID is 103. First, let's check what's the name. So customer name right now is Whipple. I want to change it to Smith, and if I requery, it is changed to Smith. Okay, so this is an example of update. Now if I want to delete, let me check who is at 101. I want to delete customer 101. Joseph, I will delete it. And now if I want to check, okay, there's no customer at 101. Okay, now let's take another example. This is like another example of inbuilt function ASCII. It will give you the ASCII code of the character, ASCII A, ASCII 4, etc., etc., right? So there is n number of possibilities. There's an n number of queries which you can write.
If you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who elects to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's Data Engineering Postgraduate Program from Purdue University in collaboration with IBM. The link in the description box and the pinned comment should take you to the program being offered.
So currently I am on my MySQL Workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright, so this is my MySQL Workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright, so first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause, or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee from my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this, this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select, I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than, I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with two different tables. So suppose you want to display some information that are present in two different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using two tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table, and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table, that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay. Now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay. So first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players, and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write &&. Next, I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was $. Next, I'll write delimiter and give a semicolon. Now the semicolon suggests This is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top underscore players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top underscore player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top underscore players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now, there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment, stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL underscore IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement, where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records, so I'm using this limit keyword and my variable var which I created here. I'll end my select statement. I'll end my stored procedure with /, and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is SP underscore sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is SP underscore sort by salary, the other 2 were top underscore player and top underscore players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is SP underscore sort by salary. and inside this I'll give my parameter, which was actually VAR, and this VAR we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay. Now, instead of a select statement inside a stored procedure, you can also use other statements. Let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /. Then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in 2 parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says 1 row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay, so suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore employees, using the into keyword. let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter 2/. I'll write create procedure followed by the procedure name. It is going to be sp_count employees, and inside this I am going to give my out parameter and the variable name, that is total_EMPs, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total_EMPs. From my table, that is EMP_details, where sex is equal to F, which means female. I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp_count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table EMP_details. So I've used my out parameter and I'm creating a new variable called total_EMPs. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I am storing it in total_EMPs. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure sp_count employees. Now to call it, I'll write call the name of the procedure, that is sp_count employees. Within brackets I'll pass in the parameter as @f_emp. I'll give a semicolon. Then I'll write select @f_emp as female employees. Okay, so as is an alias name. Let's run this one by one. First I'll call my procedure and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now, there are mainly 3 types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we'll learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright, so I'll write create table student . Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name. The data type would be variable or varying character. Size I'm giving it as 30. Finally, we have the marks as floating type. So let's create this table, which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting. If any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. Age is 13. The name is Dave. And let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50 because when we created our trigger, we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case, our trigger name is marks_verify_st. I'll just paste this here, and if you run this, it will automatically delete your trigger. I'll give this as a comment. Okay. Now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views, I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all, let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here, let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country, and other information. Now I'll write a basic view command using this customer table. The way to write is, I'll write create view followed by the view name which is cust_details. Then you write as select. I'm going to select a few column names from my original customer table, which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright. I'll write from my table that is customers. If I run this, my view that is cust details will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view, I can write select star from followed by the view name that is cust_details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that, I am going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside Classic Models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there's some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name that is product_description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table I want the text description of the products. So I'll write from products table. I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay, so here we have used an inner join to fetch specific columns from both the tables, and our view name is product underscore description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay, now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cust details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be okay. So instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright, now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay. I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over. I want to partition it by department. So I'll write partition by department, which is DEPT, and I'll give an alias as total salary, so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright. Now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary. So I'll write order by salary. I'll give the alias as row num, give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID, which is of type integer, and we have the student name, which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table. So I'll write insert into demo values. I'll give 101. The name is Shane. Give a comma. I'll insert the second student name, 102. The name is Bradley. I'll give a comma. This time for 103 we have 2 records. Let's say the name of the student is Herath. I'll give a comma. I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the 5th student, which is Kevin, we have 2 records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over, within brackets I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table, that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, now if you see here, there is just one student in the name Shane. We have one student in the name Bradley. But here if you see, for Herath, the second record it says 2, which means there are 2 records for Herath. And if I scroll down, there is 1 record for Nathan and there are 2 records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when 2 or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table, that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable, that is var underscore a, as an alias name, let's say test rank, from my table, that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable a101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function has assigned the same value, which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function, which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column, that is salary descending. I'll give an alias as highest underscore salary from my table, that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table, Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function, that is first underscore value, followed by the name of the employee inside my first value parameter. I'll write over, here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table, that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, so that brings us to the end of this demo session on our tutorial. So let me just scroll through and show you what we did from the beginning. First we learnt about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database, which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. We learned how to create stored procedures. So we learned how you can use the in operator or the in parameter as well as the out parameter in stored procedure. After stored procedure, we learned another crucial concept in SQL, which is called triggers. Now triggers are also a special kind of stored procedures. So we saw how to write a before insert trigger. You can see it here. Next, we learned how to delete a trigger. We also saw how to work with views in SQL. So views are basically virtual tables that you can create from existing tables. We also saw how you can use views using two different tables and an inner join. And we learned how to display views, how to rename view names, how to delete a view, and finally we explored a few Windows functions.
If you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who elects to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's Data Engineering Postgraduate Program from Purdue University in collaboration with IBM. The link in the description box and the pinned comment should take you to the program being offered.
Injection. So let's begin with what is SQL injection. As the name suggests, SQL injection vulnerability allows an attacker to inject malicious input into a SQL statement. So SQL stands for Structured Query Language, which is a language used by an application to interact with a database. Now, normally this attack is targeted towards a database to extract the data that is stored within. However, the vulnerability does not lie in the database itself. The vulnerability will always lie in the application. It is the developer's prerogative of how to develop the application, how to configure it to prevent SQL injection queries from happening. A database is created to answer questions, and if a question is asked, it is supposed to answer it. Database needs to be configured for some amount of security, but the vulnerability, the flaw here for SQL injection will always lie in the application itself. It is how the application interacts with the database that needs to be modified, that needs to be maintained by the developer rather than just configuring the database itself. So the attacker at this point in time, when they send a query to the application, will form a malformed query by injecting a particular command or an operator that is recognized by the SQL language. And if that operator is passed through the application to the database, then the database basically gets cracked or does a data dump because of that unwanted character coming in. So this character needs to be filtered at the application level itself. Now let's look at a quick demo. So what we have done here is I have this virtual machine called OWASP Broken Web Applications Virtual Machine version 1.2. I'm going to power this on. Till this powers on, I'm going to show you where we can download this utility from. So you can just look for OWASP Broken Web Application Project download. You'll find it on sourceforge.net. Click on the link. You can download the Broken Web Application Project from here. This is a 1.9 GB download, and you can have a zip machine directly for VMware or Oracle VirtualBox. Now, this is an application that has been developed by OWASP, which stands for Open Web Application Security Project, which is a not-for-profit organization and periodically releases the most top 10 risks that an application will face for that particular year. So they have given a web application with inbuilt vulnerabilities for professionals like us to practice upon, to develop our skills upon, because doing this in the real world is illegal. I cannot go onto a website to demonstrate how a SQL injection attack works. Neither should you try your hands on it till you become very well rehearsed with it. So to upgrade your skills, to upskill yourself, please download this machine, host it in a VMware workstation or an Oracle VirtualBox, and you can then try your skills on it, right? So just going back to the browser here, if I open up a new tab, you'll see that this machine has booted up and has an IP address called 71.132. So if I just go onto that IP address and I type in 192.168.71.132, and you'll see the OWASP Broken Web Application Project, and there are a lot of training applications, realistic intentionally vulnerable applications, old versions of real applications, and so on and so forth. So there is a lot of applications inbuilt over here that you can try your skills upon. We are going to try to use the OWASP utility over here. This gives you the OWASP top 10 risks for 2010, 2013. 2017 is the latest one so far, but the difference between 2013 and 2017 is that some of these have changed, but not all of them. The order has changed a little bit, but you can see that SQL injection is on the top A1 amongst the injection attacks, right? And you can see there are multiple types that have been given here: the SQL injection for extracting data, or SQL injection for bypass authentication, or insert your injection attacks, blind SQL injection. And then there is a tool called SQL Map, which is available freely on your Linux machines, Kali Linux or Parrot Linux, whichever you want to use. for your practice targets, and so on and so forth. So if I just take you here for bypass authentication, and this is a regular login page that an application may have, right? You look at a username, you look at password, you type that in, and you log in. So let's say I don't know a password here. I'm just going to type in the username test. Password is PASSWORD. I try to log in, and it shows me that the account does not exist. So the authentication mechanism does work. I did try type in a username and password. It wasn't recognized, so the account does not exist. Now let's try to type in a SQL query. Here I'm going to just give it a single quote, which is an operator that is recognized by the SQL language, which when the database tries to execute will cause the database to dump some data or to bypass authentication in this case. And I'm going to give it a condition, single quote, or 1 = 1 space hyphen space, and I'm going to click on login. Now right now I'm not logged in at all, and we tried our username and password and we weren't able to log in. So now if I log in, you will see that it gave me a status update saying the user has been authenticated, and I'm logged in as admin, got root. So that is what these SQL queries can achieve. I'm going to log out right now, and we are going to look at the basics of SQL injection. So looking at that small demo, now let's look at what types of SQL injections are available. So the first is in-band SQL injection. There are two subtypes within in-band: error-based injection attack and a union-based injection attack. The second type is blind SQL injection attack, where there's a Boolean-based and a time-based attack. And the third one is out-of-bound SQL injection attack. Now, what is in-band SQL injection attack? In-band is where we are either attempting the error-based or the union-based. What is error-based? We send a query to the database, we craft a query to the database, and it generates an error message, and it dumps the error message right in front of us on the screen. That makes us realize that there is a flaw, and there is some information that is dumped on the screen, which we can then further utilize to craft our further queries as we go ahead. Whereas union-based is it is where we combine multiple statements at the same time. So if you look at the URL, earlier in the URL, you would see a large structure in that URL. We can try to add two or more statements within the URL itself to combine them and then confuse the database into executing both the statements together and giving a data dump at the same time, right? So what would an error-based SQL injection look like? If I go back to the same database, which is here, right? And if you remember the username, we gave it a single quote or 1 = 1 space hyphen space. We gave it the condition, right? So basically what it did was a single quote is an operator that goes to the database, selects the default table in the user tables in this database column, and then compares it to the condition that is given. So the condition that we gave was 1 = 1, which is always true. So what it did was it selected the default user table that was available in the database, and instead of comparing it to a password, it compared it to the condition. So if I give it 1 = 2, where the condition is false, and if I log in, you will see that the account doesn't exist, comes back again, because the condition was false, and instead of comparing the user account to the password, it basically compared the user account to the condition. So if I give it a single quote or 1 = 1 hyphen space and log in, you can see that this is a correct condition, and thus we are able to log in. Now, before we even go to that extent, if I just forget the condition over here and I just give it a single quote, the operator, and I send this operator to the database and I click on login, you will see that it generates an error, which is right on top. And it tells us the line, the file where the error happened, and you can see it happened in the MySQL handler.php file. Right? And then it gives us the message, you have an error in your SQL syntax, check the manual that corresponds to your MySQL server version for the right syntax to use. Now, why would a hacker want to do this in the first place? Because there are different types of databases. So there is a MySQL, MS SQL or Microsoft SQL, Oracle SQL, IBM DB2. All of these are variations of the SQL database. they use the SQL language. However, every database has its own command, right? They have their own syntax, they have their own specific commands that are utilized for the database. So in this scenario, the hacker wants to identify what database is being currently utilized so they can craft those particular queries. So now with this injection, with just me sending the code and the error getting generated, I now come to know that we are using a MySQL server and the version of that server is 5.1.73, and the rest of the information about where the handlers are located and so on and so forth. Right, this gives the information to the hacker of how they want to proceed next, what kind of queries they want to create, what kind of syntax they want to utilize. So error-based attack is where you generate these kind of errors and you get this information. The union-based is where you craft your queries within the URL. You can try to combine multiple statements within the input fields and try to generate a response from that. Then we come to Boolean-based SQL injection. Sends a SQL query to the database which forces the application to return a different result depending on whether the query returns a true or a false result. So basically, if the input is false, both the inputs are false, the output would be false. There's one input that is false, the other input that is true, input B, the output would be true, and so on and so forth. Right? So depending on the result from the inputs, the attacker will come to know which input is true. With this, he can then access the database of the website. So you're trying to figure out by sending out multiple inputs and then analyzing the output to see what exactly, which command exactly worked, what was the resultant output of that command. Thus, from this kind of an information, the hacker can infer their next step forward. Then you have time-based SQL injections. Now, there are times when a database administrator or an application administrator has done some security configuration and thus have disabled verbose error messages. Now, what is a verbose error message? The error message that we saw right here is a verbose error message. That means that the message gives out details. The message gives out details about what the database is, the version and whatnot. So if they have sanitized these errors, and you no longer can generate these errors and thus you cannot figure out what database is, then what do you do, right? For example, if I just take you to Simplilearn and take you to a URL that is supposedly not accessible, you can see that it gives a generic error. Oops, like it looks like you have crash landed on Mars. It doesn't give you a verbose error that we saw here. So this gives us a detailed error of what went wrong, where it gives us the database, the version of the database, and where the query went wrong, and etc, etc, etc. Whereas on this side, where there's a lot of security that goes in here, so you can see that it doesn't generate a error. It just get a generic page in front of you. So in that case, what does a hacker do? So the hacker then injects a time-based query in the URL, which allows us to verify whether the command is being executed or not. So we put in a time wait, let's say 10 seconds of time wait. So if the moment we inject the query, if the query times for 10 seconds and then gets executed, that means that the SQL injection is possible. However, if we inject the query and it just gets executed without the delay, that means that the time injection attack would not be possible on that particular site. Out of bound is not a very common attack. It depends on the features being enabled on the database management system that is being used by the web application. So this can be a somewhat of a misconfiguration error by the database administrator, where you have enabled functions and not sanitized them. So you have not done in access controls properly. You have not given account control. So queries should never be executed at an administrative level. They should always be executed at a user level with minimum privileges that are required for that query to be executed. Now, if you're allowing these kind of functions to be enabled at the DBMS, and there is an administrative account that can have access to them. At that point in time, an out-of-bound injection attack is possible. So let's look at how a website works, right? How SQL works on a website. Now, the website is constructed of HTML, hypertext markup language, which would include JavaScripting for functionality, cascading style sheets for the mapping of the website, right? And then React, JS and whatnot for further functionality. Now, when we send a query to the website, it is normally using the HTTP protocol or HTTPS protocol. When the query reaches the application would then go ahead and generate the SQL query. At the client side, you'll have all these scripting languages coming in on the front end that we can utilize to craft queries and then send them across. At the server side, you'll have databases like Oracle, MySQL, MySQL, and so on and so forth that will then execute those queries, right? So just to give you an example, if I use a tool called Postman, what we generally do when we craft a query is we send out a GET request to the website, and then we receive a response from the site with the HTML code and everything. So this is a tool that is utilized by software testers to test the responses that you're going to get from various websites. So on the left hand side, you can see I've used it on quite a bit. Here we have an example for gmail.com. So let's continue with that. So this is a GET request being sent to Gmail. The moment I send it, it's going to create an HTTP request and send it across. The response that I get is this. This is the HTML code for gmail.com, right? These are the cookies. These are the headers that include information. So you can see this is a text HTML character set utilized is UTF-8, and the configuration that has been done with the application, right? So this is where everything comes in. This is the cookie that has been sent with that particular request that I had sent out. Now, if you analyze this query, right? So when we went on to this application and I typed in that single quote and we generated this error, right? You can see that the application converted this into a SQL query. So the query was select username from accounts where the username in quotes, single quotes, and we use the quote, right? The single quote right there. So that's where we use that operator, and that's where the exception error occurred. So these are the kind of queries that are structured by the application and then taken on to the database for execution. When we type in, it is a HTTP GET request with the username and password within that query that is sent to the application. The application converts it into a SQL query, sends it to the database, and the database responds with the appropriate response. So how do we prevent SQL injection in the first place? Use prepared statements and parameterized queries. These statements make sure that the parameters passed into SQL statements are treated in a safe manner. So for example, we saw that the single quote was an operator. This shouldn't be allowed to be utilized in the first place, right? So here, what we are doing here is a secure way of running a SQL query in the JDBC using a parameterized statement. Define which user we want to find. So there's a string, the email comes in. Connection to the database, we are going to figure out how the connection is going to be passed, how it is going to be created. Construct the SQL statement we want to run specifying the parameter, right? So we define how is it going to be created, what is going to be created, what can be passed to the database and what should not be passed to the database. So that is one way of utilizing prepared statements and parameterized queries. Then we have object relational mapping. Most development teams prefer to use object relational mapping frameworks to make the translation of SQL results set into code objects more seamless. So this is an example of object relational mapping where we map certain objects and allow that to be executed. And then escaping inputs. It is a simple way to protect against most SQL injection attacks. Many languages have standard functions to achieve this, right? So you need to be very careful while using escape characters in your code base when a SQL statement is constructed. Not all injection attacks rely on abuse of code characters. So you need to know what characters are being utilized in the configuration that you have created, in the structure that you have created, in the code that you have created, which characters are being recognized as operators. You need to sanitize those operators, and you need to basically ensure that these operators cannot be accepted as user input. If they are, they're weeded out by the application and they never reach the database. Other methods of preventing SQL injection are password hashing, so that passwords cannot be bypassed, the passwords cannot be recovered, passwords cannot be cracked. Third-party authentication, you use OAuth or some other service for a single sign-on mechanism. Thus, you rely on a third party to maintain the security of authentication and what kind of parameters are passed. For example, using LinkedIn logins or Facebook logins, right? For the layman, you normally go onto Facebook and you allow, if you're using a game, right? If you start playing a game, you're allowed to log into the game using your Facebook credentials or your Google credentials. Now that is not just for ease of use, but the game user, the developer, has outsourced the authentication mechanisms to third parties such as Facebook or Google, because they understand that authentication mechanism is as safe as can be. Facebook and Google are wealthy organizations, hire a lot of security experts, and the development for their authentication mechanisms is top notch. Small organization cannot spend that kind of money on security itself, right? So you use a third party authentication mechanism to ensure that these kind of attacks may not happen. Then web application firewalls. Having a web application firewall and configuring it properly for SQL injection attacks is one of the sure shot method of mitigating or minimizing the threat in the first place. So at this point in time, you have realized that the application has some vulnerabilities for SQL injection, and instead of recoding or restructuring the application, you want to take the easier way out or the cheaper way out. So what you do is you install a web application firewall and you configure the web application firewall to identify malicious queries and stop them at the firewall level itself, so they never reach the application, and thus the vulnerabilities on the application don't get executed. Buy better software and keep on updating the software. So it's not necessary that once you have a software, you install it, it's going to be safe for life. New vulnerabilities are discovered every day, every hour, and it may so happen what is secure today may be completely insecure tomorrow or the day after, right? So you need to keep on upgrading the software. If there are no upgrades available and the vulnerability still exists, you might want to migrate to a better software and thus ensure that you don't get hacked, right? Always update and use patches. Organizations keep on sending out updates and patches. As and when they are released, you need to install them to enhance your security postures. And then continuously monitor SQL statements and databases. Use protocol monitors, use different softwares, use the firewalls to keep on monitoring what kind of queries you're getting, and based on those queries, you want to ensure the inputs and the queries that are creating are not detrimental to the health of the software that you have. So the key takeaways that we have seen here in a nutshell are: what is a SQL injection attack? We have seen the types of SQL injection attack, how it works, and how to prevent SQL injection attack. Now we have done a couple of demos.
Firstly, let us understand what is SQL. SQL, as it stands, is defined as structured query language, is basically a standardized programming language that is used to manage databases, and it performs various operations on data in them. Initially created in 1970s, SQL is widely used by many companies and technologies nowadays. SQL is used for modifying database tables and index structures. It is also used in adding, updating, and deleting rows of data. It is also used to retrieve subsets of information from within the database management system. Now, SQL is used to perform various actions such as to insert data, to update data, modify, and delete the data in the database as well. Now, when we talk about SQL, it is important that we talk about relational database systems as well. A relational database system, or RDBMS, is a database system that stores and fetches data in the form of table, that is in the form of rows and columns. Tables are used to store data in relational databases about related objects. Each column contains attributes of data, whereas each row holds a record of unique data known as a key, which helps in making a relationship between different data points that is present in different table, which makes us easy to understand. Now, these relational databases, or RDBMS, are managed using SQL language, to perform various operations. Therefore, SQL codes are used to retrieve information from these relational databases by doing various interactive operations like using join, create, truncate, delete, alter, and etc. Let us now look at some popular SQL databases. Some popular SQL databases that are available are MySQL, Oracle Database, Microsoft SQL Server, SQLite, and PostgreSQL. Now that we have understood what is SQL, let us now understand what is NoSQL. NoSQL database is a non-relational database management system that does not require a fixed schema. That is, the data is not stored in the form of tables in NoSQL databases. Basically, it avoids any joining or creating or scaling the databases in SQL. The major purpose of using a NoSQL database is for distributed data storage, which is having high volumes of data storage needs. NoSQL is used for big data and real-time web applications. Like for example, companies like Amazon, Facebook, Google collect terabytes of users' data every single day. So basically, NoSQL database stands for not only SQL or not SQL, and it is introduced in the year 1998 by Carl Stross. Now, traditional RDBMS uses SQL syntax to store and retrieve data for further insights. Now, instead, our NoSQL database system encompasses a wide range of database technologies that can store structured, semi-structured, as well as unstructured data. Let us now understand why we use NoSQL. We use hierarchical storage structure instead of a table-like structure. That means before relational databases, companies used a hierarchical database system with a tree-like structure for database tables. Now, these early database management systems enabled users to organize large quantities of data. However, they were complex, often required a particular application and in a limited way, which they could uncover the data that is stored. Now, these limitations eventually led to the development of relational database, that is, the data that is stored in tables. So, SQL provided an interface to interact with relational data and allowing the analyst to connect tables by merging on common fields. But as time passed, the demands for faster and more desperate usage of larger datasets became increasingly more important for emerging technologies, for e-commerce and other big giants. For that, NoSQL has became the alternative for everyone. Now, another reason is now we have constant addition of new features and functions in the NoSQL database, right? So that means we know that technology is being rapidly evolved and huge enormous amounts of data has been released on a daily basis, and it's important that we store this data and access in a quick way. Now, NoSQL is the best database to use for large amounts of data or for ever-changing data sets. It is also best used when you have to have a flexible data model or need that don't fit into a relational model. And finally, if you want that there is no relationship between any stored data and you feel it is not important, then you can use NoSQL as well. Let us now look at some popular NoSQL databases. Some popular NoSQL databases are MongoDB, Apache HBase, Cassandra, Redis, Neo4j, and etc. Let us now look at some types of NoSQL databases that are present. Firstly, we have document-oriented. The document database typically stores self-describing JSON, XML, and BSON documents. They are similar to key value stores, but in this case, a value is a single document that stores all the data related to a specific key. Popular fields in the document can be indexed to provide faster retrieval without knowing the key as well. Each document can have same or different data structure. MongoDB, CouchDB, CloudEnd are some examples of document-based NoSQL database. Next, we have key value pair database. The data in this is stored like a key value pairs. Key value pair data stored in database in the form of a hash table. Each key is unique in this case. The value stored may be an integer, a string, a binary object, a JSON object, etc. The key value store based database is simplest database among all the databases in NoSQL database. Redis, Coherence are examples of some key value store databases. Next, we have column-based or column store database in NoSQL, which is in this the data stored in grouped columns instead of rows. Every column values are stored separately. It delivers high performance on aggregate functions like count, sum, max, minimum. Group of columns data stored in key spaces like schema in RDBMS. Key spaces contains group of rows or columns, and HBase, Bigtable, Aculomo are some examples of column store databases. And finally, we have graph-oriented or graph store databases. Data in this is represented in the form of a directed graph. It consists of nodes and edges. Nodes represent an entity and any edge represents the relation between the two nodes. Node edge to be unique. Social networks, logistics, spatial data used graphical storage database. Neo4j, Infinite Graph, Orient DB, FlogDB are examples of some graph storage database. Next, let us understand how exactly NoSQL database works. For that, I'm going to take the example of MongoDB database. Now, MongoDB is based on the NoSQL document store model, in which data objects are stored as separate documents inside a collection instead of a traditional column and row of a relational database. Now, MongoDB groups data through collections, and basically a collection is simply a grouping of documents that have a same or similar purpose. A collection acts similarly to a table in a traditional SQL database. However, it has a major difference. A collection is not enforced by a strict schema, that is, it does not have any fixed schema at all. Instead, documents in a collection can have slightly different structure from another as needed. This reduces the need to break items in a document into several different tables as it is often done in an SQL implementation. Now, coming to document, a document is a representation of a single entity of a data in MongoDB database. A collection consists of one or more related objects. Major difference that exists between MongoDB and SQL in that documents are different from rows. Row data is flat with one column for each value in the row. However, in MongoDB, documents can contain embedded sub-documents, providing a much closer inherent data model for your applications. Now, if I just have to map what are exactly and how it is different from RDBMS, a collection in a MongoDB is equivalent to the tables in RDBMS, and a document in MongoDB is equivalent to the rows in RDBMS, and fields in MongoDB is equivalent to the columns in RDBMS. So this is how a document looks in a MongoDB. As you can see, this is similar to a row in RDBMS, but we just have a field and a value that is taken separately instead of a tabular value. And another important thing to note here is that MongoDB supports dynamic schema, which means one document of a collection can have a number of fields while the other document can have less or same number of fields. That is, if a collection can have 4 fields while other document can have only just 2 fields, which is basically not possible in a relational database, which does not exist. It does not support because it needs a particular and a fixed schema in that.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Let us now understand some differences between the SQL and NoSQL. Firstly, SQL is a relational database and NoSQL is a non-relational database. That means SQL databases are in the form of tables that can contain rows and columns, and they have fixed logical schema design. All the data in SQL is arranged in tabular format and it is well suited for complex queries. And on the other hand, NoSQL databases is a non-relational database. That means it does not store data in the form of tables and contains collections, and inside every collection there is a document that contains the data of a single entry. This data is stored in the form of a key value pair, unlike SQL where we store data under the fixed schema. So as we discussed, SQL has a fixed schema design and structure, and NoSQL has a dynamic schema design and structure. SQL can handle complex queries, whereas NoSQL can handle large volumes of data. Now, SQL is vertically scalable. Now, SQL databases support vertical scaling, which means it improves the single server by increasing RAM, SSD or CPU. In vertical scaling, we are restricted to a single system and we can improve it as much as we want till the practical limit. Whereas in NoSQL database, we can do horizontal scaling because they support distributed computing or distributed systems. In horizontal scaling, we can add another node or computer for better performance, and we can add n number of such servers or nodes as per a requirement. So as discussed, we can add as many as nodes as we want, and this is why we prefer NoSQL for high scalability, because there is no limit for scaling. And finally, it follows ACID properties, that is atomicity, that means transactions should be performed at once or it shouldn't happen at all. Consistency, that means the state of a database should remain consistent before and after the transaction. isolation. One transaction shouldn't affect another transaction and should be independent. And lastly, durability. Now, successful transaction should be reflected even if there is any system failure. Whereas the NoSQL follows CAP property, that is consistency, availability, and partial tolerance. Let us now discuss some advantages and disadvantages of using NoSQL. Firstly, let us discuss about the advantages. NoSQL provides high performance and scalability, and it also has a lot of availability and flexibility. It is open source and it is schema-less as well. That is, you can directly download the NoSQL databases from the internet, unlike some commercial databases that are available in the internet. While on the other hand, there are some disadvantages as well. That is, it lacks the standardization. That means it does not have a fixed query in order to retrieve data from the databases, which result in consistency issues. And since it has all these consistency issues and does not retrieve data properly, it has a limited query capabilities. So that brings us to the end of today's session on SQL versus NoSQL, guys. So you might have a doubt that when you need to use SQL and when we need to use NoSQL. Now, SQL is easiest to work with relational databases. That is, it is useful when you want to perform complex queries using various operations like join and etc. And if you want to perform quick data storage and retrieval operations, you can use SQL. Whereas you can use NoSQL if you are designing a distributed systems and if you want a hierarchical storage structure instead of a tabular-like structure. Also, NoSQL gives you the flexibility to create dynamic structures and can add features as you want. Also, there is no ACID properties during the creation of any applications while creating NoSQL databases as well.
If you're an aspiring data engineer looking for online training and graduating from the best universities, or a professional who elects to switch careers with data engineering by learning from the experts, then try giving a shot to Simplilearn's Data Engineering Postgraduate Program from Purdue University in collaboration with IBM. The link in the description box and the pinned comment should take you to the program being offered.
So let's get started with the first question. So the first question is to state the difference between where and having clause in SQL. Now, where and having are very widely used in SQL to solve specific problems. Now let's look at the difference one by one. So where clause is used to filter the records from the table based on the specified condition and can be used without the group by clause. On the other hand, having clause is used to filter the records from groups based on specified conditions. Now where clauses cannot have aggregate functions, so you cannot use sum, count, average, min and maximum functions in the where clause. While in the having clause, you can operate on aggregate functions, and those aggregate functions are used to filter values from a group. Now where clause is implemented on rows or at row level. So for each row of data, you have the where condition applied. Now having clauses are implemented on columns, so for each column of data you have the having condition applied. Now another important difference between where and having is that the where clause is executed before the execution of the group by clause and after the execution of the from clause. On the other hand, the having clause is executed after groups are created. Now we will learn more about where and having and understand the usage better when we tackle practical problems in this video. Now moving to our next question, which is how is drop different from truncate? So drop and truncate are two different commands. So drop command is used to drop the whole table, removing the table definition and its contents, while truncate deletes all the rows from the table. Now we can drop the whole table structure in one go, so the view of the table does not exist. By using the truncate command, the existence of all the rows in the table is lost, but the view in the table exists. Now integrity constraints will be removed in drop command, while the integrity constraints will not be removed when you use the truncate command. Now moving to our third question. Now this is a practical question. So we will be using a table which is present in my MySQL database. So the table name is called employees, and I want to find the lowest salary of the employees in each department. You can see here this is how my employees table looks, and the output query would be something like this. So here, since I want to find the lowest salary of the employees, so I'm using a min function to find the lowest salary in the table, and then I'm grouping all the employees and the results by department. So let's do this on MySQL Workbench. Okay, so here I am on my MySQL Workbench. First, let me go ahead and create a new SQL script. So I'll click on this, and that will create a new script. Okay, so here we'll write our commands. Alright, so our question was to find the lowest salary for each department. Okay, so I've given my comment to make my commands and whatever I'm doing more readable. So first, before I proceed, I need to select my database. So I'm going to use my SQL underscore intro database. So I'll write use SQL underscore intro. Now this database has a lot of tables that we'll be using in this interview questions video. I'll run it. Okay, we are in our SQL intro database. Now there is a table called employees. Let me show you the table first. If I write select star from employees, okay, so here you can see this is the table I'm talking about. Now these are the rows that are present in the table. We have 20 rows, and here you can see the different columns. We have the employee ID, employee name, age, gender. We have the department, city and salary. Now this is the same table that we have also used in our other videos that are already live on YouTube. Okay, so let's solve our question to find the lowest salary for each department. Now for that, I'll write select. I'll select my department column, which is DEPT, comma, and then to calculate the lowest salary or to find the lowest salary, I'm going to use the min function. So that will return the minimum salary present in the salary column. So I'll write min salary as I'm giving an alias name as, let's say, lowest underscore salary from my table name, that is employees. Then I'll write group by department. Now I'm grouping it by department because we want to find the lowest salary of the employees in each department. Now let's run and see the result. There you go. I'll just move it to the top so that you can see the results clearly. Okay, so here we have total 7 departments, you can see at the bottom, and in these 7 departments you can see in sales 70,000, let's say, dollars was the lowest salary. In marketing we had $55,000 as the lowest salary. Similarly, if I scroll down, we have other departments like tech, IT, finance and HR. So these are the lowest salary in each department. Alright, now moving to our next question. So our fourth question is, which query will help you fetch unique values from a column in a table? So this is a multiple choice question, which is another type of question that is often asked in the SQL interviews. Now we have multiple queries here, and you need to choose the right query that will solve our problem. So since I want to get the unique values from a column in a table, so the right option would be to use the distinct keyword in the query. So if I write select distinct followed by the column name, let's say you want to find the distinct cities or the distinct departments in the employees table, so the query would be select distinct city or let's say department from the table name, that is employees. Hence this is the right option if you want to find any unique values from a column. Now moving to the fifth question. Now the fifth question says, it is actually a similar question here. we want to write the SQL query to fetch unique departments from the employees table. So as we saw, this is our employees table, and if you want to find the unique departments from the employees table, you can just write select distinct, then followed by the column name, which is departments here, so DEPT from employees. Let's do this on our MySQL workbench. Okay, so let me just scroll down and I'll give a comment here. That is, we want to find the unique departments. So the query would be select, then I'll use the distinct keyword. If I hit tab, it will autocomplete. Then I have my column, that is department, from my table name, that is employees. If I run this, the query will give us the unique departments that are present in the table. So here we have total 7 unique departments in the table. You can see here we have sales, marketing, product, tech, IT, finance and HR. But if you see our original table, which is the employees table, so there are total 20 records, and if you see the department column, there are multiple departments to which each of these employees belong to. Okay, now moving ahead. Now the sixth question is to write an SQL query to fetch the unique values of departments and print their length. Now this question consists of two parts. First, we need to fetch the unique values of departments that we saw in our fifth question, and then we want to print the length of each of the departments. So for that, I'm using the distinct keyword to find the unique departments, and then I'm using the inbuilt length function that is present in MySQL to find the length of the department, and then I'm using an alias that is length underscore department from employees. So let's say this on our workbench. Okay, so let me give a comment. I'll say unique departments and length. Okay, so the query would be, I'll write select distinct department, and then let me just scroll down. I'll give a comma and use my inbuilt length function. See, I'm hitting tab to autocomplete, and inside the length function I'll give my column name, that is department. I'll give an alias as department underscore length from my table, that is employees. This is pretty simple. So first I'm finding the unique departments, and then using the length function I'm finding the length of each department. Let's run and see. Okay, you can see the result here. So sales, the length is 5. Marketing, the length of marketing is 9. So basically you're counting the number of characters that are present in each of the departments. So in sales there are total 5 characters, in marketing there are total 9 characters, in product there are total 7 characters, in IT we have just 2 letters I and T, so hence the length is 2. Similarly finance is 7 and HR is 2 because we have just 2 letters H and R. Okay, so this is another variation of using distinct along with any inbuilt function. Alright, now moving to the seventh question. The question is, what is the use of DateDiff function in SQL? Now DateDiff returns the number of days between two date or date time or timestamp values. So DateDiff is another crucial inbuilt function that is present in MySQL. So here is how you can use the DateDiff function. So it will return the number of days between two dates or date time or timestamp values. So here I have two date values, that is 10th of April 2021 and I have 30th of March 2021. So this query will give us the total number of days that lie between these two dates. And similarly, here is another example of using the dateDiff function. So I want to calculate the total number of days that are present between today's date, so I am using the now function, and between 20th of April 2021. So let's do this demo on the Workbench. Alright, first I'll give a comment saying dateDiff function. Okay, now the way to use is I'll write select, and then you can see here once I type date, MySQL Workbench is automatically suggesting some of the inbuilt functions. I'm going to use dateDiff, and within dateDiff I'm going to pass in two values. So I'm passing in two date values, let's say 2021 April, so I'll write 04, and let's say 10th of April. I'll give another comma, and I'll pass in my second date value, that is going to be 30th of March 2021. Alright, now another thing to note here is the date value should be present inside quotations. Now if you want, you can give an alias as well. I'll write as total days. Let's run it. There you go. It has given us the output as 10. So there are total 10 days between 31st of March to 10th of April. Now let's see another example. I'll write select dateDiff, and we'll pass in my now function. So the now function returns the current date, that is today's date, and I'll give another date value, let's say 2021 April 20th. Now we'll see the results. If you want, you can give an alias name so that the output is more readable here. I'll run it. Okay, so between today's date and my previous date, that was 20th of April, there are total 49 days. So today's date is actually 8th of June. So between 20th of April and 8th of June, there are total 49 days. Alright, now moving ahead. Now in the 8th question, we want to write an SQL query to display the departments that have more than 2 employees. So this is our employees table that we have been using, and here is how the command looks like. So here we are using both group by and having. Now I am grouping by department because I want to display the departments that have more than 2 employees. Now for the second filter, I am using the count function of the employee IDs and checking if the employees in each department are more than 2 or not. Let's do this. Let me move down a bit, and I'll give a comment departments with more than 2 employees. Okay, now let's write our query. So I want to select the department, and then I'm using the count function to count the employee IDs in each department, or the employees present in each department. From my table, that is employees, I'm going to group by department, and then I'll use having my count of employee ID. This should be greater than 2. So our query will return only those departments which have more than 2 employees. Let's run and see. There you go. So we have total 4 departments, that is sales, product, tech and IT, where we have more than 2 employees. You can see here sales has 4 employees, product has 3, tech has 4 and IT has 3. The rest other departments like finance, HR and others have less than 2 employees. Now if you want, you can give an alias as well. Let's say as total employees. Okay, let me run it again, and here you can see I have the column name as total employees. Okay, so moving ahead, the ninth question, we want to display the details of the employees for all the departments except marketing. Now here I have my employees table. Now if I were to display all the details of the employees apart from marketing department, I can give a condition like where department not equal to marketing. So this is the way how you write not equal to. So you use the less than and greater than symbol. Another way to do is use the exclamation mark and give equal to. So this means select all the employees where department is not equal to marketing. Now let's do this. I'll move down a bit and will give a comment as details of employees apart from marketing. So the query would be select star from employees. I'm using star because I want to display all the details. That means I want to display all the columns. Then I'm going to use my where condition where department not equal to marketing. I'll put marketing under quotes. Let's run it and see the results. There you go. So we have total 18 rows of information, and if you see the department column, we have all the departments apart from marketing. Now if you remember, our employees table had total 20 rows of information, out of which 2 are missing, which means there were 2 employees who were from marketing department and those departments were not displaying. Now another way to do is to use exclamation mark and equal to. So this also means select all the employees where department is not equal to marketing. Let's run this. You see here it gives us the same result and has returned us 18 rows of information, leaving apart the employees from the marketing department. Alright, now moving ahead. So our 10th question is to write an SQL query to print the details of the employees who have joined before April 2010 and after May 2005. So here is my employees table and this is my SQL query. So here we are using just a where condition to filter our results, and my condition is the employee should have joined after May 2005. So I have written after 31st of May 2005 and before April 2010, which is before 31st of March 2010. Let's do this. I'll give a comment here. We'll write employees joined before April 2010 and after May 2005. Now let's write our SQL query. So I'll write select star from employees where my date of join. If you see here, I have a column called date of join which has the details about the day on which the employee had joined the company. So I'm going to write where date of join is greater than 31st of May 2005. So I'll write 2005. This is one of the formats to use date values. So this is the year value, this is the month value, and this is the day value, and my date of join should be less than 31st of March 2010. So I'll write 2010 March 31st. I hope you were able to understand this. Date of join greater than 31st of May 2005 means after May 2005, and date of join less than 31st of March 2010, this means employees joined before 2010 April. Let's run it. Okay, so we have total 3 employees in our table. You can see the date of join, and all of them have joined after May 2005 and before April 2010. Okay. Now moving ahead to the 11th question. So here we want to find the employee with the third highest salary from the table. So I have my employees table here, and my command would look something like this. So here we are going to explore how to write subqueries in SQL. So I'm using a subquery here where I'm trying to find the employees who have the top 3 salaries, or the top 3 employees who have the highest salaries, and from that I'm going to filter out my third highest salary employee. So let's do it on our workbench. Okay, so I'll come down and let me give a comment as third highest salary. Okay, so let me first write down my SQL query and then I'll explain. So I'll write select star from. After that I'll start a bracket and write my inner query. So I'll write select star from employees order by salary descending. Then I'll use my limit keyword and I'll write limit 3 as I'll give an alias name, let's say T, and then I'm again going to use my order by salary limit 1. Okay, now let me explain you the flow. So first let me run the inner query. I'll select my inner query and I'll run it. So the inner query returns my top 3 employees who have the highest salary, and this is ordered in descending order since I used salary descending. Now let me just use this. Okay, now you can see it clearly. So these are my top 3 employees who have the highest salary. So Joseph has the maximum salary, followed by Angela, and then we have Jack. Now from this I want to return only the record for Jack, because Jack is the employee who earns the third highest salary. So for that I'm going to use the result returned by my subquery or the inner query, and on top of this I'm going to order the salary and say limit equal to 1. So I'm again ordering this salary in ascending order. So what will happen? Jack will appear at the top, Angela will be at the second place, and Joseph will come to the third place. And from there I'm using limit 1 so that I can only get the record for Jack. Now if I run the entire query, you see the result. I have my employee name as Jack who earns the third highest salary. Okay. Now moving ahead to the 12th question. The question is to print all the alternate records in a table. So here is my employees table, and from this table I'm going to print all the alternate records. For example, I'm going to print my employee ID 101, then I'm going to skip 102 and print 103, followed by 105, 107, 109. So all the employee IDs that have an odd value. And you can look at this example in another way of displaying the employees which have an employee ID of even numbers. So 102, 104, 106 and so on. Now the way to do is, either you can use a simple select clause and say employee ID percentage or modulus 2 equal to 0, which means I want to filter only those employees which have an even employee ID. Else, what you can do is you can use a CTE, as you can see here. So CTE, or the common table expression, is a temporary named result set that you can reference within a select, insert, update or delete statement. Now it is used to simplify complex joins and subqueries and to provide a means to query hierarchical data. Now let's write this query on our workbench and see how it works. But before that, let me explain you. I am using a few new functions such as row number. This will create a row number for each of the rows or the records present in my table, and then from this CTE I am going to use my filter clause or the where clause, where rn, which is row number, percentage 2 equal to 1. So this will return only the odd records from the table. Let's see how to do it. Okay, so I'll give a comment, print alternate records. Okay, now I'll start with my simple query, which is select star from employees, where let's say I want to find only the even employee IDs or the employees who have an even employee ID. So I can use employee ID percentage 2 equal to 0. So it has to be a perfect division and the result should be 0. Only then I can get only the even employees. If I run this, okay, there was an error here. It should be employees. I'll run it again. You can see here I have printed the alternate records in a table. So we have skipped 101 because it is not divisible by 2. I've started with 102, followed by 104, 106, 108, and then finally we have 120 or 120. Now if you want to print only the odd records in the table, you can use employee ID percentage 2 equal to 1. So you can see here I have 101, 103, 105, 107 up to 119. Now the best way to do this is to use a common table expression or CTE. So I'll start with my command, that is with CTE, as I'll start with my bracket, I'll write select star comma, then I'm going to use my row number function. So I'll write row number, then I'll write over, then I'll use order by employee ID. So this row number for each of the rows is going to be created over my employee ID column, and that is sorted in ascending order. I'll give an alias as rn, which stands for row number, from my table, that is employees. I'll scroll down and then I'm going to close my bracket. I'll write select, let me remove the space here. Okay, I'll write select star from CTE, where my row number percentage 2 equal to 1. Now let's see this from the top. So I have my common table expression where I am going to create a row number column named as rn, and this row number column is based on my employee ID column, which is sorted in ascending order, and from that I'm going to filter only those row number values that are not divisible by 2, or I'm going to print only the odd records from the table. So let's run it and see the results. There you go. So here if you mark, I have my row number column created and I am filtering only the odd records in the table. So it starts with 1, 3, 5, 7 and goes up to 19. And similarly here you can see the employee IDs, the name, the age, gender and other information. Now if you were to print the even records in the table, the alternate even records, you can use rn%2 equal to 0. Let's see the difference. I'll run this. There you go. So I have my even row number starting from 2 which goes up to 20. Okay, so this is how you can print alternate records in a table. Now moving to the next question. Now in the 13th question, we want to write an SQL query to fetch all the duplicate rows in a table. Now this is another crucial interview question that is often asked in most of the interviews. Now I have a table which is named as duplicate table, and here you can see I have some employee ID, name and age, and a few records are duplicated. For example, 101 Sam 40, the first record is duplicated, and you can see here it has the same values. Now if you mark 103 Mary and 28 is not duplicated because here the age is different, so this is a different person than compared to the third name that we have. So this is how you can find the duplicate rows in a table. So I'm going to select my employee ID, name and age, and then count all the employee IDs, the names and age, and compare them with whether they are greater than 1 or not. So if they are greater than 1, then I'll say that particular record is duplicated or is present more than one time in the table. Let's do this implementation on our workbench. Okay, so I'll come down and let me give my comment as duplicate records. Okay, so let me first show you the records that are present in my table. So I'll write select star from dup underscore employees. I'll run it. Okay, you can see here I have my table that we saw in the slides. So employee ID 101 with name Sam and age 40 is duplicated. So we want to find this duplicate record. The way to do is I'll write select e underscore id, which is employee ID, comma name, comma age, comma I'm going to count all of them. So I'll write count star as duplicate count. This is my alias name from my table that is dup underscore employees. I'll say group by employee ID, name and age, and then I'm going to use my having clause saying having count of employee ID is greater than 1 and count of name should also be greater than 1 and my count of age should also be greater than 1. Let's run it and see the results. Okay, there is some error here. The name of the table should be employees. Okay, let's run again. We have our correct result, that is employee ID 101 with name Sam and age 40 is duplicated, so the value is 2. Great. Now moving ahead. Now the 14th question is a bit tricky, wherein we want to display the employees with exactly 2 A's in their name. So you see here I have my employee names and there are certain employees who have just 2 A's in their names. So I want to find those employees only. Now the way to do is, it is a bit tricky to understand. I'm going to break it down and make you understand on my MySQL workbench. So here you can just have a glance. I write select star from employees where I am finding the length of my employee name and then subtracting my length wherein I have replaced my employee name that has A with a blank, and if this subtraction is equal to 2, then that particular employee has 2 A's in their names. So let me show this first. Let me first give my comment as employees with 2 E's. Okay. So first I'm going to write a select statement. Okay, before that I'll show you the records present in my table. Okay, if you see here, Shane is one of the employees that has just 1 A in its name. Then we have Mary 1 A, Dwayne has 1 A, but if you see Sarah has 2 A in the name, so we want to extract Sarah. Then Jack has 1 A. Again, if you see Angela has 2 A. It doesn't matter if it is uppercase A or lowercase a, we just need to find if the employees have 2 A's in their name. And similarly, if I scroll down, let me check if we have any other employee with 2 A's in their name. Marcus has 1, David has 1, Sophia has 1. We also have Amelia that has 2 A's in its name or in her name. And we also have Maya. Okay, now let me go ahead and write a SQL query, and then I'll explain you what I'm trying to do. I'll write select. I'm using the length function, and in the length function I'm going to replace, then I'll use another function called upper on top of employee name. I'll write A and then replace it with a blank. So I'm using quotations to represent blank from employees. Okay, let's run this and see the results. You see here it has given us the length of the employee strings after replacing all the A's with a blank. So here I'm essentially converting my employee names to uppercase, and I'm changing wherever there is an A, I'm replacing that A with a blank, and then I'm finding the length. So this trick I'm going to use in my final query. So I'll write select star from employees where what I'm going to do is I'll bring this to the next line. I'll write length of employee name minus, then I'm going to use my above condition. I'll copy this, I'll paste it here, and this value should be 2. So what I'm doing is I am first finding out the length of my employee name. From that I'm subtracting the length after replacing the A's present in the employee name with a blank, and this value should be equal to 2. The reason being we are only trying to find the employees who have 2 A's in their name. Let's run and see the results. Okay, if you see here we have Sarah, Angela, Amelia and Maya who have 2 A's in their name. So we have Sarah that has 2A, Angela has 2A, Amelia has 2 A's, and then Maya also has 2A. Okay, now moving ahead. Now the 15th question is, given a string, how will you extract 4 characters starting from the second position? So I have my string here which says Michael Ballack. Now Michael Ballack, you must be aware, is a popular footballer. He is from Germany and also was the captain of Germany. So from the string Michael Ballack, I am going to extract 4 characters starting from the second position. You can use 2 inbuilt MySQL functions to do this. The first is called substr, wherein we pass in the string, then we give the position from where we want to extract the characters. So here I am going to extract from the second position, so hence 2, and then the number of characters that you want to extract, which is 4. The other way is to use the substring function, which is again similar to the substr function. In the substring function also, I am first passing in my input string and then giving my starting position, which is 2, and then I want to extract 4 characters from it. Let's do it. I'll give a comment, extract strings. So here I'm going to write select. First I'm going to use substr, which is my inbuilt function. I'm going to pass in my input string, which says Michael Ballack, and then I'll give my starting position, which is 2, and then the number of characters, that is 4. Let's run it and see the results. You can see here it has given us ICHA. So if you see, M is at the first position. From the second position onwards, I needed 4 characters, so M, C, H and A. These are the 4 characters starting from the second position. Similarly, let me just copy this, and instead of substr, I'm going to use the substring function. I'll write just ing, that becomes substring. Let's select and run it, and this also returns the same result. Suppose you wanted to extract from the 4th position, you wanted to extract, let's say, 3 characters. Let's see the results. It gives us H, A and E. If you see here, M is the first position, I is at the second position, C is at the third position, H starts from the 4th position. So H, A and E are the next 3 characters starting from the 4th position. So hence this is the result. Alright, now moving ahead. Now my 16th question is on how does self-join work. So self-join joins a table to itself. So the table must contain a column X that acts as the primary key and a different column, let's say Y, that stores values that can be matched up with the values in column X. Now this might not be really easy to understand. You'll get to know once we do this demo. So I have a table which is called employee manager. So this is my table. Now let me tell you how to interpret this table. We have 5 different employees starting from employee ID 1 to employee ID 5. Gary, Gibbs, Smith, Latham and Jimmy are the different employees we have. You have their salaries, and now you have the employees reporting to which manager. Now if you see here, Gary's manager ID is 3. So if you see our table, at 3 we have Smith. So Gary is reporting to 3, or in other words, Smith has a employee under him who is Gary. Similarly, Gibbs is reporting to manager ID 1 or employee ID 1, which is Gary. So Gibbs manager is Gary. Similarly, if you see for Smith, Smith is reporting to the person with manager ID 4 or employee ID 4. We have Latham. So Latham has one employee under him who is Smith. Now Latham in our table has no managers. Then we have Jimmy who's reporting to the employee ID 3 who is Smith. Okay. Now I want to use this table and return the name of the manager for each employee. To do that, I am going to use my self join. So here I am using a self join to join both the tables. Here both the tables mean I am using the same table twice. So I have written select e.employee ID, e.employee name, then we have e.manager ID. Then I am using another alias for managers. So m.employee name as manager underscore name from employee underscore manager as e. This join means self join employee underscore manager as M on e.manager ID equal to e.employee ID. So this is my common column, that is employee ID or manager ID. Let's do it. Alright, I'll give a comment here saying self join, and I'll start with my self join. I'll write select. Let me first display my table. I'll write select star from, and my table name is emp underscore manager. I'll run it. You can see the table here. This is the same table that we saw in the slides. Now I'll write my join query. I'll write select e dot employee ID comma e dot employee name comma e dot manager ID comma, then I'm using another alias as M for finding the manager name. So M dot employee name as manager name. There shouldn't be any space in the alias name. Then I'll write from emp underscore manager as E join emp underscore manager as M on e dot manager underscore ID equal to M dot emp underscore ID. Let me run this and we'll see the results. There you go. So Gary reports to the manager ID 3. So from the table 3 is for Smith. So Gary's manager is Smith, Gibbs' manager is Gary, Smith's manager is Latham, and Jimmy's manager is Smith. Okay, so this is how you can use self join. Now moving ahead with our next question. So the 17th question is on which of the following is called a virtual table in SQL. So again we have a multiple choice question. So the answer is view. You can see here. So view is a virtual table that has rows and columns as they are in a real table in the database. Now we can create a view by selecting fields from one or more tables present in the database. Next, moving to the 18th question. So here we want to write an SQL query to fetch the list of employees with the same salary. Again, I am going to use a self join here, wherein I'll join the same employees table, and this is how my query would look like. So I am selecting distinct employee ID, so e.employee ID, e.employee name, e.salary from employees. Then I'm joining employees as E on employees E1, where e.salary equal to e1.salary, because I want to fetch the list of employees with the same salary, and I'm ensuring that the employee IDs from both the tables are different. Let's do it. I'll give a comment here and write employees with same salary, and I'll start with my query. I'll write select distinct e dot employee ID comma, I'll write e dot employee name comma e dot salary from employees as E, then employees as E1, where e dot salary equal to E1 dot salary and e dot employee ID is not equal to E1 dot employee ID. I'll give a semicolon and let's print the results. You see here we have Amelia, Bela, Shane and Sarah who have the same salary. So Amelia and Shane have the same salary of $55,000. Bella and Sarah have the same salary of $72,000. Okay. Now moving to the 19th question. So the question is to write an SQL query to print one row twice in results from a table. So I have a table here called employees and I want to print one row twice in the results. So to solve such kind of problems, you need to use the union all operator in SQL. So union all combines the result sets of two or more select statements. It does not remove duplicate rows. Between the various select statements, all the rows are returned. So let's say I want to print the employee name and department for those employees who are from the HR department. Now to do this, we can use the union all operator. You can see it here. So I'm selecting my employee name, the department from my table employees as E. Then I'm giving my where clause where E.department equal to HR. And then I'm using the union all operator. Then I'm again selecting my employee name, department from employees with another alias as E1 where E1.department equal to HR. So let's do this. Okay, so I'll give my comment as print row twice. Okay, now I'll start with my query. I'll write select my employee name, comma, the department from my table that is employees as E. Then I'll use where E.department equal to HR. Then I'm going to use the union all operator. So the union all will combine the result set of two or more select statements. Then I'm going to write select emp underscore name, comma, my department from employees as E1 where E1.department equal to HR. I'll give a semicolon. Now let's run it. There you go. You can see here Marcus and Sophia are from the HR department and we have printed them twice in our results. Coming to the next question. The question is, using the num table, write a query to add 10 when number is 0, 20 when number is 1, else print the number itself. So you can see here I have my table called num and it has just one column which is num ID or number ID. We have some numbers here and from these numbers I want to add 10 if the number is 0, 20 if the number is 1, else I would print the number itself. So to answer this question we'll use the case statement in SQL. So the case statement is SQL's way of handling if-then logic. The case statement is followed by at least one pair of when and then statements. So here you can see I have my case statement. I'm writing when case, my column name n underscore id equal to 0, then add plus 10. If it is 1, then add plus 20, else we'll just return the number id. Now let's do this. Okay, I'll give a comment saying using case statements. Okay, first of all let me display the values present in my NUM table. You can see here this is my table and there are total 12 rows of numbers. Now let's start with our query. I'll write select n underscore id, comma, then I'm going to write my case statement. So I'll use the keyword as case when n underscore id equal to 0. I'll use then n underscore id plus 10. I'll write when n underscore id equal to 1, then n underscore id plus 20, else I'll just print an id. Now I'll end my case statement. I'll write end as an alias name, let's say num underscore add, from my table that is num. Let's run and see the results. Okay, you can see here my first number was 0. So since it was 0, we have added num id or n id plus 10. So the result is 10. Now wherever the num id is 1, for example here we have added 20, so the result or the output becomes 21. Similarly here the value was 0, so we have added 10, the output is 10. And you see here again, here we had another 1, so we added 1 to 20, so the result becomes 21. And for the rest of the numbers, for example 3, we had 2, the values are the same. Okay, now moving ahead. So we have a table called num1, and using this table we want to write a query to find the sum of all positive values and the negative values. So let's see the table first. So this is my table, which is num1. You can see here we have a list of integers, and there are positive as well as negative integers. So for positive values and the negative values, we want to find the sum separately. So again, for this we are using the case statement. You can see here I have used two case statements. I'm writing select, and then I'm using the case to find if the number is greater than 0, which means it's a positive number. So I'm finding out the sum, and then I'm checking case when the integer is less than 0, so it's a negative number, and I'm finding the sum for the negative numbers as well. Let's do this. Okay, so I'll give my comment as add positive and negative numbers. Okay, so let's start with our select query. I'll write select. I'll use the sum function, and inside the sum function I'll use my case statement. So I'll write case when num underscore integer. Okay, before that let me just print the values present in my table. So I'll write select star from my table name, that is num1. Okay, so you can see here these are the values or the list of integers that we have. There are some positive as well as negative integers. Okay, let's continue with our query. So here I'm going to write case when num underscore integer or int, which is my column name, if it is greater than 0, then I'll return num underscore int. Else I'll say 0 and end my case statement. I'll give an alias as sum of, let's say, positive numbers. I'll give a comma. Then I'll use another sum function, and inside the sum function we'll use the case statement to find the sum of negative numbers or integers. So I'll write num underscore int if it is less than 0, then num underscore int, else 0, and I'll end. Okay, and I'll give another alias name as, let's say, sum underscore neg, which stands for negative. POS is for positive integers, and then I'll write from my table, that is num1. Let's run it. Okay, there you go. We have our results. So we have two columns, sum of positive integers and sum of negative integers. You can see the results 19 and -14 respectively. Okay, now moving ahead. Now in question number 22, we want to list the difference between primary key and foreign key. So as you can see here, primary key is something that can uniquely identify a record in a table. So if you consider a school database, a primary key would ideally be the roll number or the registration number of the student, because that is unique to all the students in a school. Now foreign key is the field in the table that is primary key to another table. So suppose you have another table called courses to which the students have enrolled to. Now if you have a roll number or a registration number column in the course table, that becomes the foreign key. Now the other difference is primary key don't accept or cannot accept null values, while foreign key can accept null values. Now you can have only one primary key in a table, but you can have more than one foreign key in a table. Now coming to the 23rd question, what is the difference between primary key and union? So you can have only one primary key in a table as we discussed in the previous question, but you can have more than one unique key in a table. A primary key column cannot have null values, but union can accept null values. Now if you assign a column as a primary key, you create a clustered index, and similarly if you assign a column with union, you create non-clustered index. Okay. Now coming to the 24th question, what is a check constraint in SQL? So check constraints are used while creating tables. Check constraint helps to limit or restrict the values that can be inserted into a column. For example, we have a table here, let's say dummy 1, and you want to ensure that every time you insert the age of people or persons in the table, you want to make sure that age should be always greater than 0. Reason being, a person cannot have, or an animal cannot have, or a tree cannot have a negative age. Similarly, you can set a constant for the salary column in a table to ensure that it is always greater than 0, because you cannot earn a negative salary, or it cannot be less than 0. Now we are going to create a dummy table on my MySQL Workbench and see how check constraints can be applied. Okay, so let's give our comment as check constraints. Alright, so I'm going to create a table called dummy, let's say underscore SQL. Now this table will have a few columns. First we have, let's say, EID, which stands for employee ID. The data type is integer, and I'm going to assign employee ID as my primary key. So I'll write primary key here. Okay, I'll give a comma. Next we'll have a city column. City column is of type var char or varying character. I'll give the size as 30, and here I'm going to apply my check constraint to this city column. I'm going to check the city should take only values as Mumbai. Let's say I'll have my final column, that is age. Age is of type integer, and here I'm going to check my age should always be greater than 0. So I'll write check age greater than 0. Okay, so our dummy SQL table has one primary key constraint, and we have applied two check constraints on city and age column. Let's run this. Okay, so we have created our table successfully. You can see it here. Now let's insert a few records and we can see the difference. I'll write insert into dummy underscore SQL. I'll write values. I'll have my employee ID as 101. I am giving my city as Mumbai, which is what we want. And let's say I'll give my age as 10. Now this should perfectly work because my city is Mumbai and my age is greater than 0. So I should be able to insert this record successfully. You can see here I have inserted this record to the table. I'll write select star from dummy SQL so that you can check. Let's run it. There is some mistake. I should write from. Okay. Let's run it. You can see it here. We have one record or one row returned. Now let's say we'll insert another record. And this time I'm going to give my employee ID as 102 because it has to be unique. And this time instead of Mumbai, I'm going to give my city as, let's say, Delhi. So I'm not following my check constraint where I am supposed to give only Mumbai. I'm purposely giving Delhi here to see the difference. If I run this, let's say we'll have age is 40, which is greater than 0. Let's run it. You see here we get an error saying check constraint dummy underscore SQL underscore check is violated. Similarly, let's say I'll change this to Mumbai again, and instead of 40, let's say I'll give us minus 30. So your age can never be in negative numbers. If I run this, I get the same error. My check constraint has been violated because age should be greater than 0. Okay, so this is how you can use check constraints in SQL. Now coming to the 25th question. So given two tables A and B, we want to write a query to fetch values in table B that are not present in table A. Now to answer this question, you can use the left join. So what left join does is, it returns all the rows from the left table and only matching rows from the right table. And I've used my condition as a.id, which is in the right table, should be null. Let's write this query on the workbench. Okay, so I'll give my comment using left join. First of all, let me display my tables. I'll write select star from A. If I run this, I have the IDs. There are total 5 IDs in table A. Similarly, I'll copy this and we'll see the values that are present in table B. So again, I have 5 values. There are a few non-matching values as well. So I want to return those non-matching values that are not present in table A. So for that, I'll write select ID from table B. I'll use left join A using my ID column. This is another way to give the condition, or you can use the on operator. Then I'll give where a.id is null. Let's run and see the results. There you go. So 150, 200 and 75 are not present in table A but are present in table B. Okay. Now moving ahead. So now we'll look at the last set of 5 questions. So these questions are based on the popular Northwind sample database provided by Microsoft. Now there are several tables in this database, So we have an order table, customers, employee, products, a region table and others. We'll use our Microsoft SQL Server to solve the 5 questions. So my next question, which is based on Microsoft SQL Server, the question is, using the Northwind database, find the customers who don't have any orders. Okay, so I am on my Microsoft SQL Server Management Studio. So this is how the interface looks like, and here you can see I have a list of databases. Now to solve the last 5 questions, I'm going to use the Northwind database. If I expand this, I'll click on the plus sign. You can see there are a lot of tables that are already present in the database. You can see here we have customers, employees, employee territories, order details, orders, products, region, shippers, suppliers, territories and more. Okay, let me just collapse this. Alright, so to write my queries, I'm going to create a new query file, and here you see I am currently on my master database. I'm going to change this to Northwind database so that we can utilize all the tables that are present. So my 26th question was to find the customers who don't have any orders. So for that, I'm going to use 2 tables, customers and orders. So let me first give a comment saying customers with no orders, and now let's go ahead and display the columns that we have and see the records present in the tables customers and orders. So first I'm checking all the columns and the rows present in the customers table. I'll execute using this button, or you can hit F5 as well. Okay, you can see here there are total 91 customers. These are all unique customers. You have total 91 unique customer IDs. You see here the company name of the customer. You have the contact name, the contact title, address, city to which the customers belong to, then the region, postal code, country, phone, fax number. Okay, now let me just copy this query, and now we'll check for the orders table. I'll write select star from orders, and let's execute it or run it. Okay, so there are total 830 rows of information. So there were total 830 orders or order IDs. We have the customer ID. Now this customer ID is actually the foreign key for the orders table, but for the customers table, customer ID is the primary key, and in the orders table, order ID is the primary key. We also have the employee ID. Again, this employee ID is the foreign key for this orders table. We have the order date, we have the required date, ship date, ship via, which means by which medium the order was shipped. We have the freight charges, ship name and ship address as well. Then you have the city from which the item was shipped, the region, postal code and the country. Okay, now let me use the distinct keyword. I'll write select distinct. I want to find the distinct customer IDs from my customers table. Let's run and see how many unique customer IDs we have. So there are total 91 customer IDs or customers. Now let's check for the orders table. Let's run it and see the difference now. If you see here, there are total 89 customer IDs in the orders table, which means there are 2 customers missing from the orders table, and that implies those 2 customers don't have any orders. So to get the result, I will use 2 different queries to derive at the same output. So I'm going to select my customer ID from my table, that is customers, I'm going to use where my customer ID, and then I'm going to use the not in operator. I'm going to use a subquery select customer ID from my orders table. Close the bracket and I'll give a semicolon. Now what this query essentially does is, it is first going to find all the customer IDs that are present in my orders table, and in the outer query we are only going to return the customers that are present in both the tables, and we are going to exclude those customers which are not present in the orders table. So let's run and see the results. We should get 2 customer IDs. There you go. So these are the 2 customer IDs which are present in the customers table and are not present in the orders table, meaning that they don't have any orders in their name. Now there is another way to do it, that is to use the not exists operator, wherein you can write another subquery to get the same result. We'll leave that to you. You can try this out using the not exists operator as well. Coming to the 27th question. Using the orders table in the Northwind database, we want to find all the month-end orders. So such problems you will face while dealing with sales data. So very often sales executives would try hard to meet their month-end targets. We want to display all the orders made on the last day of the month. So let's solve this question on our Microsoft SQL Server. Okay, so let me first give my comment for the 27th question. So the question is to find all the month-end orders. So I'll just write month-end orders. Okay, now to get the month-end orders, we are going to use a built-in EO month function which stands for end of month. So let's start with the query. I'll write select. We are going to select the employee ID, comma, I also want the order ID, and we want the order date from my table, that is orders. I'll then give my where clause. I'll write where my order date equal to, and I'll use my inbuilt function, that is end of month. I have hit tab to autocomplete, and inside this function I'll pass in my order date column. Then I'm going to use the order by clause. I'm going to order it by employee ID and the order ID. I'll just move down and hit tab. Okay, let's run the query. There you go. We have got 26 rows of information. You see on the left side we have the employee IDs, the order IDs, and then we have the order date column. Now if you mark the values present in the order date column, these are all the end of month date values. You see this is 28th of Feb, then we have 31st of July, we have 30th of June, so on and so forth. So these are the list of all the orders that were placed on the last day of the month. Now coming to the 28th question, we want to find the top 5 countries with the highest freight charges in the year 1997. So freight charge is the amount paid to a carrier company for the transportation of goods from origin to another location. The freight charge is calculated based on the mode of transportation and the distance between the pickup place or the pickup location and the destination. So let's try this out on the Microsoft Server Management Studio. Okay, so let me go ahead and give my comment. So since we want to find the top 5 countries with the highest freight charges, I'll just give my comment as highest freight charges. Okay. Now to solve this question, I'll just change this to GHT. Okay. We are going to use our orders table. So the way to do is I'll write select. I'm going to use the top 5. So top is another keyword or an operator. So I'm going to find out the ship country, and then I'll calculate the average freight prices. So I'm going to use the average inbuilt function on top of my column, that is freight. I'll give an alias as, let's say, average freight. There should be no space. I'll give a underscore. I'll write from my table, that is orders. I'll use my where clause where, and then I'm going to find the year from my order date column, and this year should be 1997. I'm going to group it by my ship country, and I'll use order by my alias name, that was average freight, and in descending order I'm going to sort it. Let's see the top 5 shipping countries who have the highest freight charges. These are the results. You have Austria, Switzerland, Sweden, Canada and Ireland, and here you can see the average freight prices sorted in descending order. Okay, now moving ahead to the 29th question. So here we want to display the total number of products in each category. So we have two different tables, products and categories. So both these tables we are going to use to find a solution to this problem, that is to display the total number of products in each category. So first let me give my comment to display the total number of products in each category. I'll just write print total products. Okay, so to solve this problem we are going to use our two tables. So let me first display the rows and columns from both the tables. The first table is products. Okay, it is products. Let's run this and see the columns that we have in this table. Okay, so you have the product ID, which is the primary key. You have the product name. So there are total 77 different products. Okay, and then you have the supplier ID, you have the category ID. So these two columns are the foreign key columns. You have the quantity per unit, unit price, units in stock, units in order, and if you want to reorder some product to fill in the stocks, so you have information for that as well, and if the product has been discontinued or not. I'll copy this and let's see what rows and columns we have in my categories table. Okay, let me execute this. Okay, so we have total 8 categories of products. You can see beverages, we have dairy products, meat or poultry, you have produce, seafood. These are the description. Okay, now to find the total number of products in each category, I'll write my query as select. I'll write category name, comma, count star. I'll give this an alias name as total products. Give an underscore and write products from my first table, that is products. Give an alias as P. I'm going to use an inner join with my categories table, and I'll give my alias as C on my common key column, that is P dot category ID is equal to C dot category ID. Then I'm going to group my results based on the category names. So I'll write category name, and we'll use the order by clause. I'll write order by count star as descending. So let's see the total number of products that we have in each category. So this shouldn't be as descending, should be just count star descending. Okay, I'll select and run it. There you go. So here on the left hand side you have the different category names, and on the right you have the total number of products that belong to each of the categories. Alright. Now moving on to the final question. So the last question is to use the Northwind database, and using this database we want to find the list of late orders for all the employees. So this is a real world problem that often occurs. So the shipment of your orders might get delayed due to logistic issues, or if the products are not available on time. There can be various other reasons as well. So here we want to find those orders for the employees where the required date is less than the shipment date. So we are going to use two different tables, that is orders and employees. Okay, now let me give my comment for the final query that we are going to write in this interview questions tutorial. So using the orders table, I want to find the list of orders for all the employees. So I'll just give list of late orders, not just orders, for employees. I write EMPS, which stands for employees. So here I'm going to use two tables, orders and employees. Orders table we have already seen. Let's see the rows and columns that are present in the employees table. I'll write select star from employees, and let me run it. Okay, so there are total 9 employees we have. So we have the employee ID, this is the primary key column which goes from 1 to 9. We have the last name of the employee, the first name of the employee, we have the title, then we have the title of courtesy, whether doctor, Mr., Mrs. We have the birthday of the employee, the hire date or the date of join. You have the address, city, region, postal code and other information. Alright, so let's see how you can join the orders table and the employees table to get the list of late orders. And we must remember that late orders are those where the required date is less than equal to the shipped date. So I'll start with select E dot, I'll write employee ID, comma, I want the first name, comma, I'm going to count star as late orders from my table orders as O. Then I'll use my inner join. I'll write employees as E. It doesn't matter actually if you use small e or capital E. Then I'm going to use my on condition on E dot on E dot employee ID equal to O dot employee ID. So this is my common key column that is present in both the tables. Then I'll use my where clause where. Now you should be careful and you should give the right clause. So my required date should be less than or equal to my shipped date. So this is my condition, and then I'm going to group by E dot employee ID, comma, E dot first name, and then I'll use my order by clause, order by my alias name that was late orders, and I'll arrange it in descending order. So let's run this and see our result. Okay, so you have the employee IDs on the left, then you have the first name of the employee IDs, and then you have the late orders for each of these employees. So if you see here, employee ID 4 has the highest number of late orders, followed by employee ID 3 and 8 as well as 9 who have 5 late orders. Then we have the employee ID 2 which has 4 late orders. Even employee ID 7 has 4 late orders. Employee ID 5, that is Steven, has only 1 late orders. So we are done with our demo section and we have covered all our 30 questions, out of which 25 questions were based and used on MySQL server. And to address the last 5 questions, we used our Northwind database that had a lot of tables. You can see it here, and using those tables we solved some interesting questions.
And with that, we have come to an end of this session on Advanced SQL full course. If you have any queries regarding any of the topics covered in this session, or if you require the resources that we used in this session, like PPT, code documentation, please feel free to let us know in the comment section below, and our team of experts will be more than happy to resolve all your queries at the earliest. Until next time, thank you, stay safe, and keep learning.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.